I welcome you all to our very first session of handling equations after so many people requesting. But I'm heading it as quadratics because it's not all about quadratic equations. We have a lot of things in quadratics. And why I'm calling it a one shot, it's motivation for me to cover 90% of everything. Of course, 100% is always hard. And I always leave you with some research work, you know that. So one shot meaning that I'm going to cover all basics that you need in the topic. So be here knowing that we are now moving for 4 hours minimum. Okay. So be strong enough, but I'll give you some little breaks. Okay. So as usual, before we even look at what the syllabus really wants us to learn, we are going to first give a minute to our sponsors for the free class. Yeah, because we have so many new students here. I've seen them in the chat trying to request for classes which are already on YouTube. Someone requested for indices, logarithms, but those things are there. That means in each and every class we get new people. So we always use the first 5 minutes to have a bit of the introduction about our sponsors. So let me talk about them briefly so that people get to know who that my identity maybe, if I can say that briefly. Okay. So about us very fast. I told you that you can simply call me Dr. Paul, or you can just call me Doctor. So the sponsors for this free class, it is Science Scholars Academy, as I've already told you, and that is their logo. So they are the ones that have sent me here to take you through this class of pure math. Yeah, for me, I still call it pure math because, yeah, it's right. There are topics that are to do with application, but for your curriculum, it is strictly Math 1 and Math 2. So I'm here to take you through a topic, quadratics of Math 1, paper 1 of principal mathematics, okay? So they have sent me, and as I've always told you that their vision, mission, their aim is to create competent science scholars in the country, and they only provide 3 programs. Outside that, they don't provide. Don't look for them to give you relationship advice because you never know. Even some of them are really going through a lot as far as that sector is concerned. So you're supposed to strictly concentrate on the 3 services. Yeah. Now, the very first one is holiday program. That is compulsory to all science students of the country. And that one is 100,000 whole combination with revision of the subsidiaries, sub-ICT, sub-math, and general paper, which is compulsory to all students of the country. Is it okay? That is it. And what is done during this program, work for the previous term is revised and work for the next term is covered. That's what is always done. Okay. Then the homeschooling program for those who don't have fees, for those with fees issues, for those who don't want to attend school and just want to go in senior 6 and do papers. Our homeschooling program does not exceed senior 5 because you're supposed to benefit from that school pressure that comes in the candidate class. Okay. It's also for those who have health issues and any other issues, okay, that don't really allow you to be in school. So many, we handle them, whether religious, whether cultural, any issue stopping you from attending class, attend from home. Then the other free services, it is consultation, advice, and counseling. Most of you have used this in a very bad way. You're inboxing asking for advice, but your issue is actually related completely to laziness. Someone came and told me, Doctor, you said you do counseling. I said, yes, what's your issue? Someone said I'm allergic to reading ever since I started senior 5. That is laziness. For me, the things I want is someone telling me that even if I read for 3 times, I don't really get the point. I read it 5 times, but after 2 days I've forgotten. That one is trying. But you come and say that you're allergic to books and you chose BCM, you chose PCB, you chose PCM. That is complete. I can't even reply that message. So as you're really seeking advice, seeking counseling and so on, please be real. And as you're consulting our different consultation helplines, first give in your trial. You cannot be consulting and you send a consultant 20 questions and you be like, Doctor told us we consult, give me answers to those things. At least consult, you tell a person, I reached this step, I got confused, I thought of this, but it didn't work out. What of things like that? So be cooperative, but in a consultant way. Let me hope we are together. You're consulting, but you're being cooperative with the consultant. There, you really keep them for the rest of the time. But the moment you bias them, they will not help you. And we are here for 2 years, so we are supposed to do the needful. Every step we take should be calculated. Okay? Understand the risk of whatever you're taking. Let me first stop there, because when I start advising students, I don't stop. And I be telling them facts, things they do. And we are here for quadratics. So I don't want to extend from a 6-hour lesson to maybe 8 hours. I really don't want that. So what we do, at least by now, I believe you know that it is strictly online video classes of biology, chemistry, mathematics, physics, things like that. Okay? Now, if it's a live class like this very one, it is via Zoom. If it is free, we record it and even post it on our YouTube channel, even on the application. If it's not free, then you can't see it here. If you see it, it can be accessed, unfortunately. Okay. So I told you that ICT and GP revision is there, and the recorded work since 2015 is available, fine-tuned and made available to whoever really wants to do what? To access. Are we together? Then also the summarized work. Okay. Very available for the students really join premium. So I always tell you we don't sell notes. Those who inbox saying sell this, no. I told you I will send you to the SSA bookshop and you buy. There is the online one and physical one. Yeah. It is okay to get in touch with this contact, but only in holidays. Yeah. But to really be sure of that you're going to be worked on, I just simply use this number 0753 to reach out on anything that you may be interested in. So thank you for the chance to talk about our sponsors, and let me hope you've taken the advice, as I've said. So the channel is there, Science Scholars Academy on YouTube. You go and check on the sample classes there. You watch, you surely benefit, that I guarantee. Okay? I give you a warranty for the 2 years at a level that you will make it. So I've told you, you can simply just call me Dr. Paul, for those who have just really logged in, or just doctor if you want. Now, this is the workbook that we are going to use for today. And before I even go any further, let's see what the syllabus book, let's see what NCDC commanded us, the tutors, to really take through the students, to really ensure that by the end of this chapter, by the end of this branch, by the end of this topic, students know this, and this in the topic. Are we together? So as far as the syllabus book is concerned, someone may be like, but doctor, you're very disorganized. It is topic 2, we have seen that. But topic 1 is linear and simultaneous. But you're wiseacring and you're stupidly going to topic 2, yet you've not covered topic 1. Let me tell you, we have simultaneous equations that reduce to quadratic ones. Are we together? So I thought it wise, and the simultaneous equations, I know you people know them. They are very cheap. The ones that may be a bit hard are those of the 3 unknowns. Galaxy, kindly leave that screen if you want peace with me. So they are simultaneous ones that reduce to quadratic ones, and they are the ones that are very hard. So before we handle them, I really wanted to first handle quadratics, then we later go to the linear and simultaneous. Because I know if people really have issues with simultaneous, I just think the issue is with a row reduction to echelon form. That's what I think. Okay. And maybe some sort of information about matrix operations. I don't know if people looked at matrices in O level, but we shall see all that. So we are beginning with this topic, subtopic 2, under a considerate point of view. So we considered a lot of things for us to decide that let's cover this first. So let's see, what are we going to cover today? Remember, it's one shot, that all the basics you need, all whatever you need to understand in this topic, we are doing it today. I will not stop talking. I will not leave the place unless I feel like, yeah, students are ready to go and really battle the topic and do a lot of scenarios. Okay. Now, the very first thing, what are we supposed to do? We are supposed to solve the quadratic equations using the different methods. Factorization, I know it's a problem to solve. Completing squares, I know it's a problem to many. Quadratic formula, I know some of you are really well conversant, but you have different issues. Are we together? We are supposed to learn how we can express the roots as sum and a product using coefficients of a quadratic equation. Then we should also be in position to formulate quadratic equations. This is a full topic, but these people of NCDC just put it at something so small, but it is really serious. It's called roots of a quadratic equation, and we are going to do it today. So you tighten your seat belts. Are we together? What are they adding? They are saying we should also do what? Let me see. Solve simultaneous equations that have linear, non-linear terms, logarithms, and equations reducing to quadratics. You understand? So that's why I'm like, don't worry. Let's first handle quadratics. Then later we can look at the simultaneous that reduce to quadratics, so that I cover simultaneous at once. I don't want to say, let's cover simultaneous, and then I tell you, when I cover quadratics, we shall again go back to simultaneous ones that reduce to quadratics. No? After all, we don't have quadratics that reduce to simultaneous. Why not quadratics first? Okay? Then they are saying, apply the method of completing squares to do what? To determine the maximum and minimum value. One of my friends wanted to learn that today, and we are going to do that. So there are these last two parts that I saw. They are saying, represent the information graphically quadratic curves. Quadratic curves are they are best covered under a topic called curve sketching 1, which is an application of differentiation 1. Those who already have access to the premium drive, that work is there already. Yeah, that work is there already as far as that is concerned. Maybe briefly, if I can give you the directions, because I believe people may need them, because I know a good number of people who are online right now have access to the drive. So I may really want to, okay, let me share my screen briefly. I've told you that that part is covered well. I don't want anyone to say, Doctor, you're leaving out a learning outcome that was said by NCDC. Who are you to go against it? I'm not anyone, but this is the reason. When you go here, so this is principal math, so senior 5. Sorry, that topic here, it is senior 5 and it is term 2, if I'm not mistaken. Yeah, have a very good memory. So differentiation 1, how do you see? There is the part of basic differentiation. Are we together? That's where we have the classes. This is basic. Then we have this part of application. So that's where you're supposed to go, and then you find curve sketching. You can even see that we have something like minimum and maximum value of a function. And it is one of the things still under this topic we are covering today. So remind me in the future, yeah, that doctor, he told us that this part of quadratics, it's really, especially during revision time, that is 2027. Are we together? Now, this part of representing the information graphically, we shall see that. Okay? Then, verifying the nature of roots are using the discriminant. I'm going to say something about it today. And then we shall see our next stop. We see the research, we get assignments, and we shall be done. Whatever I've said, we are going to do it today. If you're learning for the first time, tighten your seatbelts, because I'm not leaving class unless it is done. So this is quadratic equations, strictly and strictly one shot. One shot meaning when I'm done, we leave the class. Okay, now, what are quadratic equations? Let me hope no one really has a question. I need 5 people in the chat to tell me that we go. Sir, sorry for the interruption. Is it okay for some math students to attend this lesson? It is very okay and wise. Very wise. Yeah, these are general things, because we even solve quadratic equations in chemistry under those topics of physical chemistry. In biology under genetics, there is when you solve, you find something that looks like a quadratic equation. You see that under what they call the Hadewin-Burg's principle. Okay, so this is everywhere. In physics, it is the order of the day. So it is actually wise. So quadratic equations, it is general math. So I need about 5 people in the chat to tell me that we are ready, that doctor, let's start. We are set. No questions. Are we all set? Are we all set? Are we all set? Are we all set? Okay, that is good. That is enough. That is enough. That is enough. Thank you all. Now, you really need to appreciate a lot of things. It is quadratics. So you really need to know what are we really going to be dealing with here. Those of you have covered polynomials because you also covered them and completed them. There is what we call a degree, and a degree is very important. I told you indices, and you know what a power is. Are we together? Now, a power may help us realize the degree that we may have. Are we together? Now, I want to put for you, so the introduction is going to be very brief and very disorganized. Uh, okay, this is 2x power 4, this is plus 3x power 3, maybe minus 5x power 2 plus 6x, this minus 5 equal to 0. Then I may have x power 5, it can even just be plus 17, also equal to 0, anything. Yeah? Then we can have 3x squared, we can have plus 5x, we can have minus 6, we can have equal to 0. Are we together? Then I can also have something here, as in maybe 4x power 3 minus, can have 6x squared. You can even stop there and say maybe equal to 5, anything. But when they are equated to 0, it is always better. Now, I want you people to tell me, I'm going to label them as A, sorry, 1, 2, this is 3, and this is 4. Are we together? I want you to tell me in the chat which one is the quadratic equation among all of them. Don't panic. We can have more than one. All of them can be quadratic. Only one can be quadratic or none. So I want you to reason well. You guys have a point of really panicking. Don't panic. Think twice. Okay? Think twice. You see, people are giving a lot of reasons, a lot of funny reasons. Yeah, but thank you so much. I believe most people have chosen number 3, and you people are choosing that for a reason. I want us to introduce the topic together. Now, okay, you've chosen 3, most of you. So I believe you're having something in common that you're really relating to say that. Could you also please help me and write the reason in the chat? This is the first and last question I'm asking. So let's take our time. Tell me in the chat, because I'll always remind you that when we recheck examples. 3 because the larger degree is 3, really 3. You tell me the reason in the chat. Why are you really going with that? Why are you choosing equation 3 as the only quadratic equation there? Because it has linear factors. Its higher power is 2, the unknown is power 2, its degrees in 2 because it's having a square. Yeah, that is really nice. Thanks for the trial. Thanks for the trials. Thanks for the trials, people. Okay, that's enough. At least we have introduced the topic together. So people are saying that this is not quadratic, this is not quadratic, not quadratic, but you're saying this is quadratic. And people are really basing on mostly that the reason is because of that. Someone is like, because the unknown has the power 2. But also this is unknown, it's having power 1. That's why someone said higher power. Higher power may be right, but I don't support the English because higher is comparative. You need to be comparing only two things. But even this x is this 6 is having x with the power 0. So the powers are more than 2. So supposed to use the right language. Okay? So it's better you say the highest. So the highest power we are having is a 2. So those equations where the highest power is a 2, I want you to listen to me very well. We can have those where the highest power is just a 1, just a 1. For example, if you're having 2x plus 3, Okay, here the highest power, I'm going to be using orange for the highest powers. Here it is only one like that. So here the highest power is 1. So that's why we call these ones linear ones. Okay? Oh, this was said when I was teaching polynomials. And I've given you a reference. Okay? When you look at this equation, this one, it's having power 3 and power 2. The highest power here is a 3. That means here the degree is 3. Even here where 1 was the highest power, the degree was 1. So when I said degree, have it in mind, doctor means highest power. But we don't need that here. But we shall need it as we are pressing the calculator. So I don't want you really to forget that. Are we together? So these equations have the highest power as what? 3. So we can say that equation is to degree or is in degree 3. And those equations are called the cubic ones because of the 3. These ones where the degrees 1 highest power is 1, they are linear. Now these ones where the highest power is 2, they are the ones we call the quadratic. Okay, and we are right to say degree 2. That's why as we are pressing our calculator, we shall see where that degree will really help us. Are we together? Then lastly, to give you some sort, I'm going to say, don't worry. Then these ones, when you look at now this first one, the highest power we had was a 4. Are we together? So that means the degree is 4. And those are what they call the quartic equations. Quartic equations. So the research I'm really giving you is to go and make research. These ones where the highest power is 5, what is their name? Those where the highest power is 6, what's their name? I'm giving it to you as research because because I know people are not going to look for it. And after all, it's not examined. I also leave that to you. Okay? So that is some sort of introduction. So when you think you're dealing with quadratic, yet you're not having degree 2, then you should always think twice. So all the principles you're going to learn today, make sure before you apply our principles, you've ensured that the degree in place is degree 2. Are we together? Okay, we are going to see the format of these quadratic equations and so many things. Backhouse has a very good introduction. Backhouse is a good book for teachers. As a student, only go to Backhouse to pick numbers. Don't depend on it as maybe a student-friendly one. Are we together? Uh-huh. Someone may be like, okay, we understand the other things of cubic theory. We know cube is theory. But how really, and how do you really convince us that quadratic really means power 2? So very fast. There is a word that is called quadratus, very important word. Quadratus, and this word is a Latin word. Even when you ask Google, what is the meaning of the word quadratus? Google will tell you that quadratus is a Latin word meaning square. Okay, so in Latin, when you say quadratus, for them what they will get is square. And here in Uganda, when you say something is squared, we also interpret it as power 2. You all know that, not so? When I have something like this, there is someone who is going to read it as x squared in primary, but as you progress, we just say x power 2, it is also fine. So x power 2 is x squared. Quadratus means square. So this is how things connect. That's how they connect. So, whatever we are going to be dealing with, that is the format. Before I even tell you what quadratic equations really look like, we really need to know how quadratic expressions look like. And you people have already voted for that. So I'll begin by writing for you how a quadratic expression really looks like. So I'll say quadratic expression, yeah? So that I don't write it and then people ask me, what is that? What is that? Those who know these things will forgive us. With the introduction, we take our time to secure our future. So this is how it's going to be looking like. Quadratic expressions look like this. We have a, are we together? Then we have the basic x, are we together? Then we have our power, a 2, are we together? Then we shall have plus. Someone may be like, why not minus? Is it really always like that? I'm going to communicate. So we have b, are we together? Then again, our x really comes here, are we together? Then we shall have our plus, a c, and that's where I'll stop. This is how they look like. I want you to note. Now, this is the disclaimer. This is the disclaimer. So you're supposed to take note of this. A can never be a zero. Are we together? Because let's say A is zero. When A is zero, someone will be like, why? Let me first maybe tell you this so that people can really get the urge to learn why B can be zero. So I'm going to be like, B can be a zero. B can be a zero. It is very okay. It can be a zero, but A cannot. Are we together? Because let's say A is zero. Let's say if A is zero. If A is zero, you will have zero. Then here you will have x squared. Are we together? Then this will be bx. And this will be plus c. Are we together? This is how this one will become. It will remain as bx plus c. And this is non-quadratic. We have already agreed that this is linear. Someone may be like, why is that really linear? It's linear simply because the highest power we have here is 1. Because that is x and x is to power 1. So the degree we have there as the highest power is 1. So that is linear. So the moment a is 0, it ceases from being quadratic and it becomes linear. So a can't be 0. But we are saying that b can be 0. So what if b is 0? Let's see what is really going to happen. So we shall have our a x squared, our b is a 0, our x shall stay, then here shall be plus c. So this shall reduce to still x squared plus c. So this one is also okay. Why is it still quadratic? Because the highest power in place is a 2, so it's quadratic. So have that in mind. Even the c can be a 0. The concern or the problem is on this a of ours. It shouldn't be a 0 even at any one what? At any one point. So very fast. The syllabus wants us to, I said one shot. When I say one shot, I don't even need to give you lesson targets. I said it clearly. We are doing 90%. So the target is 90% of the topic. We are together? So the first thing they want us to solve. But me, I believe if one of the methods of solving is really factorization, isn't it really wise we first look at maybe how best we can factorize? And then maybe we can see other things later. Yeah, we can first see how can we really factorize. Yeah, and then we see how to progress. So now the math has started. Those who have been tired of the literature. Now, the very first thing. So at this point, maybe I can give. There are people who are obsessed with how our classes begin, and they are really not settled because we don't have targets. So the target, I've told you 90% because 100% is really hard. Okay. Just one target that is 90% of the topic, and I want us to do factorization. And as we do factorization, I want us to do everything about it. Are we together? Then the other thing, I want us to solve equations. Okay. A lot of people requested for that. And as we solve equations, I also want us to use everything. Okay. Then those are the basic things actually. Because even as we are completing squares, we first factorize, then we solve. Okay. And then I'll be like, and some sort of miscellaneous. Then after miscellaneous, we can have our assignment or research or even both. You all are aware we either go with any or both. And then we shall see what our next stop shall be. Whether it shall be a free class, whether it shall be a premium class, we shall see that. So that is a simple plan we are really following. Let me also secure our book. So we are going to first do some factorization, which you people know. Those who attended indices with me, even those who attended logarithms, especially logarithms together, you all know that I taught quadratic equations already. You people, isn't it right? Those who are on and you attended logarithms with me. It's even on YouTube. Do you agree with me that really Dr. helped us solve the quadratic equations? So do you really accept and really allow me to use only one example for each? Then we start completing squares and then we connect roots of a quadratic equation because they are the basic things. They are the basic things of the class. Yeah. So I'm going to put here quadratics. Yeah. but I don't have anyone who is really supporting me. I don't know why. Is it true that those things were covered? We are really here to, let me first correct this page. Quadratics. Okay, let me have it like that. We tried our level best and tried factorization. I don't know if we tried bulldoze, I can't recall, but I think we tried. So let's first see how to factorize, and then we shall maybe hence solve. Okay. Now, to begin with, I'm going to give you a note. Let me see if I have some supporters. Doctor, how do you drive that equation of quadratic? You don't need it. One of the things they hate in the new curriculum is deriving things, because deriving things made students to cram a lot of stuff. So you don't need it. It's not even anywhere in the book. They just need you to be applying. Okay? That's why even the book is telling you clearly that as you're teaching students things of minimum and maximum, you teach things of maximum profits and maximum costs, not just maximum value like in the old curriculum. Let something of profit come in. But before you understand the one of profit, you must understand the one of old. Okay? That's why I always tell students the new curriculum is harder than the old one. You like it or not, especially when it comes to biology. Because the other people just used to cram and reproduce. For you're supposed to understand, because you cannot apply what you don't what understand. But that will be for another day. So let me give you a note. Because in most of the cases, we first factorize, then we solve. So I'm going to do it at once. Okay? But maybe I'll first do one, because there are people who are too indisciplined when it comes to such things. Okay? Uh-huh. There are steps I gave people as we are factorizing in the previous class, and you want to just say them. I don't want to write them, yeah, because that will be too much. But those who really need full details, I refer you to the class of logarithms. Let me hope that's the class where that was done. Now, factorization. How are we really going to do this? I remember telling people about what they call the product and sum. Okay? Now, let me write this general thing that we have. This very fast. So with factorization, let me teach you. They cannot tell you to factorize an equation. I don't know whether this is going to make sense. They factorize expressions. Equations are solved. You understand? So what we are going to be really factorizing are expressions. That's why I began the topic by saying quadratic expression looks like that. Do you see any equal sign? Equal to zero? No. The moment you say equal to zero, that becomes an equation, and equations are solved, not factorized. Now I'm going to just have it like that. I don't want you to ask me where the equal to zero is. Are we together? Now you tell me, where is the sum, where is the product? We are not solving, we are simply factorizing. Okay? So you tell me, which one is the sum, which one is the product? When someone just puts for you that. And let me tell you, what makes quadratics hard are those in front stuff. But those things become hard simply because you underrated the basics. Because you think you can use bulldozer, you can understand alpha and beta. You fail to understand the basics, you find issues with alpha and beta, they begin cubic and bring in alpha, beta, and gamma. You get confused totally. Let me see in the chat. I just need one person to give me the response. B is the sum, C is the product. That is wrong. That is wrong. See the product. That is wrong, and that's where people go wrong. Do you see people are telling us C is the product? So you learn today. C is not the product. You learn today, C is never the product. And I want you to be extra careful, because you're going to flop. I may not reach 90%. If people have told me that if people have told me that C is the sum, then I really have a very big job. So when I say plus C, those who will be listening to this in the future, you'll be revising. So don't laugh at your friends because they are learning for the first time. Okay. Now, plus b is going to be our sum. Yeah, sum, the b. Then the product. Let me tell you, the best way to recall this, is have it in mind. You know what product means, eh? Yeah, at least that can help you recall. Product means some things have been multiplied. So how you can recall this, you can be like, C can really C be a product? C should be a product after some things have really been handled well. Maybe A and C being multiplied. After all, B is already taken. So the only single person we have there is A. Okay? So maybe A and C will interact to give us the product. Something like that. So I'll come here and say that AC is the product. Okay, now they are what we call who can tell me? They are those values we always get next. I want you to listen carefully. There are those values we always get next, and we say you get two values which when added give you the sum, and when multiplied give you the product. How are those values called? Tell me in the chat. And that is the answer that you need in this lesson. Because these things are going to change in the end later on. You're going to see me changing my statements, and I tell you the sum is negative b over a. The product is c over a. But you can only understand that and not get confused if you correctly answer what I've asked. What name is given to those values we always get next? Which when added give you that sum, and when multiplied give you that product. You see, someone is saying roots, someone is saying pairs, most people are saying factors. So by side, you can really realize that the correct answer is factors. Okay. Now, I'm trying to read some private messages here. Okay. Now, let's proceed. So those two are called factors. And someone may be like, why are they called factors? Guess what? We are factorizing. So if we are factorizing, it's supposed to be factors. Don't even think of anything else. We are factorizing. So what do you really want them to be? Factors. Okay. So the zygote of these two, the moment they get in touch, they are called factors. And I'm not going to write that. I've said it. What are they? They are those when added, give you the what? The sum, and when multiplied, give you the product. So, where do these factors go? Where do they go? Who can recall the exact statement I used? After getting the factors, what do we really do next? What do we really do next? Where do these factors go? Let me see if someone says something. Doctor, save the document. Okay, thank you. They replaced the sum. Thank you so much, Ibrahim. That one attended. They replaced the sum. Okay. And after they have replaced the sum, what next? I really need sharp people. Someone can even tell me the remaining two steps at once. What do we do after they have replaced the sum? What do we do after they have replaced the sum? Ah, factorize them into two brackets. Factorize. Okay, that is nice. But we first try our level best and group them logically. Okay. Group them logically into two. And I remember teaching you that logical part. That as you group them, make sure that you have something to really factorize out. Yeah. Then after that, you factorize. Yeah. And we are going to see all this. We're going to see all this. And trust me, we just need one example on each, and then we leave the place. Maybe we can have two where we lack here and where we have a. Something like that. It's what we are going to do today. Okay. Now, in most of the cases, when you factorize, you hence solve. When you factorize, you do what? You hence solve. So we are going to be having such questions. Questions that are going to tell us factorize something, hence solve. I think you've seen those questions before. Okay. Now, example one. Straight away. Yeah. I have my math books here physically. They are very nice. So they are the ones I'm going to be using. Yeah. So for me, I'm going to be, this is mathematics. Eh? So I just need to be having my numbers here. I pick very nice numbers, then I put the number, we do it. Okay. Now, this is how the question goes. I'm not going to write it, but I'm going to say it so that you really get the point and so that we also save time. Now, the question is um, factorize. Factorize. They first write the expression like this. Just that. After saying factorize that, they say hence solve. Okay. For this first one, let me write everything. So they say factorize that expression and then hence solve this. Someone has been like, Doctor, you over-refer us to polynomials. Polynomials are very good. So that's how questions can really come, the very basic ones. Now, before I even go any further, before I really confuse people up, these things really have names. Yeah. And I'm going to say something small about them. Yeah. If you're having something like that very one we are having, you're having ax squared, you're having plus bx, you're having plus what? Plus c. You realize we are having this x of ours, eh? And you all know that we can always put any other value there. You people locally call it unknown, which is right because maybe in most of the cases you're solving for it. So if someone calls it unknown, you can really give that person a benefit of doubt. But that means any x value. You can always put there any x value. We shall see that as we are sketching curves. If I wake up and tell you, please, sketch for me a line, I taught coordinate geometry. And you recall as you're plotting a line, you can put here any x value that you want. So that x value always changes. That's why we are always looking for x in mathematics because it's never in one place. It always changes. It always varies. So we shall call it a what? A variable. And you tell me in the chat, what is the opposite of variable in math? Let me hope all students who are here after this class, you can always explain to people why that x is called a variable. And you tell them unknown is a bit local. You can tell me what is the opposite of variable in math. Don't even overthink, just ask yourself if variable means change, what is the opposite of changing in English? And maybe find ways of ensuring to have a synonym that is a science word or mathematical word. Opposite of something that changes, what is it? Because now we are having these values, eh? The value A, we are having this value of B and the value of C. It's the balance. Have people said something? Thank you so much. Constant. So those three are constants. And we are going to be seeing this in the questions we are going to be handling. Of course, some of them. So have it in mind. The others are constants. The x values are unknown or the variable. Okay. Now, let's see. How are we really going to factorize this? We all know that we are supposed to identify the sum, identify the product of what? Of factors. Okay, so this sum we have been handling here, it is a sum of factors. I will ask this in the future and I will put some money for those who will stay. Yeah, those who know the classes, right now people are too many, over 100. But by the time I reach midnight, people are going to reduce. By the time I finish the class at 3, people will not be here, and that is very bad. You people easily give up, and the level is already hard. You see, this level is not hard, but the stress starts when you're having 3 teachers teaching different things, and all things are new. That's why I try my level best to handle for you those classes you're currently handling, so that you at least have breathing space. Biology teachers are 3, math teachers are 3, chemistry they are 3. Each of them is teaching something new. Who are you? Who are you known to fail the level? If at all you're approaching it that way, very risky. But assume you're this kind of student, whatever they are bringing, you have, even if you doze, you wake up and you're still on track. That is the best feeling ever in class. But the moment you doze off, you wake up and you cannot really connect stuff. You start thinking about your life, be like, what will I really tell my parent? Be like, maybe I wasn't even meant to do BCM. Maybe I wasn't meant for this, but you were meant for that. Those are just hallucinations. The best students I talk to are students who really have reached a point of wanting to change combination. When I talk to them, they even change from BCM to PCB. And there is a rumor that is moving currently. I thank God that I've recalled. Have you heard of something like BCM students won't do medicine? Have you heard of that anywhere? I'm hearing those rumors, but I think I need a full video to talk to students because people are going to make mistakes. You've not heard from me, I've not communicated, and you know I care about students so much. And you change a combination without really consulting first. That is very bad. But to give you a simple hint, last year was the last year where the old curriculum really faced at A level. So they didn't want so many students to what? To pass. You listen to what you're going to tell your friends. Do people want me to say about it? Or we should proceed? Should I say something small about BCM students being denied medicine as the rumors say? Schools are telling students to forcefully take PCB. Okay, let me tell you the secret. This is it. Last year, the old curriculum was phasing out. Are you listening? So they didn't want to have a backlog. A backlog are people who fail and they may maybe want to repeat. So the marking was too lenient and the grading was too low. That's why you saw so many 20 points. You understand? So when the 20 points were so many, the government was really puzzled on which people to really give government sponsorship and who to leave. It becomes hard when the maximum points are too many. You understand? Because now the cutoff points at Makere were just maximum, but still, do you know what it means? Okay, students who had 20 points are even going to miss government because there were too many. So the ministry was concerned. But they looked at PCB students and they had very few 20 points. So they were like, maybe because this, okay, it's like BCM was losing its original meaning of being very hard. So they were looking at it as, how can I say, they were shifting blame to students. PCBS, it's a bit heavy, but you don't need a lot of physics at medical school. Yes, you don't. So they were claiming that we are going into a new era that needs physics, but it's not right. The rules are clear. The only medical sector that needs a lot of physics is radiography. That's why you cannot be given radiography if you don't have physics. So change combinations slowly. You will change, the combination will become too hard. For me, I support people to go for PCB if you have issues with math. But this is a disclaimer. If at all they communicate well and good, but it doesn't make sense, they cannot convince some of us who really know what happens at medical school and at A level. You don't need a lot of physics. And there are things that will need math also at medical school. So it has not been officially written. And never be confused. Your students who are learning are during an era of internet. Go to X, create an account, follow the Ministry of Education and Sports, follow NCDC, follow UNEB. When you hear of something funny, go to their pages and look for their recent posts. Go through all of them to confirm. So, the essential subjects for anyone really wanting to do medicine, it should be biology and chemistry, nothing else. The physics part is a bit overrated. You need the physics but not a lot of it. But by the time you reach campus, even your brain is well developed to learn. Of course we are learning. What will stop you to learn that little physics you need at medical school? But if it is radiography, you need a lot of physics. That's what I can say. If you have issues with math, do PCB. If at all you know you can read, because the math in physics is just to do with substitution. Are we together? So let me hope that is enough. But it is a long story. I've not even told you 1% of it. But be strong. How can you come out and say that BCM, how? The combination is hard. You understand? So you cannot just deny it a very beautiful course. You cannot deny health, you cannot deny a BCM student health sciences. That is extremely risky. So let me hope I've tried to rectify that. But if you're there and you're confused, you study biology and chemistry. But they will shock you in the end and it's really okay. So that was some bit of propaganda. But of course, it shocked people's minds. And people don't always want to risk. But that is it. The students who don't do BCB and BCM, those who are not in the dilemma, forgive us, but I had to pass that on, okay, because it is really necessary. You never know, they may even wake up and say, if you don't have chemistry in PCM, don't do civil engineering. But is it necessary? What is the chemistry in civil engineering? Nothing. The essentials remain physics and what? And math. Hope that has been understood. Now, very fast. The sum we are dealing with here, it is sum of factors. The product we are dealing with here, sorry for that. It is product of factors. That has been said. We go. Now, using what we have just said, by comparison, you can see the sum is -5. People usually forget that. People usually say 5. But have it in mind that in mathematics, any sign before a number, it's the sign of that very number. So if you're having negative before 5, so it is -5. Are we together? So here our A is a 1. Though we just don't really show that. It is a bit primitive. Okay, so the A is a 1. We're having here our C as +6. I want you to be students who are asked in class, what is C? +6. Don't just say 6. Yeah, +6. But when you're writing it, you be like 6. When you're saying +6, because you know how to speak math and how to write math. Are we together? Now, after appreciating the fact that, you see people, you're A-level students. At your level, I don't expect you to do those things of writing the sum, writing the product. You skip it. Even write them as side work. Yes, write them as side work. But if you really want, write them in one line. I don't want you to give them a lot of energy they don't deserve. Someone writes sum equals, there you go, product equals factors. You're writing a lot of what is not necessary. You can have them as side work, you just come and paste the next thing. But if you really feel like you can't really go without them, write them in a single line. You come and be like, my sum is a -5. Are we together? You say comma, then you come and say the product. Yes, you can write product like that. This is math. Product is a 6. Don't even overdo it by saying product is 1 times 6. That is bogus. Then in the same line, you come and say factors, because the most important step at A level is the one that is coming after this line, the one where you replace the sum with the factors. So in the chat, tell me very fast, the students who are focused already have the factors and they even already have the answers. What are the factors? Those two numbers, which when added give you -5 and when multiplied give you +6. What are they? What are they? I need them in the chat. -2 and -3. Thank you so much. And I told you how you can get them. I'm not repeating that. Simply go to that lesson of logarithms. You skip until where you say quadratic equation. Go back and revisit. Those who copied the notes, you just refer to your notes. So there are only two. That is -2 and -3. We are going to need these things in alpha and beta. Hey. Okay. After that, they are supposed to replace the sum. So the sum is -5. So where we have had the sum -5, we are going to come and put -2, but the sum had x. So as you bring these figures, don't forget the x. Are we together? Don't forget the what? The x. Then you also be like +6. Don't risk and put a +0. They told you to factorize an expression. So don't wiseg. You understand? Don't wiseg to do weird things. Are we together? So if for you feel like you really want, you can be putting equal signs here at the beginning. People usually do that and their work looks somehow okay. Yeah. But the best thing I really advise people is you can first decide to rewrite the question. You'll be like, this is -5x, then here you have +6, then you write. You understand? So that you chase the demon of equal to 0 early enough. +6. So from here, you can really continue from there. And it is nice work. So I said you group them logically. So you can realize that here you can pull out x, even here you can pull out 3. And realize when you pull out 3, something common will really come very fast. And I gave you a technique the other time. That here I realize it is x that you can only pull out. So what remains here is x, because when you multiply them, you go back to x squared. Then you will have minus 2, because when you open the brackets, you go back to 2x. Are we together? Then what is here? What is here is negative 3. So you just write it as negative 3, because you know it will really work on that 6. So you're supposed to be very careful. I know that after really working on this, don't even waste your time. Who can tell me, what did I say after you saying minus 3? What are we supposed to do next? Are we supposed to really ask ourselves a lot of questions? Because there are those of you who want to ask yourselves, what should I do after this? What should I do after this? Things like that. What are we supposed to do? Don't just say no, Dr. Mambo. Say it. X minus 2. Thank you, Richie. Someone is like, you just paste. Because you know this one is supposed to be similar, eh? So you're supposed to just come here and paste x minus 2 like that. Then if I told you you're this person who has trust issues, you check and be like, when I multiply this, will I go back to negative 3x? Yes. When I multiply negative 3 and negative 2, will I go back to positive 6? Yes. And that is it. Yes, that is it. You're good to go. Now after that, you really group all this. Be like, let me group the ones outside. It is x minus 3. You group them like that. Hope people get the grouping. The ones outside the brackets interact and be together. Then the other common bracket really comes out as what? As 1. So here you're really done with what? With with the with the with the factorizing. So a good math student will come and rewrite this, because this is their final answer. So they will come and show this examiner that they really know what they are really doing. So they put that. I will remove the arrow. It's not supposed to be part. Now that's that's not where the question is ending. So that was the factorizing part. If it is completing squares, we shall see how it really works. Now, remember the question said factorize that, hence solve. Who can remind me in the chat, what did I say about the questions that have the word hence? Who can remember that one statement I said? If the question has hence, what do I expect you to have in your solution? Who recalls what I exactly said? I'm waiting in the chat, but no one is saying a thing. What did I say? You start from where you stopped. You can exactly. So where you've ended is where you start from, and you're supposed to also write that word hence. You understand? Hey, I wanted someone to say the word hence, so you're supposed to come and say hence. So they say the hence of this equals. So you also come and equate the other things to 0. So you'll be like this minus this equal to 0, something like that. So you come and be like either x minus 3 equal to 0. Are we together? Then you'll be like, our x shall be a 3. Very correct. You come and say all, okay, the x minus 2 equal to 0, or the x shall be a 2. Very nice. Now someone tell me, what is the name of these answers we are getting? What is their name? These are the answers we are getting, but what is their name? They have a special name in mathematics. Who knows that name in the chat? I just want one person. Roots. Thank you so much. Oh, people are mathematicians. I didn't know. They are called roots. So they are roots. So that word roots is very important. Let me hope people are getting it. Roots are different. Let me tell you something still. Hey. I've seen these things. I've seen this and this. Those ones also have names. Who knows the name of those two? How are they called? How are they called? Like this one and this one. They also have a name. You tell me in the chat. Don't just guess. Let me hope you're sure. They can be called alpha and beta. You're lying. I can use gamma and epsilon. I can use delta and kappa. Yes, I can use theta and maybe lambda. You're lying. They are not called alpha and beta. Prenomials. Yeah. What's that? Factors. Thank you, Ryan. They are called factors. You people, we have just factorized You just ask yourself, what have you just done to this expression? You factorized it. So where you stop, where the factorization stops, that means what you've obtained are the factors. Someone may be like, what of the other ones? Yes, they're also called factors, but these ones are what they call the real factors. Yeah, they are the real factors. You get that from me. Real factors. So it is factors that lead you to the roots. Yeah, when you attend polynomials, you just pick everything. So you learn that. Why they are called factors, the factorization has stopped there. So what we have obtained are what they call factors. The moment we equate them to 0, the x values we get are the ones they call the roots. You understand? Hey, so have that in mind. We need it so much in whatever we are going to cover next. Are we together? Now, I want to be using the quadratic formula also at once. Yes, I want to be using it at once. Who knows the quadratic formula in the head? Maybe to be fast and to give you a hint that is really going to help you so much. Let me see those who say, I cannot forget the quadratic formula, the one you call the bulldozer. Let me see those who say, I can easily forget. What if I just press the equation in the calc and I get the answer? That is not marked correct in pure math. It is allowed somehow in physics, but it is also risky, even in chemistry. So avoid it at all costs. Let me see people in the chat, those who say I will forget them, those who say I cannot forget. Yeah, I see what I can really tell you. Doctor, I'm really in a wrong place because I haven't covered logarithms and polynomials, but I've not taught anything that I need that needs that. Let me tell you, you don't need any of the things you're saying to really understand this class. Are we together? Someone is like, I can really forget, I can forget. And the other time, someone really asked me for the logbook, and I really appreciated that. I was like, oh, really, these students really follow whatever we say in class. Have you guys heard of what they call the logbook? Have you heard of the logbook? Let me pick this one that is having formulas. I want to see if we can very fast get the quadratic equation. Yeah? Those who say that, you may forget that thing. Yeah, we have it here. So you don't need to really force yourself to cram things that you don't need to cram or understand. And I'm not seeing it. It may not be in my old logbook. It may be in the current one. But even if we don't have it here, um, hey, we don't have it. We don't have it. But it is not hard. It is not hard. Let me see. How come we don't have it? Anyone with the current logbook to check, eh? This is geometry. Where is algebra? It is here. I was wondering. It's here. It's here. Yeah. Now I want, do I have anyone who has a logbook on this very class? Do I have anyone? Your form fives and I don't really trust you. I want to buy the logbook. This one I'll just send you. You have it in your phone. Maybe you print those pages that you need. You have left it on first page. Thank you so much. Do I have anyone with the logbook? I want you to check. You go to around page 59 to 61, but basically page 60. Tell us if you see something like this. Confirm us with the page and the formula so that people can have it. Someone is playing with our screen, but I hate that. Remove whatever you've put because I'll remove you from the class. I hate excitement, yet we are here for serious business. Someone confirm the page and the number of the formula. Like here, what I currently have is page 60, formula 11. But this is the old logbook. I've been using it since 2015 to teach. The logbook changed, but me, I got locked up. Okay. I don't really move on. I don't have, so how can I get it? Anyone with the logbook, confirm the page and the number of the formula. We proceed. Because you're the same people who have said that for me, I can really forget, say something about the quadratic formula. And I've said confirm the page, confirm everything. Okay, now quadratic formula. So I want us to be using quadratic formula and also be using the factorization so that people can really see the connection. We begin completing squares, then I think we go to roots first, then later we can switch to the completing squares. I think that will really work and it will make sense, I guess. Now, look at this. Look at this. Um, Quadratic formula, what we call the bulldozer. I don't know whether people know the story why it's called bulldozer, but you will learn. Let me see if some serious students have confirmed. Page 60, formula what? You people are telling us page 60. Tell us the number of the formula. Can I first write the bulldozer and substitute directly in the calculator for the answer? That's what we are going to look at because I know very many people are disturbed by that. Anyway, let me not stress myself with unserious and incooperative people. Page 60, formula number, people are not telling us. Now, how does it really work? So it is the same as my old one, yeah? So it is formula 11. Now, how does it really work? They write it like this. Let's go to my logbook. So they are giving you the format of the quadratic equation. Are we together? And they are telling you it's having roots, and we have agreed that roots are those values of x that we always get at the what? At the end. Okay? And I always want you to be using this small x. Yeah, if you can, write well, small x. Because when it comes to applied concepts of math, when you write capital X, it is really issues. You will see that in Newton-Raphson. I think I need to also post it on YouTube. Linear interpolation, those simple things. Are we together? Now, this is the formula. In case you can really forget it, just be like, breathe in and out, accept the fact that it's already in the logbook. Ignore. Okay? But it's having this important part, the plus or minus. It's having a negative b first, then down it's having 2a, then it's having this square root, then inside it is b squared minus 4ac. Those are the components you're not supposed to forget. What have I said? So as you're getting the roots, that means you're getting values of x. So we are going to write it as x equal to, you understand? So don't be like, why are you saying x? We are saying x because we are getting roots and I'm using small x. So I've said the important features of that formula is the first negative b, never say positive b. Then the other next important thing is the plus or minus, so we are deriving it together. Then the other next important thing is the root, okay? Then what is the other important thing is the b squared minus 4ac that is inside, okay? Something like that. And later on, I will tell you that that is what they call the discriminant. Then all over, we are having 2a. You understand? So that is the quadratic formula. So what is it really helping us? Someone may be like, what are you really getting? You're getting root. So, what is the role of it? We are supposed to substitute. So when they tell you something like solve, so this one can never be used to factorize. Because factorizing, we factorize expressions and we solve equations to get roots. So it's supposed to help us get roots. So it only deals with solving. So where they have told you to factorize and hence solve, they are trying to avoid you from using the bulldozer method, if at all you get the literature. Okay, now how was the equation? The equation was like x squared minus 5x plus this. That's what we had. Now, let me tell you this. You're not supposed to write that formula in the paper because they know it is in the logbook. Whatever is in the logbook, they cannot mark it because now that's like cheating. What are they really marking? You cannot mark something, yet it's in the what? It's already in the logbook. So it's like you're giving free marks. So I advise, I just come here and be like, you know that your A is 1. So you can even put here a 1 and on top of it, you put letter A. Then you be like, my B is this one, negative 5. Why I'm putting that bracket to for you not to forget the negative, and then you be like, my C is this positive 6, like that. Yeah. Then after having that, you can substitute, but it doesn't really require you to rewrite everything. No need. That is wasting time. So just come straight away and be like, okay, my X is negative b. Are we together? Negative alone. But remember, even b is already a negative. So this negative is the one in the formula. This negative is the one on negative 5 in the equation. Yep. Hope you don't get confused. Then you come and be like plus or minus. We shall have this root. Then b squared. Our b alone is negative 5. And we are squaring. I told you that in indices, that when you're squaring a negative, please bring in that bracket for your work to be extremely neat. Minus for a c. So most of you be like, after all, a is 1, even if I don't show times 1, you're messing up, you're going to fail because you're not correctly substituting. I told the physics students the Esca mode of calculating that if at all you're calculating, please, after the expression, substitute. And the substitution should completely resemble the expression. So that someone can tell that when you put here in brackets 1, someone is like, yeah, if the other one was 4ac and this is 4 into 1, that means a is 1. Not you missing a 1 and just putting a 6. It's like you're saying AC is somewhere already in the general quadratic equation, which is very bad. Then you also come here and be like bracket 6. Yeah, you can use multiplication, but me, I just want brackets because they increase on how neat I can really be. Are we together? Then you come and say all over 2a. Someone is like, but a is already 1. Why don't you just put a 2? You will fail. Please substitute correctly. Come and say 2 into what? 2 into 1. Very nice work. So when you make such a substitution, who can really deny you marks? Now, a friend of mine said, now, doctor, after having that step, can't I really just, someone said, can't I really just go to the calculator and really have everything ready? No, I don't support that. I don't support that. They will know. The people who are marking you are more mathematicians than you are. So they know all those tricks. Those tricks work in physics, they work in chemistry, but this is math. So don't really do that. It's a bit risky. Quote my words, a bit risky. So what are you supposed to do? At least show a step. You understand? Show these people that you're really doing something. Hey, what is that step? For me, I really hate square root signs. So in the next step, I wouldn't really love it to see a student having that square root sign. So I beg, first work on what is inside the square root. I mean square root, non square bracket. I hate square roots. So I avoid them as early as I can or as much as I can. So I want you to go to the calculator and you tell me the result of the whole of this. So that in the next step we are writing, to just show these people that we are doing some math, we really have a step at least. And it can be done. Okay? Now, you're supposed to come and split it. So you come and say either. So you come and be like x is equal to negative and negative is positive. Okay, so this is where you're going to have the plus. Then this side, the whole part, is where you will have the x. We have agreed negative and negative is already positive. Are we together? So here what you will have is the 5. So then here you will have what? Minus. Are we together? Now you get me. What is the result of that whole thing? What I'm having in the chat, people are saying 1. Let me trust you. Hope it's right. So you come out here and say this is 1. This is 1. Are we together? Then you say over 2. Over 2. When you have that step, at least you have given this person marking a benefit of doubt, so that you really didn't just press the calculator, you did something. So finally you come and say, okay, my x value will be a 3. Then this side you be like, the x value shall be what? 2. Yeah. So this value is correct. This value is also correct. You get your marks. So that's how I expect you all to be using the bulldozer. Yeah. Now, the next example that we are going to do, this one had a as 1. So we are going to do only and only one example. One example. And here we are going to be very fast because now we are going to go to the next thing. That is roots. And let me tell you, if at all you've appreciated these roots, you're going to just enjoy. Yeah. Because now these are the roots. These are the roots, the x and 3. Sorry, the 3 and 2. Now, example 2. Example 2. You're going to be doing it as I also do it. Just revision to close the chapter. You write and say, let me see what we can have as we hear from Alfred. Yes, Alfred. So get ready. I want
Sir,
by 11. A moment, please. I want by 11 when I think we have started roots. Yeah, by 11:30 we have really understood it. By midnight we do completing squares. 10 minutes into midnight we shall have left this place. But trust me, that is a joke. We may even reach 3 a.m. I'm just trying to motivate you. I have demotivated you. So yes, Alfred.
good evening, doctor.
Good
Yes, my
evening.
request was you pinch the screen, I take the first screenshots.
Okay, we shall do that at the end. I don't know. Are you okay with that?
Okay.
Thank you, sir. So I've just put that equation in, but let me hope you all know the question. The question always goes that really first factorize and after factorizing hence solve. Okay, the factorization is a bit very easy. Now very fast, write the sum and product in the chart. But I want you to just say, you just put commas. You'll be like sum is 2, comma, product is 3, comma, you put the factors in brackets at 1. So I'm expecting one response. When I see one response, well and good. Sum, comma, product, comma, factors in brackets. As we hear from Richie something. Yes, Richie. But be fast, be fast.
Sir, I wanted to ask,
Please go on and ask.
our teacher told us to show few steps when you're using bulldozer.
And that's what I have told you. I've told you that bulldozer, you people, I've explained the risk and everything. I don't really expect that. Who can reply to him? Who can tell him why we are showing that at least one step before the answer? Who can raise up their hand and help me to respond to Richie? Okay. You don't have a name, but unmute and respond to Richie. Why are we really having that step before the answers? Please speak up. Please speak up. The person raise up their hand. Okay. That person is really wasting our time. Yes, solve something. Okay, you people, when you raise up your hand, make sure you have something readable. Make sure your identity is readable. Now, someone is saying the sum is 2, that is very nice. The product is 24, that is wrong. That is wrong. Completing squares, I've told you it's coming after roots, please. People just giving me the factors. The factors are right, but you're having wrong products. Okay. It's as if someone wanted to speak. Are they quiet? Sum is 2, that is right. The product, it is this 3 times this -8. So it is -24. So we have those two numbers. When you add them, I told you how they are really obtained. But I told you just need to be like 24 can be obtained by 1 times 24, 2 times 12. Are we together? 3 times what? 8. Then 4 times 6. Then you'd be like, among all these pairs, which pair really looks suspicious and it can in one way or the other give me a 2? You'd be like, it is 4 and 6. How can 4 and 6 give you a 2 when you say 6 minus 4? That means the factors, it is 6 and -4. Is that really hard? It's not. I don't really expect it to be that hard. Let me tell you, factorization method is really overrated. Okay? I like those words because I just learned how to use them of recent. I think it was in 2020. I really didn't know how to use the underrated and overrated, but I learned. That's why I oversay them. So it is 4 and negative. So it is. I think it is -4 and 6 if I'm right. So this is the point where I talked about the logical part. So you can be this person who is like, let me arrange them like this. Are we together? -4 and 6. And that's what most of you will do. So we are saying that these factors replace the sum. I brought this example for a reason. After here, I'm going to have this. Are we together? Then I'll say -4x plus 6x is the one to replace the 2x, then -8. Who can tell me, is that thing right or wrong? Don't say anything. Don't give me any other reasons. I just want to know, is it right or wrong? Someone is saying right, okay? Someone is saying wrong, right, wrong, right, wrong. Do you see that battle between the right and wrong? That's the battle that happens in papers. Who can raise up their hand and tell us why that is wrong? Those who are saying right, you're not being serious. You will get the answers, but you're not being a student of Science Scholars Academy. Remember, I told you that you're supposed to logically do something. Let me hear from Haddad, but be fast. I'm giving you 30 seconds. Be straight to point and to content. Don't greet me, just give me the response.
It's because we don't have a common point in 6 and 8.
We have a common point. It is 2. 2 is common in 6 and 8. Or
So
we don't
but,
have a common one in 3 and 4.
yeah.
Yeah, thank you so much. So you realize that you're lacking something common in 3 and 4. But you have X. Let me tell you, you're going to get the answer. This is right. But I always want people to have some neat work. This is okay. The answer will come out. But I prefer what you guys understand. And I know you know what I mean. Okay? So you realize that if at all you switch positions, and you begin with the 6 and then this 4 comes this side. When the 6 goes this side, it has a story to tell with 3. When the 4 goes this side, it has a story to tell with 8. So it's really better. So as a mathematician, you come and change them. Yeah, the examiners won't know what hit them. Okay, so you come and say plus 6x. They can't know what really hit them. 6x, this is minus what? Minus 4x. Yeah, then you come and factorize. When you do this and I see your work, I just be like, yeah, this student really follows. So when you reach this step, you be like, here the common thing is 3x. Then here we are having a balance of x, we are having a balance of what? This. Now, when you see this -4, and you know it has a certain story to tell with this 8, you just place it. And when you place it, because you know these brackets are supposed to be common, you just come and put here x plus what? X plus 2. Then you try to reopen and see if you go back to where you're coming from. And you realize it's coming out. So you just leave it at that. Are we together? You come here and say, what are you coming up with? You're coming up with this minus this. Then here you're having x plus what? X plus 2. So you factorized. Let me hope people recall what I said about what to put here on the left-hand side. I'm not putting it because I said it already. So I expect people to be having something before having equal signs, then bringing back the question at the end. And you know that those two are what they call factors. And when we equate to 0, what shall we have? We shall have what we call the roots, which roots are the values of x. Okay? About the sketching and everything, that will be another topic. And I told you the name of the topic, right? After that, we have the hence part. So we also say hence. But when we say hence, just bring our factors, equate them to 0. So this is x plus 2. Okay, then you'll be like either equal to 0. Are we together? So yeah, you just write the answer. There are some of you really waste a lot of time here. You'll be like 3x equal to 4. You even do this. There are those who do this. You're wasting time. You even come and make your work dirty. There are those who even leave this step and come and do these things of primary. 4 divided by 3. They put 3, then they come. 1, 1, 1, 1. They even say, I get 1 remainder 1. What is that? So, there are things you're supposed to be avoiding as you progress in mathematics. when you reach medical school and do biomath, there are things you're also supposed to dump. And I'll always be here to guide you. You people, even after you're done with high school, I can advise you in all sorts, provided it's education. Yeah, that's where my passion for. So I'm really informed about everything concerning education. Yeah, don't come to me and you're asking me about how to start a given business. Yes, I may give you theoretical knowledge. Okay, this is -2. Yeah, so this is a root, that is a root. That's how neat I really expect your work to be. Okay, now as we are using bulldozer, I've told you, just make sure your substitution is kawa. When it is just kawa, you just have one step, then go to the final answer, and no one will comment on your work. Everyone will be like, yeah, this student really deserved it. Are we together? Now, we are going to roots, you all know, and there are things really going to talk about. Let me see. Do I have people who have issues with yeah, but I believe all of you have issues, but we are going to handle them, don't worry. So if at all you're going to handle bulldozer, so I'll come and say alternatively. So I just want to use little space because we really need to leave this as early as we can, okay? And tomorrow is a Sunday. We are not supposed to give up. Let's show God that we can stand for 4 hours studying mathematics continuously, get everything, and that endurance really counts. So that at that point when they are marking your work, yeah, and really you made a very slight mistake, God is like, this student really showed me endurance during their early stages of A level in senior 5, serving classes for 6 hours. Let this examiner write their 68 as 86, and that's how you get an A. You see? But if I told you this person who has not been reading, you've not been showing God you really endurant, you're the people. Guess what? You'll be getting such things. What's happening to my screen? Okay, let me hope we are back. So as your friends are really getting blessings of getting 68 and they are writing them as 86, for you be there and you get 23, and God is looking for a way to help and he can't, because the only way he can help is 32%, and still the bracket is still within an E. So please do the needful so that the marks are like 57. You understand? So those are the marks that really come around. Marks like 26. So that the result is what? This. But how will really God help you to do that reverse when you have 12%? All you will deliver is 21. And that is still an E. So please really try your level best. You're tired, you're dozing, you stay on. You're not understanding, you stay to not understand more. So that you show God that you collect enough evidence to show God at the other day that I really tried my best. Okay? So it is 3x squared. This is a positive 2. And this is a negative 8. Not so? Equal to 0. So here you just need to come just below. You'd be like, this is my A. You'd be like, this is B. Even if you don't put a bracket because it's not even a negative. But here you'd be like, hey, this here it is a negative. Let me do that so that I don't forget. Then after that, no need to rewrite the bulldozer method. No need. Just come and substitute. Be like, the first thing is negative B. So negative B is a positive. So I'll put a 2. Don't forget the plus or minus. Are we together? Then the root. Then it is B squared. B is a positive. No need of putting 2 in brackets. So just set to squared minus 4AC. What is A? A is 3. Are we together? What is C? C is -8. Let me hope I didn't change the question. Out of what I have is 2A. My 2 is that. My A is a 3. Let me show you that none of you is serious because no one of you has gotten me the product of this. Yet you know it is the next thing. If someone really delivers it in the next 5 seconds, I'm giving you 100,000. If you have the product to that, no one has it. But you know that that is the next step. And now 5 seconds are done. So please get me the result to that. Someone is saying 100. It can't be 100. It can't be 100. It can't be 100. I've never seen that. Is it really 100? The result of the whole thing? Are you getting really 10,000? Because 100 is the square root of 10,000. Remember, we are not supposed to write the square root again, but that was biased because me as a person, I hate the square root. So we are avoiding it at all costs. Are you really avoiding it? Or you're panicking because of financial issues? People are panicking, 38, 96. Why are you panicking? You relax. Okay, so it's 100. So after having something like that, we are going to come and split. So when we split, what shall we have? We shall be like either. I used to be very stubborn as a student. I went to Google because for me I was really informed. I went to Google and asked for the words either and all in Spanish and Latin. So in one of the math papers, I used Latin to write the words either and all, and my math teacher was pissed. But after proving to them that the word really meant those things, they were really proud of me. They asked why Latin, because most of the topics in math, when you look at where they really come from, it is somehow related to things of Latin. Every word, Latin word, Greek word, Latin word, Greek word, Latin word. I think those guys were very brilliant. But I've never heard of anything like this topic is called so because it came from a Luganda word, this. I don't know what's wrong with that tribe. But you try looking for names of thieves, you'll be shocked. Most of them, okay? What I have here is -2, but it is still -10, okay? But it is also still over 6. You can even use your head here. Yeah, it can really work without really going through a lot, eh? So this is 8 over 6, which reduces to 4 over 3, which we have already. Then this is -12 over 6, which reduces to a -2 like that. And yeah, it really works out. So that is it. So I'm not doing anything else as far as factorization, as far as Bulldozer is concerned. I just believe that we have perfected that. Do you see that I'm good at keeping time? I told you by 11 we need to be really introducing what? Roots of a quadratic equation. So very fast we are going to go to that. You people, are we set? There are so many questions, but we shall see that in revision. Yeah? Yeah, there are so many applications of these things, but I want you to at least have what we call basics. When you have basics, even if the question changes, you can really handle it. Are we together? But there are those concepts we shall look at in the future, not now. So for now, let's do something on, let's do roots first before completing squares. What should we begin with? People can decide in the chat. Completing squares, or we can do roots. But I think roots are better. I think roots are better so that you connect faster. Okay, so let's go to roots so that people know what roots are later on. So let's do roots because I've just talked about but there are those other things we shall see. The ones we saw in what we call miscellaneous. I may even give them to you as research work. Okay. This is a full topic. And the syllabus says the first class is supposed to end where we have just ended. Now, this topic is very serious and you need to be very careful. If you have your friends who have not yet come for the class, you just take a screenshot and tell them, please come for the class. The class has now started. Roots of a quadratic equation or roots of quadratic equations whatsoever. Now, this one is very serious. Very serious, and I want you to listen. There are things we are going to put into consideration. Okay? So we are going to consider this. Yeah. So what I'm going to do is what you need in the topic. The rest of the questions are going to be very easy. Plus C. We are dealing with the equation, eh? So equal signs shouldn't shock you. So someone will be like, what are we really going to cover here? What are we really going to cover? Now, I want people to first agree with me. Those of you who are doing factorization with me, do you agree with me that if I begin from here, I want you to look here. Are you seeing this step where we had the factorizing? This step. Do you believe that if I open that bracket, I go back here? Do people believe that? Do you believe that if I open those brackets, I go back to the question? Do people know that? Or they really need proof? That is one. And do you also believe me? This is what I'm saying, people. That you like it all. This is what we had. This is what we had as something that we factorized, don't so? But this is how the thing was looking. It was like this. This was, I think, minus 5x, and this was plus 6. Don't so? So I'm asking, do you know that if I multiply this, I go back to the equation? Is it right? Yeah, you know that. So I'm going to just prove it for only this, then the rest I will not prove. Okay? Because we need it somewhere. And there was also another game I want us to play before this proof. So you all know I get this x. I told you how to multiply it the other time. That you get this first one x, multiply it by the whole of this. That's what we said. So I'll come and do that. Then I said that you also come and get this negative 3. You write it negative 3. Okay. Then you also say x minus 2. Are we together? Like that. Isn't it? That's how it is multiplied. Then you proceed, you be like, here, what am I getting? X squared, then here, you're getting minus 2x, then here, minus 3x, then here, you get plus 6. Why I'm repeating all this, I know there are people who have trust issues. So do you see that the whole of this reduces to negative 5x? Then you get that. That's what I'm saying. That you just factorize something. So when you try to reverse the process, you must really get everything. Are we together? Now, another confirmation. I want to begin from this bulldozer thing, this very bulldozer thing. Do people agree? Remember, the bulldozer just gives us the roots. Do people agree with me that this is what they call the root? That one everyone knows. Now, do people agree with me that if at all I want to first do something like, maybe I first say x plus 2, like I'm going back, I bring this to this side, it will be x plus 2 equal to 0, isn't it? Like it is negative 2. Now I've transferred it to the left. It is x plus 2 equal to 0. Do people agree with me that this thing that I equate to 0, do you agree with me that it is what they call the factor? Is it right? Is it right? Because even if I just pinch the screen, you can see in the previous method that x plus 2 was a factor. Do you see that? X plus 2 was also a factor. Remember, these are statements you need. Now the lesson has started. Hey, be careful. This is why I had to start with whatever I started with. Then what else? You all know, again, that if it's like this and I want to reverse, this is 4 over 3. If I bring it this side, it will be minus like this. You understand? That means the whole of this is a factor. But someone may be like, but it is looking weird. That wasn't the factor we had. It is okay. But someone can really be like, this one becomes 3x not so equal to 4. Then someone is like, let me now bring the negative for this side. Then equate to 0. You understand? And if I pinch the screen again, you see that 3x minus 4 was our factor somewhere up there. Do you see it? So there are things I want you to understand here. That when the two factors are multiplied, you go back to the equation. That is one. Then second, when you have a root can help you get the factor. When you understand those two, the topic is easy. That topic of roots of a quadratic equation. One, what have I said? The factors when multiplied, you go back to the equation. That is one. Then two, a root can help you obtain the factor. So are those two clear in the chat? I just want 5 representatives. Do you get those 2 points? We proceed. One, When you multiply factors, you go back to the equation. 2, when you have a root can give you the factor in one way or the other. Are those two things okay? Because now, hey, there are things I want to talk about and I don't want to shock you. Okay. Now, when you see a friend confused, but for you, you've gotten the point. Why I ask you in the chat, you help those people. When someone says no doctor, you ask them, where is the problem? Some of you just be happy when you see your friends not understanding and for you getting, which is very bad. So as you work on them, you're attending to me and you're also understanding. So I'm helping you, you're helping them. But as you help them, you remind them to also be attentive. Yeah. Now, you people have told me that. So I'm going to say, consider this. And after considering it, we are going to say, let's say, remember it is unknown, we can't solve for it. So its roots are unknown. So let's say it has roots. Alpha and beta. This is what really gives most students a time. Someone may be like, why are you really choosing alpha and beta? Because that's what was chosen in math textbooks. And why because you can't solve for it. It is still having unknowns everywhere. So I'm like, unknown. Okay, that's why we are also choosing unknowns. And we cannot, someone is like, but we have always been choosing X for things that are unknown. Why are you really changing your mind? And why are we really going for alpha and beta? Because X is already in use. Are we together? Now, if alpha and beta are the roots, do you people agree with this? Therefore, we can say X is alpha, all X is beta. I want us to be slow. Do you people agree with that? That if those are the roots, then I'm right to say X is alpha or X is beta. Do people agree with that? Yes, thank you so much. Now, after that, do people agree this X minus alpha being a 0, all X minus beta being a 0? Do you see that? So we are having this. We are having this and that. Do people agree that these are factors? Do people agree that those are factors? Let me see if someone has said yes, because I don't want to leave anyone behind. Absolutely, sir. Thank you so much. And now, do people agree with me that if at all I come and say that I now want to multiply, do people agree with me that if at all I'm supposed to come and multiply these factors, I should end up to, if at all I'm to multiply them in any way, I should find ways of ending up to this? Is it right? Remember the roots alpha and beta are roots for the other equation. Are we together? And they can give us factors. And I'm saying if we multiply them, do you agree with me that we are supposed to go back to that equation that only the roots that gave us the factors we are multiplying? That's where the confusion usually comes in. Because without this knowledge, then there are certain assumptions that may disturb you. I'm saying the equations have those two roots. Those two roots give us factors. So the factors, when multiplied, must lead us to an equation. So which equation? It is the equation that owns the roots that give us the factors. You please make it make sense. Does it make sense? I need people who are going to be telling me it makes sense, it makes sense, it makes sense. Does it make sense to you all? You told me that you got the other 2 points. That a root can give you a factor, and I've applied it. And we also agree that when you multiply two products, those two, they should go back to the equation. So here our equation is that 1x squared plus bx plus c. So we are like the roots are alpha and beta. Those ones can give us the factors x minus alpha, x minus beta. And you've said they are okay. So those factors, when we multiply them, they should go back to our equation in question, which is ax plus bx plus c, x squared. That's what I mean. I don't know if we are together there, because now the next thing is multiplying, and it is the most important thing. Should I proceed and multiply? It makes sense. Okay. Someone is like, I'm not understanding things of alpha and beta. Those are just roots. Don't overthink. The problem, some of you, when you start seeing those Greek letters that you're not used to, you start really feeling weird. And that is very bad. So let's now proceed with the algebra. Okay. Now we know that this x, this one, it is supposed to multiply the whole of this bracket. And we are going to have x minus beta, like that. Then you know also this minus alpha, it is supposed to multiply the same bracket, like that. Let me hope I have not left anyone behind. So let's hear from Davi, because I don't want anyone to be left behind. Yes, Davi, what do you have to say?
Thank you very much, Doctor. So I'm asking, what if the alpha and the beta are negatives? Because in the other cases, when we were solving the quadratics, some of the roots were negative.
It
So
is
what
okay.
if alpha and beta? Yes.
If so, alpha can be 2, alpha can be negative 2. So when you let it, do you realize that when you're solving something, you always let it to be a letter that is positive, but the answer usually comes out either as a positive or negative. So since they are unknowns, in math, you don't attach a sign to an unknown. Is it that okay?
Yes.
Yeah, so it is risky. So if it later comes out as a negative, well and good. So just know the alpha is trying to, it has engulfed both positives and negatives. We are just waiting for what may come afterwards. You understand?
Yes. Thank you very much.
Okay, welcome. Okay, I think now we can proceed. Hope people are conversant with that multiplication. Now, if we are to proceed, what next? This one is going to be x squared. Are we together? Then this one is going to be x beta. Put together, then this one is going to be x alpha or alpha x, whatever you want. Then this one is going to be positive alpha beta. Let me hope the multiplication is making sense. Now, after that, we can do some sort of correcting like terms. As a mathematician, for me, I can see that this is x and this is x. So I'm having a thought that I can pull out that x. I just have a thought that I can pull it out. And I will do that. Okay? And when it is pulled out, I can see a negative. I'm going to pull it out as a negative because I'm seeing negatives and negatives. So it's what I'm going to do. So I'm going to come here and say, x squared. This one is going to be x. Then inside here, I'm going to have beta. Then here, it's going to be plus alpha. Always be very careful with this sign. This sign. Because most of you, because you're seeing negative here, even negative here, you're always forced to come here and put negative. But remember, this is already negative. When you put here negative, multiplication will be taking you to a positive, which we don't have. So let me help people know that trick of math. It disturbs so many students of math. When you pull out a negative and you're having negatives here, it's supposed to be a positive. So that when you multiply this negative and this positive, you go back to the what? To the negative. So be careful. Hope you understand. Now, what do you have here? Here you have plus alpha beta. Then you can be that kind of student who is like, but it's better for beta to come, for alpha to come first, then beta. Then you can also be like, these equations normally, they are always, okay, it is always x outside. So x, I'm going to put it at the end. Just like the way you people see ax is squared, then maybe plus bx. What I mean is that x is always at this end. It is always at the extreme like that. It shouldn't come first. Yeah, that we write ax squared, not x squared a. That's why we are also going to shift this x and put it where? Somewhere there. So if at all we are to also come and rewrite, guess what? We shall have x squared. Then this one will be minus. Then what is this going to be? This is going to be beta plus alpha. This is going to be x here. Then you're going to have alpha what? Alpha beta. Now, let me first remove this. Remember what we said, that as you're multiplying these factors, they are supposed to lead us back to the equation that we had. But guess what? Look at what we have just obtained, because we cannot go beyond that. But look at how our equation looks like. So the best thing we can do is to compare them. Nothing else. Nothing else. We can only compare them because we have failed. The A is not coming, the B is not coming, the C is not coming. So the only thing we can do is to compare them. But before we compare them, I want you to be good students of English. I want you people to recall that these ones are roots. Don't forget that these ones are roots, the beta and alpha. So you realize here they have been added, and because they have been added, do you people agree with me that this thing, the beta plus alpha, which is supposed to be alpha plus beta, but it is okay. It is sum of roots. Do you people agree with me that it is sum of roots, that one? Do you people agree? Beta and alpha, they are roots. And we are having beta plus alpha. Do you agree with me that that is the sum of roots? And if it is the sum of roots, you tell me, what is this thing? This one of alpha, beta. For it, what is it? You tell me in the chat. You agree, you say yes, you say comma, you tell me what alpha, beta is. Okay, product. Thank you so much. Some because they have been added. Now, these ones have been multiplied. Because I believe you people know that when they write alpha, beta, it's alpha times beta. This topic is really hard, but you need to understand these things. So because of that they have been multiplied, so we are going to say that this is product of what? Of roots. This question has, this topic or chapter or whatsoever, it has so many questions, and you really need to understand everything. Are we together? Now, that is so important. Now, guess what? We are supposed to compare it with the other equation that we had. But let me ask, can you compare those two? Students of physics, I told you something about comparison. Can you really compare those two? You look at this thing that we finally have, this one, and you also look at this. Can you really compare them? If we can compare them, you say yes. If we cannot compare them, you tell me that thing that is really stopping us from comparing those two. Yeah. The answer, you can say the answer just lightly. If we can compare, you say yes. If we can't, you say no, but attach a reason as to why. You just tell me the reason as why we can't compare them. Yeah? You just say the reason is because of this. I can't get it. And I'm giving you just 10 seconds. Yeah, someone is giving me a very good answer that we can't compare them because they are not yet looking alike. I'm going to use green color. I want you to look here. Are you seeing this X? It is okay even the X is here. Yeah, so someone can be like, the other negative B plus alpha, it is B, so it is okay. Someone can be like, here I'm having alpha times beta, or what I'm reading as alpha beta, then here I'm having C, which is okay. But the problem is, this x squared is x squared alone. There is nothing here totally. So they shouldn't ever lie to you that you can really compare it with this, with that is having A here. So we are supposed to remove that so that in one way or the other it tries to resemble. And we really need to be careful that the x squared is not interacting with the roots in any way. The sum is after the x squared, even the product is after the x squared. So that means there is a way we shall have avoided the A if at all we don't rearrange appropriately. So what is the advice here? We are supposed to make sure that that A disappears. We are supposed to make sure that that A disappears. Yeah. So someone may be like, how are you really going to make it disappear? So, let me teach you. Okay, remember these are quadratic equations. And quadratic equations are always equated to 0. So it may be like, it can be like, let me equate this to 0. Because even the general one is equated to 0, eh? So that means even this one that is supposed to lead to the general one is equated to 0. Now I'm supposed to come and also handle. I think we needed some space here. Just I forgot to leave it, but it's no problem. But let's handle it very fast. Now the general one is this: x squared plus bx plus c equal to 0. Are we together? So if I told you to eliminate that a, I've told you reasons as to why. So you don't need to be asking. We come, divide by a. We also come here, divide by a. We come here, we divide by a. We come here, we divide by a throughout, so that a disappears, whether it's liking it or not. Why? It's on both sides, the left and right, and it has been divided. Okay. What is going to result? We are going to be remaining with x squared. Are we together? Then here we shall have plus, this will be b over a. Are we together? Then this will be the x, then this one will be c over a, then this one will be a 0. And that is the new equation. Someone may be like, why are you really doing all this? We want to create something common at the beginning. Here it is x squared, even in the other one it is x squared. So what we are going to do is to compare the two. Okay, so we are going to come here and say compare. So you people are going to do the comparison, we have the conclusion. If you understand that conclusion, the topic is done and it will never disturb you. But problems usually arise from people seeing alpha and beta, they develop phobia, they develop allergies, and then as if the topic is an allergen. Okay? Now, compare the first one. What was it? The first one was x squared minus, we agree that this one is going to be alpha beta. Isn't it what we said? And both of them are equated to 0, so we can really handle them. Then this was plus this. Okay? And we are supposed to compare it with this. And what is this? All of them are equated to 0, so no need of bringing back the equal to 0. This is b over a, this is x, and this is c over a, like that. So you guys are going to do the comparison. Now, don't ever forget that this is what they call the sum of roots. Okay, and then this is our what? Our product of roots. Very important work. Now, we are going to compare, and we are interested in these two because we already know the roots. Now, we need their sum, we need their product. That is something that is so important. Never underestimate that. Now, I want you people to look at this. If we are to compare this x squared, for it is out because it is just x squared, nothing to compare. But when we come to compare the coefficients of x, look at them, coefficients of x. Can you people see that the negative of the sum of these roots is the same as b over a? Do you see that? Do people see that? That when we consider, let me remove these green things. Maybe I put some other later. Let me put blue to show that this x squared, for it is out. So concentrate on green. Do you see that the negative sum of those roots is b over a? Do you see that? So we are going to write that. Where you get confused, you tell me. So we are having negative. So let me also actually use that color so that things really correlate. So we are having negative. This is alpha plus beta. Then what is that? It is b over a. Like that. Are we together? Then after that, what are we going to get? We are going to get alpha plus beta. And then this will be negative b over a. Someone will be like, why are you doing all that? We don't need this negative. Yeah, we don't need this negative. It's going to give us a 10. It's better we take the negative the other side of the constant and we leave the roots this side. Are we together? Then after that, we are going to come up with the statement. Yeah. And what is that statement? I'll write it at the end. So let me first stop there. So let's compare now the remaining thing, the C. Are you seeing? You can just see this is plus and this is plus, so no problem. But to me, I'm seeing that alpha beta, which is the product of roots, is just corresponding to this C over A, something that is also very important. And that one, you just write it, so it'll be like alpha beta, that one is C over A, that is the product. So the statements I want us to learn or to make are these ones, that each and every time, you like it or not, if you have any equation and you have its roots, trust me, the sum of those roots, so I'm going to say sum of roots, and for this case it is what? Alpha plus beta. Or even if I don't put the alpha plus beta, after all it's already there in the above one, it is just negative b over a. That negative is very key. People normally forget it. Then also here, I'll be like product of roots, which is alpha beta. Product of roots, it is C over A, like that. That's all you need. That's all you need. We are going to be using it in calculating numbers. First, get the literature. Now, after understanding those two, now we are going to rewrite this. Are you seeing this? We are going to rewrite it. Okay, now maybe to do that very well, I'll first maybe tell you that this is going to be like my equation 1. I'm going to just do some replacements, just to make sure that we don't really find that time when we reach those earlier things, complexing the earlier stuff. So this is going to be my equation 2. Now, I'm going to be like rewriting equation 1. What are we really going to have? Rewriting equation 1. Yeah, we shall end with completing squares. It is the easiest. Yeah? So what do we have here? Rewriting equation 1. So rewriting equation 1, I just want us to have the x squared, which is a constant, okay, minus, remember in brackets here we have been having the sum of roots. So instead of the sum of roots, alpha plus beta, I'm going to write the word, that sum of roots like that. Then I will have x here, then plus. Are we together? Then where I had the alpha beta, the product of roots, instead of alpha beta, it's better I have the word product of roots. Yeah, someone has raised up their hand. I don't know why they are confused. Equal to 0. So this is very important. Very important. In whatever you're planning to forget, someone is making our screen dirty, and that is very bad. But I'm saying that is very important. How people are writing important things and not just looking ones. So in whatever you're supposed to learn today, that thing is very key. Because all examples that we are going to handle, they are just rotating about whatever you're seeing on screen. Yeah, those things of sum of roots, product of roots, that equation of rewriting equation 1, that one that has the words. So never forget, what really puts students off, it is this negative. It is negative here first, then here it is what? Positive. Very important. Are we together? Now, our question set, the questions I should be expecting right now. Our questions set, our questions attempted. Before we go into how questions are attempted, there is something so important that I want us to talk about. So important because there is algebra involved in this. You see, with this, I'm not supposed to do a lot of numbers, especially when I brief you about the algebra. Okay? There are things we are going to need in this topic. So before I even do the very first exam, let me first show you some of the sort of algebra we may need here. Very important. So the first one. And it is this algebra that really puts students off, because they know everything that I've just talked about, but then when they reach calculations, that's where they get stuck, simply because they cannot do the algebra. And this is so important, okay? Now remember, we have only two things. That is alpha plus beta, which is the sum, and then we also have alpha beta, which is the what? The product. Now, everything that we are going to be handling should be in this format, okay? So I'm going to be like everything must be in terms of those two, either both of them or one of them, because that's all we have. So if at all you see any algebraic expression that does not really respect those things, you think twice. That one I'm telling you point blank. You think twice about it. And how do you think twice about it? It's what I'm going to teach you right now. So there is a certain step I want to skip because I want to assume that people know it, because I talked about it in the previous class. There is someone called Favor. Favor, leave the class. I think let me first remove Favor from this class, and maybe they will have to learn. Let me first remove them. Where is remove? Where is remove? They are really misbehaving. I've even reported you to Zoom and I've submitted a report. So Favor is no longer in class. The next person is also going to do that. I'm going to remove you from class. So I'm like, how do you handle that algebra? And how do you really handle everything? So this is what I've been saying that I wanted to skip. So it is, you know something like a plus b squared, and you know whatsoever it's equal to. So instead of a and b, I'm going to use alpha and beta because it's what will be coming in here. So look at your alpha as your a and your beta as the b. So when these things are squared, what really comes out? It is alpha squared, yeah? So we have alpha squared plus what else? 2 alpha beta, what you people know as 2ab, then beta squared. And this is the beginning of the confusion in the topic. So I want to first ask people, are we together there? I've told you, look at your alpha as your A, your beta as your B. So this is the thing we expand as a squared, then we say 2ab, then we say plus b squared. I just believe that is familiar to most math students. So I hope my assumption is right. Are we together? Okay, thank you so much. Now, let's proceed. What do I really want to bring in at this point? I want to really make this the subject. As of now, you may not appreciate why everything is being done, but when questions begin, you will appreciate. Now, this and this, I'm going to make them the subject. So making them the subject simply means they are going to be on one side alone, and that side may be the alpha squared plus beta squared. Like they on one side, they are together. Then I don't want to see this. So that means I'm taking this away, and maybe I'm taking it where? The other side. Are we together? And guess what? I will have the alpha plus beta. Are we together? And this will be a squared, okay? Then I will have the minus 2 alpha beta, something like that. That's what I will come up with. That's what we have. I don't know, has that statement confused anyone? If it has made sense, just write in the chat, proceed, we go. You will see why that is happening. And you really need to have some knowledge on how everything is derived, so that in an exam, you really have a point of defense. Okay, now, I've just expanded and then made alpha and beta the subject. The problem, people don't concentrate. Then when I ask whether it has confused anyone, they check if it's really confusing. Then they say they are confused. So you're supposed to be extra. Maybe this is what confuses people. Let me show them. I'm bringing the alpha plus this, it is staying this side. Are we together? Then this one is the one I'm bringing this side, and it is coming as minus 2 alpha beta. Are we together? Then this side, only two things are remaining. That is alpha squared and beta what? Beta squared. But I'm interested in the other alpha squared plus beta squared. So I force them to be on the left-hand side. That's the step I miss, but I at least try to say it verbally so that people can understand. And I always do it in all math classes because it is very key. So here I'm just switching positions. What is on the left and putting it on the right. What is on the right and putting it on the left. So let me hope those we are saying not clear. Let me hope things are now clear. So that is very important, and we are going to use it in this very class. Okay? Now there is something else, because work does not stop there. We have not studied a lot of algebra, but there is something we need at this very point. Though the topic is a term 3 topic, and it is binomial expansion, but I'm going to say something small about it. Okay? What do you think we are really going to obtain? Remember, we have been handling okay, let's now handle this. A plus b Thank you, Alfred. Thank you for calling. You're telling me that someone else is sharing their screen and you can't see my screen. Who is sharing their screen? I don't know if the screen is back. Is it now back? Yes, the person who was called to notify me, thank you so much. I couldn't tell. You're supposed to call in case something like that comes up. Is now this, okay, thank you so much. Now, I don't know where I had stopped. I don't know whether we are together there. Had dropped something off and I was explaining something. I said that I was interested in making this to the subject. This and this. Are we together? So I carried the whole of this and put it this side. That's why you're seeing it here. You understand? Okay? Then this side I remained with alpha squared plus beta squared. Now I put alpha squared plus beta squared still on one side, then the other one went the other side. I just switched position. That's what I was saying. And we shall need it as we calculate, you will see. Someone may be like, why are you really writing it in that format? Why are you really writing it in that format? Let me tell you. When I look at this, this is alpha plus beta. So this one is in terms of sum. When I look at this alpha and beta, this one is in terms of product. Do you understand? So they are in terms of the other two things we need. But when you look at alpha squared and beta squared, these ones are not in terms of either product or sum. You understand? That's why I'm putting them on one side, because it is alpha squared and beta squared. If I ask you, are they in terms of sum or product? They are not. Because sum of roots is alpha plus beta. This one is alpha squared plus beta squared, so they are different. The product is alpha beta, and alpha beta is nowhere. That's why they are alone on the left. And I'm equating them to something that has sum, something that has product. So there is a way things shall be simplified. But this is just literature. When the number comes in, you're going to see how cheap things are. Are we together? So we go. So I was telling you that there is a topic called binomial expansion where we're supposed to look at something like this. But let me brief you just right now, because you have some idea. Okay? And this is it. You people, this is power 3. So if at all I tell you to expand that, you people should appreciate that I can split power 3 like this. I can have this one as power 1. I can have this one as power 2. Do people appreciate that? That is right, and I believe you know. So I may say power 1 is just power 1. So I can just write it like that. Then I be like a plus b squared. I know that it is a squared. I know it is 2ab. I know it is b squared. In case the screen goes off, you're supposed to call me, not writing a lot of messages in the chat. Don't think I am looking at the chat. I concentrate on the screen. So thank you, Alfred, again. Now, let me hope we are together at that step. We are building the concepts which make the complex ones hard. So you're supposed to pay attention to the basics. Now, we all know that this is supposed to multiply the whole of this bracket. Also, this b is supposed to multiply the whole of that bracket. So I can come and show that step and be like, a is supposed to multiply that bracket, a into a squared. I always want to write this math when people are following so that you get that vitamin. Otherwise, I have these things already written. I can just come and expose all that. But it really always doesn't work out for math. Yeah, because as I do and as you follow up, you can also later on write on your own. But when work is already written, you reproducing that work, you always be checking. But here we write together, we rectify the mistakes together, things like that. Now, after that, the next steps are the easiest. When I leave you behind, at least raise up your hand, I check the chat to see a message you sent. This will become a cubed. Are we together? Then this will be 2a squared b. Are we together? Then this will be ab squared. Are we together? Then this will be a squared b. Are we together? Then this will be ab squared. Are we together? Then last we shall have b cubed. Very nice math. Now, you all know that when you reach a certain step, it is always wise, especially when you realize that I'm about to reach the final step. But we shall do that. Let's first collect like terms. Let me use some bit of this color. I can see a squared b here. I can also see a squared b here. Are we together? Do you see a b squared also sharing something? Do you see some other common terms? Because I don't want to be struggling alone and identifying everything on my own. We really need to help each other. So I'm also seeing ab squared here. I'm also seeing ab squared here. Are you seeing that? So we proceed. Someone may be like, what of others? Why are you being a racist? This one is a cubed and this one is b cubed. They don't even relate in any way. This is a cubed and this is b cubed. They don't relate, but others relate. So what is next? I will just leave the a squared as it is. Are we together? But then I will come and handle this one in a very nice way. Because it is 2a squared b and a squared b, that makes it 3 because there is a silent one here. Do you see that? So it will become plus, this will be 3a squared b. Very nice, okay? Then there's also a silent one here. So this one and this two, they also give me a 3. But this is a squared b. Are we together? Then lastly, guess what? I will have the b cubed. So are you seeing how the math is becoming sweet? Because now the thing is becoming simplified. And that is very nice. So someone tell me, can we really, because we can, this one we agreed it is out. Can we do something about this one, if I may ask? Can we do something about that? Someone may be like, why don't we factorize these two? When you factorize those two, you're going to go back to the question. You're going to go back to the question, but you don't see it coming. You don't see it coming, but you go back to the question, something that is really bad. So I don't advise you to handle those ones. You will end up going back to the question, something that is very bad, and I don't advise it. Are we together? So we are working on these ones in the middle. And when you handle this, you will end up having something funny. Still a squared will be funny. And it is something that we are avoiding. You know that we just need something that is looking like a plus. Oh my God. Okay. Now, do you look at those two and tell me, is there any way you realize that we can handle them? Is there any way you see how those two can really be handled? Okay. So there is a step we had that I believe everyone got. This was a cubed. This was 3 a squared b. This was 3 a b squared. This was b cubed. That's where we were. Okay, in simple terms, you people just tell me what is common here and it is also common here. That's what I'm asking in simple terms. You tell me in the chat. What can we pull out? Someone is like, pull out 3. Someone is like, pull out 3ab. Thank you so much. We have a common factor of 3b. You're leaving out a. That is very bad. So I think you people have realized that. Very cheap things. So me as me, I see 3 as common. I see a as common. I also see b as common. Though the powers may differ in one way or the other. So 3ab is common. So I will bring back this thing. I told you that every time you are approaching the final answer, what you started with should come back. So it should come back here. And it's like, don't forget me, people. It is a plus b cubed. Then what do we have? We are having a cubed, okay? Plus, you people are saying 3ab is common. That's what you people are saying. And then what is remaining inside? Here it was a squared. So when you pull out 1a, it remains 1a inside. Then here it was b squared. So when you pull out 1b, this one remains as b. Then never forget the b cubed. Do you see that? Very nice work. Now guess what? Guess what? This one is a plus b, eh? This one is just cubed and the cubed is outside it. So it's like, yes, we are having the sum, but the sum is actually just cubed. So the sum is existing. Even here you're having a b. So a b is actually a product. Here you're having a plus b. It is actually a sum of the roots. So this one is very clear. Even this one is very clear. But this one is a cubed. This one is b cubed. A cubed and b cubed, they don't even relate to the other things that we want. So what are you supposed to do? Put the ones that are stubborn on one side, then also put the other ones that are aligning with what we want on one side. But before I do that, let me first rewrite this as alpha and beta, like in the other way that we want it, in our normal way. So what do I mean? This is what I mean. I mean first having this as alpha and beta, because that's what we are going to be using in all calculations. Let me tell you, I'm trying to give you a foundation for all the calculations we are going to meet. You understand? Remember this thing. This is where they normally ask you questions. We are going to see them. There is where you're supposed to express. There is where you're supposed to now find the new equation. There is one that deals with just showing proofs. And we are going to handle all that. Are we together? Now, what is this? It will become alpha cubed. Are we together? Then here it will be 3. This will be alpha beta. Together. This will be alpha plus beta. Then this one will be beta what? Beta cubed. Now, I was telling you something. That if at all anything is not in terms of sums or product, put it on one side. Those that are aligning, put them on one side. Now, I'm going to play the other game again. But this time round, allow me to do it at once. This one is okay. This one is okay. It is okay with this. Now, these are the things I need, but I want them on the left, but currently they are on the right. So I assume they will stay on their own side alone, and it will be the left. So I will have this. Be good mathematicians. Someone may be like, but doctor, the alpha cubed has been this side. Now you're putting it this side, but you're not writing it as a negative. Why? I don't want you to be those mathematicians asking me such. I've explained that this alpha cubed and beta cubed, they are supposed to be alone on their side, so leave them there. And I've decided that side to be the left, because that's where I want. So this one that is in good mood, or that is in line with what we want now, it's the one that you're supposed to carry the other side. And when it goes the other side out, how shall it be? It will find that it will find this minus, so it is going to come, but it is going as a negative, because where you're removing it from, it has been a what? A positive. I don't know. Do people get this? Or it confuses them? Do you people get this? Because we shall need it. And it's not there in the logbook. So that's why people say this topic is hard. That's why I told you that when I thought and I was like, why do people want me to cover these cheap things? I recalled these things of alpha and beta and also completing squares. Then I was like, yeah, there are things people are complaining about. So do people get that statement? Can you really prove it on your own? Because you're supposed to in an exam, in case you forget it. But when you do a lot of numbers, it becomes part of you. If it doesn't, you're supposed to prove it the way I've tried to prove it for you. It's the same way you're supposed to do in an exam to remember it correctly. So do people get that expression? Because we are going to use it. Okay. Okay. Now there is the last one. Yeah, but these ones are very cheap. Those are the hardest. Those are the hardest. Yeah, those are the hardest. This is the last one. Look here. When you have something like this one is a complete red flag, because for it is not even in terms of sum or product. Total red flag. But at least we know it is alpha squared. Then here we are having 2 alpha beta. Then here we are having beta squared. Don't look at those alpha and betas to confuse you. They are very cheap. So I'm getting that from my a minus b, which is squared, where I always have a squared, minus 2ab plus b squared. So I don't really want anyone to be confused, okay? So I can rub it off. Now, what is it? When I look at these things, I see something funny. I see the alpha squared plus beta squared. But remember, the alpha squared plus beta squared is already something here. Do you see? It is something already. You look here. It is something already, and we shall need it. It is something already, so you're not supposed to take that for granted. So we go. You can first do some sort of rearrangement. Rearrangement. What do I mean? First put the alpha squared and beta squared together. Yeah. So you're going to come and be like, okay, let me first put the alpha squared plus beta squared together, because you know it is something, okay? Then you end with the 2 alpha beta. Why you're putting the 2 alpha beta the other side? Because at least for it, you trust it. It is already in terms of product, so you'll have something to substitute. But this balance is a bit weird, but it is having something. It is equal to, okay? You just want to have this one also in terms of sum and product. So you think as a mathematician, you be like, this one is just good to go. You understand? That one is very cover. You be like, what of this one? How am I going to handle it? But remember, it is also equal to something. So when we scroll up here, do you see that it is equal to something? And that something is already in terms of sum and product. Look here. I don't know whether people are seeing that. That is what I'm talking about, the alpha squared plus b squared. These are the things that make the topic hard. But as you start to get confused, remember there is completing squares. Though for it is very cheap, yeah? Very cheap. So I'm going to come and put what you guys have just seen. You've realized we are having this squared minus 2 alpha beta. But that alone was for that. You understand? But remember this, there is this one also. Hope you get it. Yeah, this one is here. Okay, then this one is becoming that. Are we together? Very cheap. Very cheap. Okay, then I'll come and say, what do I have here? It's becoming alpha minus beta squared. So finally, we also have it in terms of sum and product. This one is going to just remain alpha plus beta. This, if you know math, minus 2 sweets, minus 2 sweets. These are the sweets alpha and beta. So it becomes minus 4. Don't forget the alpha beta. And you should be in position to derive these things on your own. Yeah, these are ones. Hey, it's midnight. That's nice, because we are done. because these ones are now just supposed to be applied. And when I start applying them and for you I've already forgotten, don't feel bad. Just make sure when you go back and see it, you can really have all this. I think I'll even provide you with this workbook, but I won't, because I want people to be writing these things on their own. Are we together? So people, you tell me, how is that? Do you also try to get that? We are fighting one thing, writing things that are not in terms of sum and product, forcing them to look like that. So what we had was alpha minus b squared, and it didn't have things completely relating to what we want for the topic. So we really looked for ways of how to really bring it to life. Something like that. Okay? So when you need a square root, you know what to do. You know what happens. You can put the square root and you get the next thing. That one also works. Someone may be like, when is the square root really going to work? I'm going to show you where, how, and when, but that is the hardest. Okay? Someone may be like, square root. Let me show you. So if you're to apply a square root here, it will remain as alpha minus beta. Not so? And then we have agreed, you can just put a square root, then you maintain the rest. Okay? So this will be alpha plus beta. This will be squared minus, this will be for alpha beta, like that. Are we together? What are you going to have next? Okay, let's just assume that one stopped there. But this is not how questions are set, but these are things we are going to come across. And you're just supposed to apply it there and then. They believe that you have the derivations at head. So what if we encounter what we call the difference of two squares, which is like alpha squared minus beta squared, which I also talked about the other time. So you all know the difference of two squares. We agreed first do that. After doing that, you realize they're dealing with alpha, they are dealing with beta. They're dealing with alpha, they are dealing with beta. Then what next? You simply add and then what? Subtract. So this one is sorted because it is the sum of roots, but this is not sorted, but it is here. Isn't it the one? It is a square root of something, with something is already in terms of sum and product. Provided you have sum and product, things will be very easy. But if what you're interacting with is not sum or product, my dear, the topic is hard. Okay? So you need to befriend all these cheap things that are going to be coming your way. Hope things make sense. So the rest of the things, we shall find them there. The rest of the things, we shall find them there. So let me just give you a hint. In case these people really want to make your life hard, of which they can't, it is so rare, where maybe they give you something like this, beta power 4. I think I'll give you this in exercise, but let me give you the hint. You first handle it as squared, but this is squared. Remember, alpha power 4 is the same as alpha squared squared. The math is now becoming serious. Beta squared squared. So you have a starting point. I think I'll do this for you in revision. Okay? Just because revision is premium. That is the only bad thing. But I'll do that for you in revision. But trust me, if at all you have some nice humor of mathematics, that is very cheap. With that hint alone, you can really handle the work. So I think that is enough of the derivations. So I want people to tell me that they are ready for the first example. First, look at them. Just tell me, because now I want to do people have question banks of the old curriculum? Because you at least need to do those computation questions of old curriculum before we even go to scenarios. Scenarios need their special time when we are done with the syllabus, so that we just revise each mock paper that comes. Mocks are coming very soon and you should be excited. So that you will have things to try about. Are we together? So are people ready for the very first example? So that people really look at how things are set. I want to begin with the UNEB number if that is possible. Are you ready? Let me check this book of hours. I see if we can get a certain number. See if we can get a certain number. Are people ready? Find the roots. Okay, let me see if this was a special topic this side. So you should be using this time to at least rest. Yeah, you rest core. You see, I told you in the old curriculum, this was a full topic. You can see the sum and product of quadratic equation. You can see these people were also struggling. So I think let's just go straight away to their numbers. You see, they even have the things that we have been dealing with. So let's first handle this. Yeah, yeah, very cheap number. Here, you don't want to waste time. Let me see if people can really give it a try. Let me show you that this work is really very hard. Okay, let me see if people, yeah, people are ready. That is nice. Now, you tell me in the chat, write down. They just want you to write down, not calculating. So you can really say it. They want the sum and product of roots. You tell me in the chat, what is the sum of roots for the first equation? Hey, that question is hard. If you pass it, you know mathematics. If you're there and you pass it, you know math. If you don't pass it, my dear, you still have a lot of things to learn. And you're not supposed to leave class. And many of you are going to fail. For the first equation on the screen, what is the sum of roots? What is the sum of roots? For the first equation on the screen, what is the sum of roots? Write in the chat. Someone is saying 6, another -2, some is saying 2. I'm liking what people are writing. Some 6, some 2, -6, -6. Hey, hey, negative +6, 2, -6. Do you see? There is a confusion between two numbers and two signs. The two numbers, it is 2 and 6. The signs are positive and negative. That's what really makes math very hard. And let me educate you, okay? People have already forgotten. You people, the sum we are dealing with is the sum of roots. That's why I told you roots and factors are different. Do you remember that we said this -6 you're picking? You people, it is the sum of factors. Do you remember that I told you that I'll bring this in the future? So it's not what they are looking for. Here they are looking for sum of roots. That's why I've endeavored to be writing these things on my own so that I can really show you something, and I show you the statement which we wrote together. Do you see the sum of roots? The sum of roots is -b over a. -b over a. So you're supposed to first write the equation very well. Don't panic. Don't panic. So I'm only going to do for you the first one. Let us agree. I'm doing the first one, and you shouldn't fail the next part B. The equation is 3, -6, and 2. So let me write here. I always like it when at least you first fail. Because when you don't fail, you don't get a shock to really wake you up. To know that, hey, things are really serious. Let me pull up my stockings. Okay. So when you look at that book, it really had completing squares first, then roots later. But I'm trying to follow the syllabus. Where the syllabus really favors us, I do that. You see this way, they wanted us to apply completing squares. But again, they wanted us to use it to solve. So for me, I just want, we solve at once, we apply at once. But then there is this part I'm handling right now, sum and product. So you just know that we are on the right track. And the lesson is done. You understand the first example, you have understood the rest. Okay? So the first example, they're giving us this equation, 3x. It is the equation. So the moment you forget to put equal signs, you're done. Because the word roots works with what? Let me hope that is the equation. Let me check again. Yeah, it is the one. Now they want the sum and product of roots. So we know that for you to get those things, this one should be, like we shouldn't have anything here. You should first remove it. Before you do anything, before you explain yourself, first remove it. Say over 3. Don't cancel your work. Just put over 3 throughout. After putting over 3, are we together? Now you come up with this. What do you have here? -2x. Are we together? plus 2 over 3. Are we together? Then you say equal to 0, like that. Yeah. Then you come and be like, what is here? That is negative 2. But the sum of roots they need is negative b. Ha, ha, ha. Let me do this. Let me first take back people to the comparison. They see it well. Where is the comparison? It is here. I want you to first compare these things well. Do you all people realize? I'm just going to mention this, but listen carefully. Do you people appreciate that for you to get the sum of roots, you just look at what is here and make it a negative? Do you understand that when I make the statement that way? That after you've divided throughout by a, for you to get the sum of roots, just get what is here and make it a negative. Then for you to get the product, just get what is here and pick it the way it is. Does that make sense to you? That for you to get the sum and product of roots, first make sure there is nothing here before x squared by dividing throughout by whatever is there. If nothing is there, you're good to go. For you to get the sum of roots, get whatever is here. Now, what we have currently there is positive b over a, but the sum is here is negative b over a. That means to get the sum, look at what is there, make it a negative. But this is sum for the roots, which we are using in things of alpha and beta. The other sum we began with was sum of factors, and I explained why, so forget it. Now you're learning something new to do with the roots. That's why I wanted to teach it immediately after the other one and in the same class, so that you get it. And for you to get the product, just pick this one the way it is, because here it was a positive. Even here the product was still a positive, but the sum was negatified. I don't know whether people are getting that. You get it that way because it is the best way we can have it. So I need about 5 people to support me that yeah, we can proceed. That after dividing throughout by the a, whatever is the coefficient of x, make it a negative to get sum of roots. Whatever is there after the c over a, the way it is, whether negative or positive, for it just carry it. But for the sum, change sign. For the product, don't change, just carry it the way it is. Twende sa. I've liked that. So we are going to be saying it twende sa. Let me see the person who has said twende sa. Samsung. Twende sasa. Yeah, that's what we are supposed to be saying. Twende sasa. Now we go back. So I'm not going to explain a lot. Divide throughout by a. When you write something like that, now you come and say, so that sum of roots. What we have there is negative 2. So for you make it a negative and it becomes a positive. Are we together? Then the product. That one you just carry it the way it is. Just carry it. For me, I'm seeing a 2 over 3. So you write it as 2 over what? 2 over 3, period. Period. Don't waste time. That is it. Yeah. The next question is yours. Look at it, part B. I want the sum, I want the product. Hurry. You just write them in the chat. You don't need to do any calculation. You just look at it, you do the math in the head, you write the sum, comma, product. All of them at once. Sum, comma, product. Sum, comma, product. For part B. Sum, comma, product. For part B. Please hurry, 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 hurry. Hurry, 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 hurry. Hurry, hurry, hurry. Hurry, hurry, hurry. What do people have? Some of you are having the sum as positive. That thing is going to really affect you. That thing is really going to affect you. Some of you are dozing, you're just waking up. Let me see. Sum is negative 11 over 5. That is correct. Product is 3 over 5. Very correct. So what really makes this topic hard, that people mess up from the beginning. This is not how questions are set. We are going to see the questions maybe in the next example. Okay? And you really need to be extra careful. That's why we began with this simple one so that they really guide us in what next. So let me hope I've not left anyone behind. Can we use decimals? We shall see that as we calculate, but fractions really make your life simpler. Use decimals if it is a final answer, but it's not even the final answer, so why stress yourself with decimals? Okay? Mathematicians, we go to part C. Go to part C, sum and product. You write the sum, you put a comma, you write the product. Part C. Part C, that one is very cheap. I just expect answers straight away because we don't have even anything to divide. It is already x squared, so it's ready for us. We are on part C. Sum product. Hurry. Let's hurry. People are fading it. People are saying -1. Are you people serious? Someone is saying product is 0. Hey. People are saying -1. Really? People are saying -1. Is it -1 really? Yes, I've accepted the sum is -5. Okay. But people are saying the product is -1. Is it real? Is it real? And now to make matters worse, all of you are writing 1 in the chat. And you're wrong. The product is -1. So that means you've not yet understood. The product is -1. Me intimidating you does not change the math. The product is -1. But now you people are just using intimidation and you're changing your minds. The product is -1 because you're supposed to first arrange that equation the way it is supposed to be. But then after just simple teasing, people are changing their minds and the math is changing. Math does not change by really intimidation. So you had to first x squared plus 5x minus 1, okay? So it is in the format we really need it. So the product, you just carry it the way it is. -1 is the product, but this one, to get the sum of roots, you make it a negative, from positive to -5. That is it, okay? Now, someone is like, math is interesting until they give you a scenario for the same topic. Hey, until they give you a scenario for the same topic. Now, this is what people are saying. This is what people are saying. They are saying, this is now case 2 for examples that come in this topic. They are saying, write down the quadratic equation, the sum and product of whose roots are these and these respectively. You listen, hey, this one is the sum because they're saying respectively, and this is the product for the roots. So they want you to write the quadratic equation whose, okay, the sum of the roots of that quadratic equation is 3 over 4. The product of the roots of that quadratic equation is -7. So they want you to write it down. So it is the other thing I told you. This formula, it's the one that is really going to help us. That's why I told you that in whatever you're planning to forget, don't forget it. Do you see that? I even put for you the word very important because it's going to simplify our work. So you've been given the sum and product, so you just fix it there. You're not supposed to write that formula. No one wants to see it. Formulas in math, especially the pure part of math, they don't need a lot of your confirmation and showing off. Just substitute in your formula. If you want to write it to be completely neat, it is okay. But why would you waste time? Okay, so that formula is very key, especially that negative that comes after the x squared. It is one negative that is so prone to be forgotten. Okay, someone is using vulgar language in the chat. I'm going to remove you from this class. You remove that message. You remove that message before I remove you from this class. I've stopped the class. You cannot reply your friends just like that. I told you why we are in school is not to understand this, is to connect. There are so many people that have benefited from those communities we make. I really hate it when I see someone embarrassing a friend. Delete that message and I'm giving you less than 5 seconds, or else I'm going to remove you in the class. A friend said positive one, you embarrassed them in the chat. Okay. Person has refused. Let me look for them. Okay, maybe they can't delete. Let me give them a benefit of doubt. Maybe they can't delete a message from the chat. Remove me because I can't delete. You see, I'm very intelligent. I knew. But please apologize to the friend. If you can't delete, apologize to the friend. Tell them I'm really sorry. Yeah, at least apologize. That is very bad. That is very bad. I would even end the class if at all you hadn't responded. Has that person really apologized to the friend? Apologize to the friend? Sorry, I'm really sorry. Yes, thank you so much. I think now we can proceed. Now, I've told you that formula is very important. Okay? So when a question really gives you the sum and product, first do this. You'll be like x squared equals, you know I'm going to put the sum here, put here x, you know that I'm going to put the product here, then I equate to 0, period. Period. Okay? This is x, don't look at it as multiplication. Eh? This is x, this is x. So you come, what is the question saying? They are saying the sum is 3 over 4. Okay, so I'll come here and put 3 over 4. Yes. What is the product? The product is negative 7. Negative 7. When they say positive 7, when they say 7, I go there, I put plus 7. Do you see that? So what are you coming up with? You're coming up with something like this, 3 over 4. This is x minus 7, also equal to 0. So you can just leave it like that. They will mark your work. But what is the best thing? Why would you have a fraction? Why would you have a fraction in your work? So the best thing is you come here, multiply by 4, go together. Then you come here, multiply by 4. Then you come here, you multiply by 4. Then this side you multiply by what? By 4. And guess what? You will come up with something like 4x squared. Okay. Then this will be minus, this will be 12x. Then this will be minus, this is 28. But this will remain as 0. So that is some neat work. So you have that alternative. Do you see that? But that question can come. Yeah, that question can come. Though they are the other more complex ones that have alpha and beta. But we are going to split them. Don't worry, they are cheap. So let me hope we are together there. Now, the next thing is you people handling the next example. You do it for me. This one is a bit, it's having some sort of unknowns. They are saying, given that one root of the equation this is 3 times the other, find the value of k. This is what really makes math hard. You'd be like, I thought doctor taught this. Yeah, and yes, I did. I taught. But then you'd be like, how am I really going to handle this? Where am I going to get the value of k? And let me ask you something. When you look at k, because now, okay, let me first write this equation and then we reason together. I'm also going to assume I'm the student. The teacher taught me how all the basics are handled, but then I come across such. So it's 3, 4, and k. Let's write it here. We reason it out together. I'm also the student. I don't know what to really do. So it is 3, 4, and k. So 3x squared. This is plus what? Plus 4x. This is plus k. Okay, equal to 0. So they are saying that there is there is the first root. Okay, the first root are the values of x. So I'm going to use x. Don't worry. So I'm going to be like the first value of x. They are saying, let us say that values may be a. I'm just assuming. So they are like the other x value is 3a. Are you people getting? Are you people getting? I want to show you that these things are really very cheap. The math is saying, given that one root of that equation is 3 times the other, find k. So that's the equation. Are we together? Roots are the values of x. Why x? Because the equation here, it's very nice. It's already in terms of x. So the roots shall be x values. So they are not sure of the roots. They have not mentioned them. But one is 3 times the other. That means when one is a, the other one is 3a. Sir, how are you getting 12? E? Oh, thank you so much. It is 3. This is 3. Oh my God. You people, no one is calling me. For me, I'm just saying hands up. Let me hope that was the concern. It is 3 because the 4 cancels 4. Are we together now? When you see me delaying to respond, you give me a call, yeah? Okay. Okay, I think now we are good to go. Now, let me hope now we are together with this question we are trying to reason. So now we have the roots. We have the roots. These are the roots. But remember, it is very bad for you to start dealing with roots when you have something here. So the best thing every time you're dealing with roots, first try to eliminate it. Divide by 3, divide by 3, divide by 3, everywhere divide by 3 to really be on a safe side. Are we together? What are you going to come out with? You're going to have x this, then here you'll have 3, this shall be x. This shall be k, this shall be over 3, this shall be a 0. Are we together? But remember, you could even have let these ones to be your roots. It's very okay because that's what the math is saying. So our first root is a, the other one is 3a. You understand? Who can tell me? If these ones are our roots, actually they are the ones, let's use those to really save time. One of our roots is a because the other is 3 times, it is 3a. You understand? Those are roots. So we are dealing with sum and product. Who can tell me? You write in the chat, they are sum and product. Sum, comma, product. Please be fast. We are doing sum, comma, product in that equation. We are having the roots already. It is 3a and a for reasons you know. But now we have the equation. So extract for me the sum and product of the roots. Yes, be fast, please. I don't want us to waste a lot of time there. I really want to see if the people I'm really handling as of now, they know what to do. Okay. That is nice. But someone is attaching x. Please don't attach x. It is very bad. So the sum is negative 3 over 4 and people are trying. The product is k over 3. So don't ignore the k. It is so important. So the product, you just take it as it is k over 3. The sum, you add a negative. So you're having the roots. It is a. And the other one is 3a. Okay? Oh, someone may be like, but this is a topic where they use alpha and beta. Let me use alpha, which is okay. Someone can be like, let me use beta, whatever you want. So the first one, if it is alpha, the other one is 3 alpha. I can even use Q, I can use P. This is math. So the sum of those roots, you can first come and be like, sum of roots, it is negative 4 over 3, isn't it? Then you put a comma and say product. Remember, they want the value of k. Product of roots is k over 3. You people, product of root is already having the unknown k. So it may not help us as of now. What may help is the sum. Because the sum is just a value 4/3 and it is having no unknown. But remember our roots, it is alpha and 3 alpha. So how do you write their sum? Their sum is adding them. Let me hope that is very obvious. So the sum of roots, you just come here. The roots, it is alpha and 3 alpha. So their sum, you add them 3 plus 3 alpha. And what do you have this side? It is -3 over this. Are we together? This one becomes 4 alpha because they are the same is equal to -4/3. If you're a good mathematician, you can realize that the 4 is cancelling on both sides and the alpha is coming out to be -1 over what? 1/3 like that. But someone is like, why are you getting alpha? Is it what they want? No, I'm really trying to forge life here. Someone may be like, okay, what if I didn't really have that knowledge of me wanting to get the alpha first? This is the technique. If at all they want the value of k, and the value of k is on part of product, first come and pretend as if you're dealing with product. So the roots are 2, they need the product, or they need the value of k. So the roots, it is alpha and 3 alpha. So product, you multiply them. Then this side, you're going to have k what? Over 3. So you realize you cannot get the value of k without the value of alpha. So you'll be having 3 unknowns in the same. So you will be having 2 unknowns in the same equation. Something that is really scary. Something that is really toxic. Something that is really risky. So you're supposed to first make sure you find ways of getting the value of alpha. That's why we made use of the sum. For it didn't have unknowns. So it helped us get the sum. So do you see that these are numbers I'm not even supposed to do in class? Because you'll be having the technique because we taught. So you're now supposed to apply knowledge. That's why UNEB avoids setting past questions. It always wants to see if really students can reason out stuff, okay? So after this step, let me hope I've not left anyone behind. I will have 3 alpha squared, then this side I will have k over 3, okay? So I'll have 3 alpha is -1/3, then this will be squared, then this side will be k over 3. Do you see that? Then I put 3 the other side. And then if you really know math, when you use a calculator, what are we going to come up with? For me, I'm seeing a 1. According to the little math I know, I'm getting the value of k as 1. I don't know if anyone else is having that. So our product, if you substitute, it will be 1/3. So do you see, they can really set different tricks, just trying to play on your mind. Now, the next example is the example that they normally set. And you're going to struggle with it. That one, I'm going to be frank with you. The next 2 examples, when we are done with them, the lesson shall be a success. Because completing squares is just something small, 10 minutes and it is done. Okay? So do you see that technique? The question gave us the equation that had unknown. They wanted the value of k. But they told us something about roots. So we had to find ways of playing with the sum and product. So someone who cannot extract the sum and product very well cannot pass. That's why students over complain about this topic. They think they have understood, but because they extracted the sum and product wrongly, they get a certain imagination that maybe I didn't understand the topic. So basics really what matter. Are we together? Now, next example. Let me up here together. Okay, so let's handle it. What is it saying? I don't know if these people will have the same answer. Yeah, I think that is it. K is 1. Yeah, if k is 1, that means even the others, we really did it. So this is how questions come. Now, this should be your expectant. Yeah, it is something that they can really turn into a scenario and you struggle with it seriously. So this is it. They are saying if alpha and beta, those who have been waiting for alpha and beta, doctor, where do we really apply those things you have been teaching? This is the time. What do they say? They say that if alpha and beta, so the lesson has just officially started, whatever I've been teaching, those are basics, bogus. This is the math. If alpha and beta are the roots of this equation, do You see how they really fool you. This is the equation you can solve, not so? You can solve this equation and get the roots. But they are pretending as if they don't know the roots. And they are telling you those roots are alpha and what and beta. Find the values of this, value of this, value of this. Every time they give you such questions and they are saying roots, the knowledge should go to sum and what? Sum and product. Never take that for granted. That is very serious. Sum and product. Very important. Are we together? Now, never sort of for it, you get the value of alpha and beta, and for you come and substitute, you fail completely. When they talk of roots, sum and product should come in your mind. So let's first handle it. We get the values of, we get the sum, we get the product. Are we together? It is 3, -5, and 1. When I leave you, you raise up your hand. Okay? So it is 3 x squared minus, let me hope that's the question and I've not changed it. Yeah, it's the one. So you all know that before you deal with things of roots, because of the derivation I gave you, please and please, there is nothing easy at A level. So you need to be getting these principles. First, divide throughout. And make sure you don't forget dividing even this side of 0, because if you don't, the question will have changed. So you need to be careful with that. So even here over 3, even here over 3, just do everything the way I'm doing them. That's why I don't use already texted work in math, because I really want you to get something. Are we together? What do we get after? This one will become x squared, not so, minus 5 over 3. This is x plus a third. This one will always remain as 0. Okay. Now, the question has not asked for sum and product. It is giving you things to handle, and things are in terms of alpha and beta. So I don't want you to really struggle. You write the word sum, you write the word product. No. You be that one student who knows what they are doing. You just come and say alpha plus beta. But deep down, you know that alpha plus beta, you mean the sum. So all of you write the sum in the chat and then the product. Then also the product, you just put a comma, then you be like alpha, beta. For at the back of your mind, you know alpha, beta, it's product. Alpha plus beta, you know it is sum. Isn't it? So you quote them in the chat, we proceed. When you do that, now you begin on the question. Yeah? Very cheap. And this is harder than the next concept. So when you get this, you have really understood the topic. Yeah? Very cheap. Sum is 5 over 3, product 1 over 3. That is it. So you're seeing -5 over 3, but what is there? Whatever you see there, you're supposed to make it a negative. Yeah? So it becomes a positive 5 over 3. Then this one, you just carry it the way it is. This. My dear, when examiners see you trying to create the coefficient of x squared as a 1, they give you a score. When you get the sum and product correctly, you get another score. So how can you really fail to get a 2% in a paper where your roots have been set? At least you pass those. Okay? Now let's begin struggling. Let's see what these people want. I don't even now need the equation. I don't even need it. I don't need to see how it really looks like. I don't need. Now I go to the question. What do they want? They want you to get the value of this. Okay? Very technical things, but nice. Are you seeing? They want you to get the value of 1 over alpha plus 1 over beta. You may even wonder why they want such. But for you, just do what examiners want. You see? That's what they want. They want you to find the value of that. So here you just need to have good knowledge of LCM. So you should be this student who knows that the LCM of unknowns is their product. So the LCM of alpha and beta is alpha beta. Isn't it? It's not your first time to hear that. Then you start fractions, primary work. This divided by this, you get beta. Beta times 1, you get beta. Plus. This one divided by beta alpha. Alpha times 1, you get alpha. Do you see that these things are really cheap? So after there, they want you now to substitute. If you have a very keen eyesight, on top we are having the sum of the roots, which is 5 over 3. You see that? Then down we are having the product, which is 1 over 3. So according to me, the 3 is cancelling. And I'm getting my first answer as a 5. You thought the thing was hard. You see? T, T, T. Very cheap. 3 is cancelling, 5 over 1 is 5. If you're not sure of your math, use a calculator. Should we go to part B? Those who are supporting, should we go to part B? Those who are on? We go to part B. You're supposed to represent your people who will see this in the future. You're supposed to represent them very well. Okay? Twende sasa. Aya. You see, they want the value of alpha squared plus beta squared. Do you recall now what I said? That these people will give you things that don't look like the sum and product. So you're supposed to find a way. So I want you to be these kinds of students who understood the other derivations we did, so that when the question asks for this value, you don't really struggle. You know it already. You know it already in your head. Now for me, I know it. For me, I know it. But remember, we derived it together. I don't know how best I can really tell you so that you can memorize. Because I know by the time you read the topic of biology, you will have forgotten how it is memorized. So I always want you to be that student who can derive the other things slowly. But you can recall this. You just understand that when it's like that, just at least appreciate that this is there. The minus 2 alpha beta. Then you understand that here you have this. And then here you know the square is outside. At least you should be recalling that. But if that is hard for you and you're like, for me I cannot recall. But at least you should be in position to recall this a squared plus 2ab. Let me show you very fast. 2ab plus b squared. Are we together? Now, when the question asks for this, do you see it is asking for this and this? Isn't it what the question is asking? Look at it again. It is saying alpha. It is saying alpha squared plus beta squared. Isn't it the same as that thing I'm trying to edit out, the a squared plus b squared? So that means for you just get this and subtract this because you're supposed to take it the other side. It's what I'm doing here. Do you see that? Very cheap things. So that means you should have mastered all those techniques. So after that step, now you just come and substitute. Is substituting really hard? Because that's why I told you the other time that fight hard to express everything in terms of sum and product, because those are the only things that will be available to be substituted for. Anything outside that you can't substitute. So if you don't have anything being expressed as sum or product, you're really doing yourself a disservice and you be completely disorganized. So I'll come and be like, okay, yeah, the sum has been squared. So you'll be like 5 over 3. This is what? This is squared minus 2 alpha beta. So 2 alpha beta is the product and the product is 1 over 3. This is something you can put in the calculator at once and get the answer. So do it. And I remember teaching you in indices that to do that, you open brackets, you be like 5 divided by 3, you close brackets, you put squared. If the power is more than 2, you use this symbol and then put maybe power 5. You press the answer. When you get the answer, you'll be like minus 2 over 3. The word answer will bring itself automatically. So you get me that answer and tell it to me in the chat. So do you see how cheap they are? But the technique is always this link reaction. I'll teach you the link reaction in respiration. That link expression that really connects you to direct substitution into the what? The sum and product stuff. So what do people have? Do people have 2 over 3? What do people have? You people are using your calculators very well. Should I trust your calculators? 25 over 9 minus 2 over 3. What do you get? I want fractions, 19 over 9. Okay, thank you so much. So that is the answer. So just come and say. So the book was kind of misleading me maybe. 19 over 9. That is very good. Then we go. Part C. What else? Let's see this. Now are you seeing this? I told you that here you just need to be someone good at some little algebra. Then the substitution comes in later. Do you see that? It is 1 out of 1 out of 1 is alpha squared, another one is beta squared. So you first also handle it. I think alpha squared was the first one. So I'll come and say 1 over alpha squared, and this is beta, plus this is 1 out of, this is alpha, and then this is beta squared, something like that. Okay, someone tell me what is the LCM of these ones? Yeah, someone was like, doctor, you told us the LCM of unknowns is their product. Okay, that's what I said. So someone tell me what is the LCM of these ones? Yeah, I said it. So someone tell me what is the LCM of those? I will not deny myself. I said it, that it is the product. But you tell me, what is the LCM of those? Because it is something that usually disturbs people in the country. And I don't know why. What is the LCM of those? Or someone can really unmute and speak. What is the LCM of those? Because without something clear, you use A and B. Someone may be looking for alpha and beta in the chart. Just use A and B. And I told you when you're writing the power, you just write a theory. For me, I will understand that you mean a power theory. Don't really stress yourself with all this. But I always want to see your trials first at least, so that I'm not just a dictator. In the new curriculum, lessons are even supposed to be student-centered. But I try to really balance the scale. So what is the LCM? Just use A and B. Just don't stress yourself with powers. You see people are using 3 and 3 because I said that LCM, you really multiply these things, and that is wrong. And all people who have tried have failed it. So please stay on. Whoever has failed it, and all of you have failed, you don't have any reason to leave this class until it ends. Do you people recall these things of getting LCM in primary, where I used to say, get the LCM of 24 and 36? Do you recall these things? We used to say, 2, then you say 12, then 18. Then you say 2, then you say 6, then 9. If at all you people recall, tell me what should I put there? Which number should I put there? If you people really recall these things, which number am I supposed to put there? Some of you are giving me right answers after I've said the other one is wrong. Someone is saying 3. You people, you have forgotten primary work. We put there 2. We used to put a 3 where we are looking for the greatest common factor. Don't, you people, you have forgotten those things. GCF and LCM. We are supposed to put here a 2. Because even if you avoid these 2 and put a 3, you will put here a 2 and the 2 will still come. Hey, you people, we used to do that for greatest common factor. Okay. You've forgotten LCM and GCF. You want me to put primary classes on our YouTube channel? Hey, you people, not easy. So you put here 2, put here 3. Then here remains a 9. Then you come for a 3. Then this is 1. This is a 3. That means you people didn't pass P7, but you're doing BCM. Hey. Okay. 3. This is 1. Hey, you people, does this really remain a 1? Someone recall. What did we used to put here? Because this one was a 1. What do we put here? Isn't it a 0? Do we put 0? Do we put a dash? Do we leave space? Do we put 3? Do we put 1? What do we put there? These people went to good primary schools. I can now tell who started from home. Someone is saying 3. It was a 1, because it wasn't causing any change. So it was a 1 because the goal was always to end. So we used to get the... So you tell me, how did we used to get the LCM? This last number here, this one here, we multiply 2 and 3, we multiply all of them. What did we used to do to get the LCM? You tell me. What do we used to do? Multiply all. Thank you so much. Multiply all. We'll be like 2 times 2 times 2, that is 8 times 3, 24 times 6, 72. Then we get 72. So we are going to still use that knowledge here. Hey, don't think that knowledge really ended. So in most of the cases, when you're confused, really pull that move. Yeah? Pull that primary move in case the unknowns are becoming stubborn. Are we together? So we are going to come here and say, okay, let's say the first one is alpha squared beta. Okay, then the other side we have alpha, then the other one is the one that is beta squared. So we start LCM. What is common? Alpha. Here we shall remain with alpha and beta. Not so. Here we remain with beta squared only. Are we together? We go alpha still. Alpha here it will remain beta squared because there is nothing to be lost. Okay, like the primary stuff. Then you people, sorry, here we are remaining with beta. So alpha is gone. So you now bring beta. This is 1. Here remain with what? Beta alone. I don't know whether I'm confusing anyone. So this is beta, this remains 1, this remains 1. So do you see that the LCM is alpha squared and beta squared, not cubed? So if you want to learn the reason as to why, you pull that move of primary. But if they are just alone, maybe the LCM of alpha and beta, that one is clear. If maybe you're looking for the LCM of alpha squared and that one is just multiply them. Maybe you're looking that of this is squared and maybe this cubed. You're supposed to just think twice and just multiply them. But when they are mixed, my dear, maybe this one is alpha and this one is b power 4. Hey, you're supposed to pull that primary move and really get the right LCM. So let me hope people have gotten that. Okay? So the LCM is alpha squared, beta squared. Okay? But we need to start revision very soon. Revision is really nice and it's the one that makes the greatest sense. Alpha squared, this is beta squared. I've taken some good time without revising. I'm really just struggling with students. So when you get this divided by this, you can see the alpha squared cancelling. This beta squared divided by this beta, you remain with only beta. Okay? Plus. When you divide this by this, beta squared cancels. Then this alpha squared divides that alpha, you remain with only alpha. Do you see that? Do you see that now things become very easy? So you need to be knowing the other things we handled, and you should be a good student of LCM. Yeah. Then after here, you can first even decide to be like, let me write this as alpha plus beta. So this one, you're supposed to write it in product form. Yeah? So product form, it is as I told you, indices. Write the product alpha beta, put the power outside because it is common. And I'm not wasting time on that because I myself, I taught you indices. Okay, now this one, it's just like even the reverse, the reciprocal of the previous one. On top, we are having the sum, and I think the sum, isn't it 5 over 3? Yeah, and the product is a third. So I'll come and say on top, we are having 5 over 3. Then down, we are having the product squared, like that. Then you get the answer. So you people tell me, what is the answer to that? So do you see that these things are cheap, yeah? Yeah, but we are having the next step. That step where you're really supposed to formulate equations. Yeah, and I think it's going to be the next number. Yeah, there you're supposed to be extra careful. Yeah, and when we handle that, shall really be done. Yeah, this topic, equations and inequalities, it has a lot of miscellaneous, but we shall handle that miscellaneous as time goes by. So do we have the answer to that yet? Yeah, and thank you for maintaining some good number. That is very good. I'm seeing 515, 2.5. What should I really take? Please, I need people who are serious. You cannot be giving me different answers, yet you're so many people here. Someone is even having 155. That one is, I think, tired. But 15, I think we have it there. Okay? Then, I can also shock you. Yes, I can shock you. What if, let me add on my own other parts. Okay? Yes, let me add on my own other parts. People tell me whether they can really do that. So assuming I come and add on my part and I say having this one, okay, and then I'm having 1 over, this is beta power 4, and they want the value of that. I don't know whether people can, let me even not use that. Let me use this is squared, let me use minus, even here I use squared. I just want to show you that they are cheap, especially if you can handle them well. We are going to handle that together. Okay. Then this. Beta squared, alpha squared. Then there is also this. Yes, they can come out and tell you, please, we need the value of this. They put here alpha. Are we together? Then they put here power 4. Then they put here plus. They put here another 3. They put here alpha power 4. Then they put here 3. Yes, they can do that. So I'm not going to do the substitutions because you've realized the moment you express it in terms of sum and product, you just substitute and then things become very cheap. I think people have noticed that. I'm right? So let's first do some primary math. So when I come here and be like, okay, equal sign, what do I have down? So here you just multiply them. This LCM for it is cheap. So you'll have alpha squared, beta squared. Are we together? Then you will have, here you'll have alpha squared minus beta squared, not so? Are we together? That's what you will have. Then let me come here. You'll be like 3 is common. You'll be like alpha is common. You'll be like beta is common. You'll be like here I'm remaining with beta like this. Then you'll be like here I'm remaining with this. I think people can see all that. So you can first be like, this one, okay, it's difference of 2 squares, which is this. Okay, then you be like, okay, here down, this is product. I can put this all together like that. You understand? Then you also be like, maybe I should rearrange this, but I told you rearranging doesn't matter. Now I want to pose a question. You people know what we should put here. And so because this is sum, this is product. You understand? Even people know what to put here because this is just product. Now the concern is on what to put here and the concern is on what to put here. I'm just assuming if those questions were added. Can people really proceed from there? Like what are you going to put where you have alpha minus beta? What are you really going to put there? That's my concern. This is what I told you, that you're supposed to be the student. It is very hard, but you can cram them. You can cram them because they are not there in the logbook. But if at all you can't cram, then you must be in position to derive. So for you, you're supposed to derive as of now. But me who has taught this for years, I know that that one is the square root, if people recall. And here what we have, it is alpha plus beta. Okay, this is squared. Who can tell me what we have here? Those people who can really cram with me. What do we have there? Minus what? Minus what? Those who recall. What do we have there? Minus what? Write it in the chat. I said alpha and beta, you can use A and B. What do we have there? What do we have there? Because now the rest are easy, but now we are looking for what to put for the alpha minus beta. Someone is saying 1, that is 2, but someone is saying 2AB. That is wrong. It was 4AB. Thank you so much. So it is supposed to be 4 alpha beta. That is nice. So do you see that? Yes, these ones are very cheap to replace because it's just sum and product. But again, this can help. Yeah, the one alpha minus beta, it is hard because we don't have difference of the roots. But you look at what it is equal to. It is having sum which we can substitute for and product. You people, do I need to do for you that number? Do you see that it is just upon you to do the right algebra? Do I really need to go beyond that point? You promise me in the chat that you can go beyond that point. Then we go to part E. When you understand part E, then we handle the other real question that deals with forming the quadratic equation. And that one we are just going to do 1, 2 numbers, and then that is it. Completing squares is very cheap. Completing squares is very cheap. That one, don't worry, because we are not supposed to sketch. So we are going to just be doing things of minimum, maximum. Then the revision class I've told you shall just be like, now we are going to do scenarios of indices, surds, logarithms. Equations, we are also going to just handle them at once. Then we revise. That's why I advise you all to be part of Premium so that you don't miss those serious classes where scenarios are revised, because it is the goal after understanding the content. Are we together? So do I have some who have promised me that they can proceed? Okay, you can go beyond that. Now, when you look at part E, you could literally handle this part for the for the alpha B, but then this beta cubed plus, I don't know whether people recall what we said for that. I've said you can use A and B for alpha beta. Now I'm going to ask you again. One thing you're supposed to always appreciate is that this one will always be this first in most of the cases. Then it will be minus something. So you people tell me in the chat, it is minus what? That's what I want to hear. It is minus what? Minus what? Those were with me, because all those things were derived. Do you see where the topic becomes hard? It becomes hard in the future, where you get stuck and you don't know what to replace for the beta cubed plus alpha cubed. And that's where you start lamenting. So I want to see in the chat. I say minus what? Those who are writing, try to check up and copy and respond in the chat. Just use A and B for alpha beta. You see, all of you have failed. It's only one person who has tried. Most of you have been just saying 3AB, 3AB, and that is a common mistake. Even me as a student, I did that mistake one time. Most of you have just stopping on 3AB, 3AB, 3AB. But you will check, it is 3AB or 3 alpha beta. Then inside, we also have something like that. But don't worry, when we revisit it, you'll get it. Because if I'm to scroll back a bit, for you to confirm that later on it will make sense, do you see it there? And remember, at this point, you were claiming that you understood, but you couldn't say it in the chat. That's what I always tell you, that when I'm introducing a topic, you're simply appreciating, not understanding. Yes, you're understanding and appreciating, but for you to master these things, you're supposed to revisit them. Now, most of you have been stopping here, and you're forgetting this. And that's where you say, maybe I didn't understand the topic. But you know the basics. You just don't believe that things are really forgettable, and you're supposed to always revisit once in a while. So do you see that? So now what you have finally, it is having a sum which you can just substitute, a product you can just substitute for, a sum you can just substitute for. So people promise me that you can really move from this step to this step, and then you get the final answer after substituting. Because the sum is 5/3, the product is a third. Can you also proceed from there? Should we now go to the last case of the questions that have the highest probability to be set by UNEB? Should we go? Okay, Kate has said we can. Yeah. So I think now we can go to, this was, I think, example 3. So this one is going to be example 4. Very serious question. Yeah. For it, you're going to see, I think it's supposed to be having 2 roots. So when the roots are 2, you realize that, things are now becoming serious. Okay, so I added on our parts, other parts. Look at this example. It is 54, but I'm calling it example 4. What are they saying? They're saying that if alpha and beta are roots of this equation, see, they're saying find the equation. So this time around, we are finding the equation. Find the equation whose roots are these. Are you listening? They want the equation whose roots are these. So these are the questions that really give people a time. These are the kinds of questions that really make people say the topic is hard, we really need help. So you just get the hope in advance so that you solve the future problem in the past. Okay, now do you realize that we are having two kinds of roots? We are having these roots and also these roots. Do you get it? Because they are saying these ones are what? Are roots. They're also telling us that these ones are what? Are roots. So these ones are going to be our old roots because they are coming faster and they are belonging to the old equation. So even this one is the old equation. Then they want us to form an equation, but we already have one. So what we are forming is the new equation. That's why I'm telling you that let these roots of ours be the new ones. Do people get that? That is the first thing to understand. That is the first thing to understand. Yeah. But I told you, since the things you're going to be dealing with are alpha and beta, you don't need to have those things of sum, product. But remember, this time round, you're supposed to form an equation. But remember, for you to come up with an equation, you need two things. I want you people to listen. I want you people to listen. Let me give you the behind the scenes. Remember, for you to get the equation, do people recall this formula where we said xc minus, then we said this one is supposed to be sum of roots? Are we together? Then this is x, then plus, then the product of roots. Are we together? Then we say this one is equal to what? A 0. Do people recall that formula? It's the formula we are supposed to use. You know that. But let's first look at the roots we have been given. Let's be like you, that student. You don't know the approach, but you're like, I understood that topic because it was taught. So you be like, that is the formula. I know it, thank God. Maybe you even wrote it in your logbook somewhere. You're copying, not knowing that UNEB will give you new logbooks. So as you have it in your own logbook, make sure by UNEB time you've mastered it. Okay? Now, it'd be like sum of roots. But remember the equation they want you to form, its roots are these ones. So it'd be like, when I reach that part of sum of roots, I will just come and add them. Alpha plus beta, alpha plus 1 plus beta plus 1, isn't it? This one will give you alpha plus beta plus 2. But let me tell you, you cannot just come and substitute this here. Because the equation is going to have alpha and beta. Yes, they are not supposed to be part of the final answer. Do you understand? That means before you work on the new roots, the new roots are going to have unknowns, which is very bad. So make use of the old roots, get the values of such things. You understand? Make sure that you know the value of alpha plus beta, of which everyone knows it. Alpha plus beta means the sum. So if this equation is having roots as alpha and beta, the sum is clear, it is negative 7 because it is positive 7. You understand? The roots of that equation are alpha and beta. The sum of those roots, alpha plus beta, is negative 7 because of this. Not so? That means negative 7 is supposed to be here. Do you understand? I'm trying to show you the importance of the old roots by using the new roots straight away. That you using the new roots straight away because you know the equation in which you're supposed to substitute. It is a total mess. Because you will end up having the final answer with alpha and beta. So make good use of the old roots. Get something at least. Have the value of alpha and beta. Have the value of alpha beta. Start the struggle from there. Because guess what? Even if you're like, okay, this is what I'm supposed to substitute the product of roots here. But in the new equation I'm forming, so I'm supposed to use new roots. So it'd be like the product of the new roots. So let's be getting the product as if it'd be like alpha plus 1, you're multiplying it with beta plus 1. You guys know how to multiply. Alpha will multiply beta. I'm even stopping here. Because when you multiply alpha and beta, you don't even know its value. And it cannot be part of the answer. That means the old roots alpha and beta, their product, it is even here 5, is the one that is supposed to hit a pass. So that you remove this sheet and put 5. Excuse me. I didn't want to say that. But remove the alpha, beta, and then put the 5. That's what we expect. That's what we are supposed to sit there. So what is the criteria? First, use the old roots. Let them get you the value of alpha, beta, the sum and the product. Because you will need them as you manipulate the new roots. And before you even write this funny equation, first get the sum of the new roots, product of new roots, so that you just substitute without even writing the formula, because no one needs it in mathematics. Are we together? So let me just hope you people now have the criteria. You now know the order of the solution. So as I'm writing it, I don't expect any questions. I don't. And you're supposed to just understand only that. The rest of the things, it is your own algebra. The things I gave you. Let me see if these people have a second example. Otherwise, if they do, they will be very mad. Yeah, they gave method 2. Of course, we are not. You see? After method 2, they gave exercise. Because now, what do you really want the examiner, the teacher, to do next about this simple work? Very cheap. You understand? Hey, but for me, I'm going to sample so many numbers. You know the technique we use. You confirm they are doable, we tag them as assignment. You be like you need a hint, we give you the hint, okay? So the equation is 7, 5, and the roots are alpha and beta. So I'm going to come and be like, the equation in question, they are saying it is 7 and 5 equal to 0. And guess what? We have nothing here. So that when we just use it the way it is, without struggling, okay? And they are saying the roots are alpha and beta. So we are like, first make good use of that. Be like, okay, the sum shall be -7. Yeah, because I'm supposed to negatify whatever I see there. Then the product alpha beta, I just write it the way it is. Okay? Like that. Then after that, what next? That should be the question. What next? Now, they are telling you, they are giving, now these are the old roots, but you don't need to tell us sum of old, sum of new. For us, we just want the alpha and beta. It's the one to play the real game. Now you come and handle the new roots. But remember, the new roots are supposed to be substituted in a certain equation which has the words sum and product. So you're supposed to set them. You realize most of the math classes, steps are just written. But I want you to be good students so that you know why steps are written like that. So you're not supposed to also really, what's that English word? I've forgotten. But let me use a simpler one. You don't really need, and you're not supposed to shame me. Okay? Sum of new roots. So you come and be like sum of new roots. Please, this word new is very important. Even first put brackets to show that you know they are different. Even when the brackets, or the opening of the brackets will not cause any effect. If we just pretend and be like you're putting brackets so that you show the person that your aura of mathematics is very high. This is the root, this is another root, they are different. And you very well know that when you open brackets, there will be no change. Show the examiner that you're even going to skip that step of opening brackets because you know there are positives throughout, so no change. Put the alpha plus beta here in brackets, then the other one plus 1, make it a 2. You understand? Don't be the local kid who is going to do this. Because even after you're supposed now to bring this together and also add this, so you skip that. Bogus. You're not substituting, so why stretch yourself? Are we together? Then do you see that now it's going to be very easy? Alpha plus beta, you have the -7 to substitute. So you come and be like, don't overdo it and then you just come here and put -5. Now substitute, because now that's like the expression. That is -7, then plus what? Plus 2. Then you also remember what doctor said. Doctor said that every time you reach the final answer, for example, it is -5, it is advisable that you bring back this, the owner of the word, then you rewrite it and be like, we have not forgotten that this was the sum of the new what? Of the new roots. We are still with them. Tick. Very nice work. Why are you doing all this? In the equation into which you're supposed to substitute to get the equation the question wants, has the sum, has the product, and you're supposed to substitute. After that, I told you that this arrow is not really necessary. So you're supposed to do what? To come and say, let me now come and handle the product. So come and say product of new what? New roots. New is very key. Hope you know the old ones. So new roots, it is still alpha plus 1, then beta plus 1. And you people know how to multiply. Now let me teach you something else. You see the other step that we do here, where we say alpha is supposed to multiply this bracket. Even 1 is supposed to multiply that bracket. You can skip it. If you know that, you start, let alpha multiply that bracket. When alpha multiplies that bracket, you get alpha beta, not so? When alpha multiplies 1, you get alpha, sorry, not 1. I think I'm starting to get tired, which I doubt. Then if you know that 1 is supposed to multiply that bracket, also multiply it. 1 times beta, what do you get? Beta. 1 times 1, you get 1. I know someone who is dozing, who is halfway sober, wanted to put a 2, but it is 1. Hope we are together there. Now, as a student who knows that I'm supposed now to substitute things of sum and product, you now put just put this in bracket. Put it in bracket. Squeeze the brackets there. Then you come and be like, the product. Let me check it from I've forgotten. It's there. It's a 5. So you come and put your 5. Okay. Then you be like, what is the sum? It is -7. Okay. Then what is this one? It is 1. Then the product, finally, you're getting it as -1. Hope I'm right. Then you're supposed to bring this back and show that this is the product of what? Product of new roots. Do you people get it? I told you that I'm supposed to write these things step by step so that you also get that vitamin of writing the mathematics on your own. So that is very good. You see? Now you have the sum of the new roots and product of new roots, but they want the equation. So you recall that the equation has a formula. You understand? This one, I told you it is very important and we have been needing it so many times. So you'll be like x squared minus, put the sum of roots, put x plus, put the product equal to 0. As simple as that. Is that really hard? And then after you say mathematics is hard. But we are not really doing anything. People have really over-requested for this class. And I'm really happy that we have really moved. Because now we have a more interesting concept that is completing squares. You ask your friends. These are things that really took a lot of time. But if at all we can organize them and have them as one class, check the syllabus book, check different questions, and we are there, we are like, yeah, it's really a success. So if you write the equation, you just come and be like, therefore. Okay, so you just note the sum is 5. I don't know. I beg your pardon. I don't know where we had stopped really saving. Oh my God. Oh my God. You see, you people, you had not really reminded me to save the document, but at least you people had appreciated how the steps were being done. You tell me, what was the sum? Those who have been writing something. You see why we record classes? Now someone can just go back and check. What was the sum? I only remember the product. Which sum did we get? Sorry for the inconvenience, people. -7, really? You see, when people are confused, who was writing? For me, I remember something like -5. Yeah, I think it was -5. Because product, that one I know it has been -1, yeah? Yeah, so these ones, So when you're writing the equation, you just be like, therefore, when you see me delaying to save the document, you really notify me, yeah? So x squared, you'll be like minus, then you put the sum, put together, then you put the x, then you put the product as it is, then you equate to 1. Then after you write the equation, be like, this will be x squared, this will be plus, this will be 5x, this will be a -1, and this will be a 0. Like that, and that's the equation they want. So you people, are those things hard? These are, they are not hard. So the criteria is very cheap and simple. Handle the old roots, the old ones. Let them get you the value of alpha plus beta. Let them get you the value of alpha beta. Are we together? Then after, start on the new ones. Get their sum, get their product. The other ones will help you with those substitutions to really make things chap chap. Are we together? It's even kind of relating to what we have been doing before. Though here we are forming the equation. So we need to write those words, sum product. Then after we substitute very well. So let me hope I've not left anyone behind. Okay? Yeah. That's why I advise you. And for math, no excuse. You're supposed to write the notes on your own. That's why these workbooks are very rare. Even when I have them, I keep them to myself because when I give you, you not copy notes. And if you don't copy notes, my dear, you not pass mathematics. You not pass mathematics. Yeah, the equation is there, 5x minus 1. I think that's what we have. Okay. These are other methods. But these ones, we shall be, okay, if you know polynomials, they are also very cheap, and I also talked about them there. So before we go to even completing squares, you take some of the assignment. You take these numbers up to 5. I'm going to pick one of the numbers. You take those numbers, very cheap. I'm going to do for you a certain number because people usually see them and be scared. Yeah, because people may see these things and be like, Doctor, I'm seeing certain proofs, but you had not told us about proofs. What do you really mean? Because they are telling you to prove these things, such things. Yeah, and proofs are one of the things that really give people a time. And I'm seeing some answers here. Maybe you never know, they may help you. I'm seeing these answers part A, part B. These are answers, so you take them serious. I'm seeing here answer 9, 4, 6. They are really nice, so you really try them out. But I'm going to do for you a certain number that is to do with proofs, and you're going to see that things are not really hard. You also need this assignment. Yeah, you take the whole of it from number 6. Yeah. Yeah, there are those numbers, but they are really special cases. And those proofs, there is a way they want to phase them out of the new curriculum setting because they used to teach people a lot of cramming, but they are good if at all you can really come up with those things. Hope people are also resting a bit. Now, I want to pick a certain equation. Maybe we do the last one. And now let me ask people, according to the way you have looked at this, do I really need to do for you a question? Hope you've taken the screenshot. Just because this question is bad, you look at it, it's having this. Like we don't have a coefficient, even this one has no coefficient. I don't know why, but they are nice, you try them out. Yeah, you take these last ones. So what I called miscellaneous, we shall have that special session of miscellaneous, where we shall look at other questions, where those things of show, where you show weird things. But I want to first confirm with a lot of things concerning assessment so that we don't waste our precious time. You really need to concentrate on understanding the content so that the application it's really nice. Okay. Now, according to the way you people have looked at that, okay, you look at number 6 and number 9. That's how the questions come. They give you a certain equation like this one, then they tell you the roots are alpha and beta. They give you a certain equation and tell you the roots are alpha and beta. Then they tell you to find new equations. That's why those roots they provide, just because, yeah, sorry, they are saying values. That one I told you. But they tell you to find the equations. Those roots are these ones, so they provide you with roots. And they are the new ones, and I've told you need their sum and product. However, to handle their sum and product, you may need, I want you to listen to me well. You may need some knowledge about the old ones, where the old ones are supposed to provide you with alpha and beta. Now, I just wanted you to look at the format. Now, I'm going to set my own question. Then we say something about it, And then people let me know if it's really doable. And if really I need to do it for you. Okay? So I'm going to put it here, maybe as the next example. So I'm going to be like, they will tell you that if alpha and beta, I want you to listen, are roots of this equation. So they can put for here 5x squared. Are we together? Then they can put for here something like maybe 15x plus 4 equal to 0. Are we together? And they tell you that is the equation. Then they tell you the roots for those for the equation, it is alpha and beta. They are the roots. Are we together? Then they tell you find other equations. Find other equations. Are we together? With roots, they give you those roots in pairs. They normally separate them with commas. I want you to listen carefully. Then they be like 1 minus beta squared, then they put alpha like that. They don't even you just can't see it coming, but that's what they have put, and they want it like that. Anyway, let me put for you like that. Okay. Then they also tell you okay, let me just put for you only 2 things. Then they can tell you, please and please help us. Whose roots are those ones? Like that. There is a way they want to resemble the other ones of values, but not. They don't. They just overdo it. Now, if they give you something like that, what are you really going to do? I've told you that these new roots they really provide. I want you to be very sober. You're supposed to form equations, so you need sum and product. So when you look at this one, now you look at their sum. If I told you to add them, do you see that if you're to add them, I want us to just be very fast. I'm just teaching you the technique. If you're to add them, the 1 will cancel. Are you seeing this 1? It will cancel with this negative 1. So if you're to add, you remain with alpha squared minus beta squared. Do you see that? Then you'll be like, this one, I know it is alpha plus this. Then you know that this one is this. Are you together? But then this one, you know it doesn't stop there. It is the square root, you know? And you know it is alpha plus, this is beta squared minus 4 alpha beta. Hope people are connecting dots. Do you see that? But now the problem is 1. Where are you going to get the things you're going to substitute here? That means you like it or not. You need the value of what? Alpha plus beta. You need the value of what? Alpha beta. So that's where the knowledge comes and be like, oh, I had to make use of this equation and get the values of those two. After all, even this one had the roots as alpha and beta. Be like, okay, now you people, I want you to tell me, look at this equation critically. You tell me, what is the value of alpha plus beta? That is the sum. You just tell me and you separate them with commas. And what is the value of the product? That is alpha beta. Be fast. Look at that equation. Tell me the value of the sum. Tell me the value of the product. Hurry, people. Hurry, people. Hurry, 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 hurry. 15 and 4, that is wrong. 3 and 4 over 5. Thank you so much. You people, some of you are not yet serious about these things of sum and product. I told you you're not supposed to apply those things unless there is nothing here. That's why I've told you that those questions in the assignment are very bad because they don't have that value before. So the 5 is supposed to first go through all of them. Are we together? The coefficient of x squared should be a 1 before you apply anything. I want you to get that from me. So you first get negative 15 over 5, which is negative 3. But you're supposed to make it a positive so that it is a 3. Remember, when you get that one as wrong, even these ones you're going to substitute poorly, and the examiner will get biased. They will not even look at your work below. They will just cross everything. So you need to be very serious. Then the 4 over 5 will be taken as it is. 4 over what? 4 over 5. So do you see that if you have the 3 and you can really put it here, You have a 4 over 5 that you can put here. You can really get the value for the sum of the new roots. Do you see that things will be kind of cheap? Not even kind of cheap, very cheap. Then if I told you to get maybe the product, I told you that if I told you you're looking at the other method as very hard, where we say one number is going to multiply the rest, just do it at heart. Just do it at heart. What do I mean? That when you have something like 1 minus beta squared, then you're having alpha squared minus 1. Guess what? It'd be like 1 times alpha squared. It is alpha squared. 1 times negative 1, negative 1. Okay? Negative beta squared times alpha squared. You'd be like it is negative alpha squared. Are we together? Then also beta squared, like that. Negative beta squared times negative 1, you get positive beta squared. Now, for you at the back of your mind, you should be that student who is very much aware that when alpha squared is added to beta squared, there is that expression that really tries to connect it to the thing that we want. This one squared, then minus to alpha beta. You know that, isn't it? You know that thing. This one and this, it is the same as that. Then you come and bring this. Are you seeing this? Okay. Then you know indices. I can put product inside in one bracket like that. Then I end with a minus 1. I shouldn't forget it. But remember, you're very happy now. You're like, I have the value of the sum. I can put it here. I have the value of the product. I can put it here. I can put it here. Do you see? And here, what are you obtaining? You're obtaining the product. So you're having the sum and product. So I want people to tell me that they can proceed with this, get the sum, then they can proceed with this, get the product. Because when you get the product and sum, guess what? This is what you do. You be like x squared minus, you put the value of sum you got, you put x, then you bring your product, you equate to 0. Isn't it what we said? So do you see that I don't really need to do a lot of numbers to show you a lot of steps? No. I'm supposed to teach you the techniques in line with alpha beta so that you have a task of what? Substituting and doing the algebra. Is that okay? You will first assure me that you can do that number the way it is there and you complete after those techniques I've given you. Can you do that part? Can you really complete it? Only one person is telling me. Okay. Now, I don't know why people are really confused. Because, I don't know. The one of difference of two squares one we have been doing. Many people have not been following. Now, you look at part B. Now, those who have questions, you're supposed to raise up your hand and ask. Those who will be listening to the recorded class, you replay. Because you may be seeing stars after you've dozed off. You're supposed to now go back and get to listen. What was I saying step by step? Because there is nothing I've just put. I endeavor to explain. Now, this one, when you're to add, at least, okay, the product, let's begin with the product. When you multiply those two things, 1 times 1 is 1. Alpha cubed times beta cubed, you get alpha beta all over what? Cubed. You see that the product is easy for the new roots. Because guess what? You already have the value of alpha beta as 4 over 5. So you just put it there, cube it, then say 1 over the answer, get the product. That is easy. Then concerning the sum, this one we have been doing it. You people at this rate, you should be aware that when those two things are added down, you're going to have alpha cubed, beta cubed, which is the same as this after applying some indices. Then here you will have this plus this. Are we together? Sorry, this is a 3, not a 2. And you people should be aware about how this one really expands. And I told you that this one really should come first. Never forget the cube. Then minus, this will be 3. This will be alpha beta. And this will be alpha plus what? Alpha plus beta, like that. Do you see? Things are not hard. It's just because you're seeing a lot of alphas and betas on the screen, so your mind just blows up. But you've been following, you can really settle down and do this thing from scratch and really do it perfectly. So you can see, product, it was very cheap. The sum, the denominator is just very cheap. You can put it and cube it. Then the numerator, you have the sum somewhere, you have the product somewhere, you also have the sum somewhere. So the rest is just substitution and your algebra. I don't need to do it. Because when you substitute, you can just use a calculator. And I believe I'm talking to mathematicians. So why would I really need to do that question for you? Yeah? And let me tag it as assignment. You're supposed to complete and really get those equations. So you take that screenshot. So do you people say that, yeah, you've at least gotten something? Can you do those numbers that give you the equation, the old one? They give you the old roots as alpha and beta. Then they give you new roots and they ask for the new equation. Can you handle that thing? I want to listen from you all. You people, you tell me, can you do that thing? Yes, you can. Now I want to give you the one of power 4. So that I want the class to be high yield. So that you leave the class with everything. Let's say one time, you never know, things happen. You may find these roots, especially those people who want to set hard things for candidates. Okay, you can see search. So when you see search, it is easy if at all you're getting the sum. Sorry, the product. If you're getting the product, 1 times 1 is 1. This one will be alpha, beta, then power 4. This one will be cheap, because you just get the product and put power 4. But now my worry is about the sum, that when you're getting the sum, okay, down we are aware, this will be the LCM, okay, which is very okay. But here we are going to have this plus this. So this is what I want us to handle. But I want us to handle it very well, okay? This. Yeah, I'm going to give you the simplest technique. So this one, it is better for you to have it like this so that it relates to others. Okay? So someone will be like, I know that. So what are we going to do? So we are going to, okay, it also has the expansion that goes up to power 4. It has it. Yes, it has it, and you're not supposed to take it for granted. It has it. But there is a better way we can really handle this. Look at this. You people, this, let me see if really people can connect. That alone is this. Isn't it? Now, what if I need this? 4 plus beta power 4. Remember, power 4, we agreed it is power 2 plus beta power 4, it is power 2, then also power 2. I told you that in indices. Now, I want you people to connect these two. Here we had alpha squared alone. Even here, beta squared alone. Are we together? Look at what we had here. Here we had alpha. Here we had beta. These ones that were squared, they're the ones we had here in brackets as a sum, then with the squared because of this. Then here we had alpha, beta. These ones that were squared with the K2 here. Do you people agree with me that if this one is this, we can copy that and come up with something? That here what they have squared is alpha squared and beta squared. They are the ones that are squared. So as I'm copying here, they are the ones supposed to be inside alpha squared, beta squared, then squared. Then the 2 will come. Then here why we had alpha, beta, because they are the ones that were squared this side. So this time round it is alpha squared and beta squared that have been squared. So here we'll have this squared, you understand? Beta squared. You can try to get this, but my concern is about this 4. Can people get this? Is this supposed to be a 2 or it's supposed to be a 4? If I may ask. Yes, we are copying everything. Are we really going to maintain a 2? Are we really supposed to maintain a 2, or it's supposed to be a 4? Let me see if people can say something about that. What do you think? Yes, we have been just copying, but should it really be a 2, or we are supposed to change that and it becomes a 4? Yes. That's what people are saying in the chat. A 2, I think a 4, maintain 2. Hey. Okay. But don't worry, with time you learn, yeah? But we are supposed to leave that 2 as it is 2. But as you progress, you learn why. So let's only concentrate, because the 2 has not been in these things. For us, we are only dealing with the alpha and beta. So we shall still respect the 2, provided the squareds have been left as squareds. Let me hope we are together there, people. Hey, so that's how. So do you realize that you people can really deal with this after? Yeah. Someone may be like, but is this thing really correct? Will it really work? Yes, it will work. Someone may be like, but doctor, this one, you're lying. Let's do this for you. Let me do this for you. You all know that to expand this one, you square it, it will become power 4. Then after, you square this one also. So it will also become power 4. Then after, you get this times this times this. So it will be 2 alpha squared beta squared. Then you subtract this, so this one cancels and you remain with this, which is here. And I know all of you are confused. But let me hope you've gotten the support or the evidence or the defense for that too. Yeah? Some of you have been saying that change it to, I cannot. Remember, you people, as I'm having the a plus b squared, this is how I do it. I be like, let me square this, then I say a squared. Then I be like, let me square this b, this one, yeah? Then I get b squared. Then the last thing what I do, I multiply this 2 by this a by this b. Then I get the 2 plus the plus 2ab. That's how it comes about. So I've been applying the same thing here. And I'm saying, let me first square this what? Alpha squared, so that I get alpha power 4. Then I say, let me also square this beta squared, so that I get the beta power what? Power 4. Then after that, I get this 2 times this times this. And I've said I'm coming up with this. Remember, there is this minus. So this one will cancel with this. So I remain with this, which is the same thing here. So do you get the support for that too? And I'm rubbing this off. So you're supposed to just have that math with you inside your blood. It should be part of either your blood or the blood plasma at least. Okay? At least if it can't be in that, let it be in the tissue fluid. If you don't want it to be part of the circulatory system, let it go into lymph and be part of your lymphatic system at least. Okay? So that is it. So do you realize that there you can really handle? Someone may be like, things are still hard. No, they are not hard. This one is very cheap because it's going to be alpha, beta, then squared. So you have the product, you just substitute. Then this one is squared, so the calculator will actually work on this. So for you just concentrate on this bracket. How? Who doesn't know that that one is alpha plus beta squared minus 2 alpha beta? The other squared is just coming on. And let me hope people know why I'm using square brackets, because I've already used the curved ones, and I told you the moment you use curved brackets, the next ones should be square brackets. Are we together? So do you see that really these things, there is a way they are complex, but the way they are complex is bogus. Because they are complexity now stops here where I'm stopping. The rest of the work is you coming, substitute here, substitute here. The rest is just pressing the calculator. So you realize even getting the sum will be very easy. So you get the sum, you already have the product, you substitute in the other chi equation, x minus, put the sum, drop x, add the product, equate to 0, underline your answer. You people just promise me in the chat. I just want 5 people to give me a promise that, doctor, we promise those numbers we shall handle, even if they bring power 5, even if they bring power 6. Just tell me that, doctor, we shall handle. Because if they bring power 6, that is the easiest. Because now power 6, for you just told them, okay, you bring in power 6, okay, for me, let me write it as power 3, then here I put 2. You recompare, but no one will bring you power 6. That is wasting students' time. But me just want to handle you as students, that even when they bring you power 16, you know that you're going to put here power what? Power 8, you put here power 2. You struggle until you reach where you're supposed to be. Are we together? So promise me in the chat and say, doctor, we shall handle. Do I really need to do any other number for you to see the flow, or you got the flow? Tell me, doctor, we got the flow and we can do other numbers. How is the flow? Get alpha plus beta first and alpha beta from the old equation. Now come and struggle with these new roots. Get their sum, find the funny algebra, work on it, substitute where necessary, get the sum. Go to the product, multiply the new roots, handle the algebra. When you reach the point of substituting, fixing the old values, get the new product, substitute in the equation, and you're done. Do I really need to do a lot? But I've said a lot. I think you people are just good to go. We can even go to completing squares. We got the flow, we can do other numbers. We got the flow, doctor, we shall. I promise I shall handle. You see, it is easy to promise here in the Zoom chat, but let them bring a paper with the same questions. That's why you deny me 3 times. Be like, you didn't say anything, you didn't even explain. You did one number and then you started shouting for us. You see? Now, the easiest thing. The easiest thing is what I'm going to handle next. Hope you took the screenshot for that part. I told you, for me, I never leave class unless I be like, yeah, whatever I promised students has been covered. The miscellaneous is what you're going to take as there's someone called Jenny. The video has been on for the whole class, but she has not dozed off. I've been watching her. Very focused student. Very focused student. Okay. Now, the next thing, we are going to complete squares. These ones are the easiest. Completing squares. Yeah? You'll now know what I mean when I say one shot. When I say one shot, I mean it. Other than us having 5 classes of quadratics, what is that? Completing squares. So you really need to appreciate, what are we really going to be doing here? What do they mean by completing squares? Completing squares have confused so many people. So many people. So many people. People have things they follow. Get the coefficient, multiply by a half, square it, add it and subtract. Those funny things that you're going to really forget. I don't want to call them funny because you might have heard of them, or you might have been given those things. It is very okay, but you really easily forget. You understand? So I'm going to give you some small sort of concept that may help you. You see, quadratics are too big. That one I'll tell you point blank. Too big. But again, if at all there is a chance for you to have a certain formula to help you with something, okay? Now, I don't want us to waste a lot of time getting to know what they mean by completing squares. That is now serious math. Those of you have heard of math contest. I need now to tell you what a perfect square is. So what do they mean by this? How it came about? I know all those stories, but I'm not going to waste my time, because I'm not going to be straight to what you really need. Yes, this is an academy. That information is very important, but for today, since completing squares they already hard, so I'm not going to make them harder. I'm just going to give you the format, how they always really look like. Are we together? Okay, so completing squares is writing quadratic expressions. No one will ever tell you to tell them the meaning. No, they always just tell you complete squares. If they don't tell you to complete squares, they will tell you to write the quadratic expression in this format. Okay, and it's what we are going to do. is writing quadratic expressions in the form a into x plus b plus q. This is squared, never forget. Yeah, that is it. Though they may try to twist it, they can be like, okay, they can maintain that a, they can be like still x plus b, they square, then they say plus c. They are very funny. They can write it like that, but it is kind of risky because we already have the x plus b, you know those things. We already have that, so it can be a bit risky. But they can do what they want, okay? They can begin with a p. Yes, they can be like, okay, let's begin with p. They be like p. Now they be like x plus q squared. Then they say plus what? Plus r. They can do that. They can do what they want. So, and this one is more common, almost common. Okay, so how will questions come? They will either tell you complete squares, or they will tell you write the quadratic expression in this format, hence solve. So that's what we are going to handle. And this is another interesting thing. Either way, I didn't really think we would cover the alpha and beta with this same class. So thank you for being active, people. So how do you really do that? I'm going to give you the formula we use. We are not going to go through the things of coefficient, a half, square, multiply, and add. No, we are going to just be using a simple formula. Okay? We are going to just be using a simple formula. So I'm going to tell you steps followed. Steps what? Steps followed. 1, ensure that the quadratic expression or the quadratic equation is in the form, you know, the form that we wanted. Okay, let me just tell you, it is in the form where the coefficient of x squared is a 1. I'll just do this, maybe you will get it. Then I'm going to teach you. For the case of the expression, what do we do? For the case of the equation, what do we do? Then after ensuring all that, the last step, we use this formula, x plus the sum over 2 squared minus, hey, sum over 2 squared plus c. And trust me, it is this. It is this that takes us to this. X plus q squared plus r. There are things that I don't expect you to forget. What are those? The fact that x is our what? Variable. Okay. And the fact that our p, our q, our r, our p, our q, our r are the fact that they are what? Like that. Do you see that? That's what we are going to do. Nothing else. So if I was caring about completing squares, that was very bad. That's what we are going to be doing. Now someone may be like, now where are you getting those things of sum over to what? Those things are really hard. They are not. But now the problem may be someone may ask themselves now, which sum, because we have been dealing with a lot of sums. So that's what may really confuse people here. So you may be like, which sum, which sum, which sum, which sum. So we are going to see. Now, okay. That formula, if people first tell me, can you recall that formula? Oh, it's hard. You see what really makes this formula hard is this first step of ensuring that the coefficient of x squared is a 1. Then the other hard thing is that here we have plus and here we have minus. Then the other thing is that we are having squared here and here. Then what is the last thing that makes it hard is that we are having sum over 2 and sum over 2. So those things, I don't know, will you people recall? Can you recall that formula very well? Because trust me, it is hard. But then the other ones are steps. There is another format of completing squares, but for it, it's a bit hard. But you know, learning is a process. So please just do it for me. Accept that formula and please take it on. It is the formula that can only and only simplify your work. That one, I'm telling you facts. It is the only one that can simplify your work. You understand? So someone may be like, things are now becoming hard. They are not really becoming hard. Now completing squares. You understand? So what does completing squares do? You understand? This one factorizes and solves. I want you people to be very serious. The sum we have just handled was the sum of roots. So the topic was roots of a quadratic equation. You know that. So that's why the sum, the product was for roots. But now we are going back to factorizing and solving. That's why even the syllabus book is telling you clearly that the completing squares can help you to solve quadratic equations, and they are attaching the completing square. You understand? So we are back to factorizing, because I told you it is after we have factorized that then we later come and solve. Okay, so as we are taking that sum, you're supposed to be very careful. And that's where most students do the mistake. Now let me ask you people, if at all we are not into things of alpha and beta, so you just have it at the back of your mind, alpha and beta is not here in things of completing squares. Here we are factorizing and hence solving. So we go back to the norm. So the sum we are taking, shall it be that one of shall it be like the one of alpha and beta or no? Okay. Before I go there, let me first put for you a unib number. Before you even go there, so that I ask people questions well when they are seeing the example. How do these questions really come? We are going to pick a number from our kabook, okay? Page 27. Okay? So that you look at how these questions come in, so that you're not just hearing stories. I'm talking of something that you're really seeing, okay? Now, this is how questions come. They never tell you to use completing squares. They say, express this in this form. Are we together? Hence, solve the equation. Realize, so here they are telling you that you're supposed to only and only solve using completing squares, because the format they are giving you is a format of completing what? Squares. And that's what we are going to do. That's what we are going to do. Okay? Let me just solve me one thing and capture that formula very well. But if at all it's hard for people, I don't know what we are going to do. I don't know what we are going to do. Because here it is serious. Now, someone is like, we shall write in the logbook. Then at UNEB, what if they change that logbook? Eh? But me, I'm telling you this out of experience. But in revision, I'll also give you this other formula. But why I hate this formula, let me just give you a red flag. I want you to look at this. You look at that. This is one of the formulas that I've seen that really give people time. Are you seeing this thing? You look at the whole of this. Do you see this? The whole of this is supposed to give you, I think, -1. Because 9 minus 1 is 8. Eh? Are you listening? 8 minus 9 is -1, but there is -10. But this -10 was a result of these last two, -1 and -9. This one is the one that came from this. So there is a way it's a bit technical, and I don't like that way. Yeah. Okay, it has things of perfect square, but they disturb people. But me, I believe if someone can write this formula, oh, okay, let me give you the technique that students usually use, or the one that I usually give my students. You say I always feel bad when I give people something they're supposed to learn by heart. Have these formulas somewhere. So when you're going into the paper, you capture them, you read them again, you make sure that you know it, and you're sure that I will not make any mistake on this formula. Okay? So that when you reach the paper, you first check, do I have anything that deals with completing squares? You write the formula somewhere. If you don't have it or need it, you breathe in and out and forget. Okay? So you either practice so much that they become part of you, or you have a special book where you write formulas that are highly volatile, those you can easily forget. So that every time you're going for a paper, in the last 1 hour, you go through all of them. You reach an exam, you look for those you may need. You write them somewhere in pencil or in small ink, so that you later come back. You learn the trick, very important. So for me, I prefer this formula, provided you can remember the plus, the over to the squared on both the minus and everything. For me, it's the one I'm going to use, and you're going to see we're going to have the same answer. Are we together? Not forgetting that the equation you're using should be in the format where x squared has the coefficient as 1. There shouldn't be a 2, a 3, no negative. Just clean. Okay? Let's do the number. Example 1. That's why I like math. It provides a lot of options, so that you as the student, you choose which one is really friendly, student friendly. Examples. Okay? So the first one, what have they provided? It is x, it is 6 -1. So people, this is an expression. Yeah? Don't risk and put equal to 0. You're risking. So since you already know the formula, you people, those are mathematical formulas. People know they already quoted. So for you, just come and be like, okay, the sum is ready. Now, this is what I was asking. If at all I told you guys that you're supposed to make sure this is coefficient 1 and it is already that, okay, well and good. So I told you the other sum which you're supposed to make a negative, it works in things of alpha, beta. That is a different topic from this. This was supposed to be covered best immediately after the other things of quadratic formula and factorization. But I wanted to end with it because imagine if I ended with alpha power 4 and beta power 4. People would really mess up everything, okay? Now I'm asking, which sum are we going to take on for this case? Remember, now we are back to factorizing and solving. That's what completing squares does. The other one was alpha and beta, a certain concept separate on its own. So are we going to take the sum as +6, or we are going to take it as -6? That's what I want people to tell me. And you should have a reason as to why. For you, what do you think? Thank you so much. +6, because now the other negative, yeah? The other negative is now those things of alpha, beta. Those are other things. We are not there. We are now back to the normal factorizing. So use the normal thing. Though with completing squares, it is different. One of this should be extremely 1. These are one of the hardest things, let me tell you this. Completing squares and alpha, beta, very hard things in the subjects. But then you reach other topics and things are really smooth. Things like differentiation and integration, those ones you will enjoy them so much. Very cheap. So we are going to just come here and say, x is equal to, open brackets, x plus the sum. So the sum is 6, I'll put over 2. Then I'll put squared. Then I'll say minus. Don't forget that minus, my dear. Hey, minus. The sum is what? This over 2. Don't forget the squared. Then the c is just minus 1. Not so? Then guess what? This will become x plus what? 3. This will be squared. 6 over 2 is 3. Squared is 9. Negative 9 minus 1 is negative 10. So do you see that we reach those people very fast? For us, we just need one step to find them. But there is a way they do their things. Even them, they have 2 steps. But my dear, those steps, they have a lot of things behind them. Hey, I don't know whether you people finally see it. So they have their steps, but they are serious. And those steps, I don't want us to struggle. You see, they are telling you add half the coefficient. Are you seeing that? Very serious. Very serious. So there is this format, but for me, we shall not go for it because it has explanations of a perfect what? Square, of which perfect squares are Olympiad math concepts. Yeah, your level doesn't need anyone to know what a perfect square is. You don't. So I also don't like it. So you see, we are just having a formula substitute and then we find these people. But these people have a funny step that has a lot of literature. Don't think it's just like that. So hope we are the safest. Are we together? So they say hence solve. You see that? So even these things of completing squares, it is very easy. So when you reach the hence part, you just equate it to 0. So hence, someone may be like, but we expect 2 values. Where are they going to come from? You relax. So when you reach here, you're supposed to take the 10 the other side, and you'll be like, x squared is equal to 10. Are we together? So when you reach here, after you be like, this one will be the root of 10. Now, you be aware the root of 10 is either a positive or a negative. So if you know that, you'd be like either x plus 3 will be the positive root of 10, or x plus 3 will be the negative root of 10. Because you may be like, now where are the 2 values going to come from? Because we are dealing with a quadratic equation, so we expect 2 values. The 2 values always come in at that point of getting square root. It'd be like square root of a value is either. That's why even in the quadratic formula, where we have the b squared minus 4ac, why we have plus or minus a, it's because the square root of a number is always what? A positive or negative. Don't just think that was decoration. It was real math and it had meaning. Let me hope I've not confused anyone. So do you people get the hence part of completing squares? So here we shall have, this will be negative 3 plus root 10. It is better for the roots to come at the end. And if I taught you SADs, then even here it's better for the root to come at the end. So I will start with negative 3, then minus root 10, like that. Then you have those 2 values. So those are the roots. So you people, you tell me, is completing squares really hard? Look at the number that came. You look at it. Look at how we have factorized it up to this point. Okay? Then look at how we have tried to struggle with the hence part and got the 2 values. Is it really hard? You tell me, can you do other numbers and reach up to that point? Is completing squares really hard? You just tell me we do the next example. We look for it and also handle it very well. Should you go to the next value? I mean example. Now, there are some other things on completing squares where they talk of a minimum and maximum. I don't know whether that one should also be covered, but it is very cheap. We are going to cover it. It's not so hard. Very cheap. How do these questions come? They ask you for the minimum or maximum value for the function. Yep. And I want to give you something very cheap, but I don't know whether people will really like it. Oh, let me see. Let us see the syllabus book. Okay. I think I should maybe we are supposed to, maybe we are going to handle this one as it is. Yeah, I think it will work that way. So that at least you people, because I believe when I add on that, I don't know if people will come back and revisit the class or the content will be too much, but I really wanted this to be full package. But I've realized something. Let's first edit this and see. Concerning this part of simultaneous equations, I told you that we shall handle in simultaneous, not so? So this one was covered. This one, good. Are we together? And solving quadratic equations using factorization, this one we have covered. Completing squares, you guys have seen something, not so? And then quadratic formula, something has also been realized, isn't it? Then roots, this one we have really perfected it so well. So we are now somewhere here and somewhere here. So applying the method of completing squares to verifying the nature of roots using the discriminant. This one we are supposed to do it. So this one I'm going to give you the hint, but you're leaving when you know how verification is done. I told you this part of a quadratic and everything. This one I told you about curve sketching and even gave you the directions. So we are going to do this thing of minimum and maximum, but I think we are supposed to do it for the questions, all of them, okay? But we are going to first get that number, okay? Don't worry, it's also part of everything. I told you this one is supposed to be full package. For me, I don't give up. Even if I start losing, the only thing that can stop class is losing the voice. Even when I start to talk uncoordinated statements, I don't give up. Or broken English, because I know how hard the level is. Okay? So we are supposed to endure, and you're supposed to learn endurance from me. So I want to pose a question. You people, if at all, if at all you're having something like this, let me say 2x 2x squared, let me say plus 4x plus 8 equal to 0. Are we together? This is what they call the equation. I told you that. What really shows the equation are the equal signs. Okay? I told you that also in polynomials. And then I also told you that we have what we call the expression. Okay? Expression doesn't have that thing of equation. So I'll come here and say this plus 4x plus 8. Now, when you want to reduce this thing is kind of easy, because for it is the equation. So you'll be like 2, 2, 2, 2 throughout. Are we together? But then my worry is about this expression. This is where people really make a mistake. How are you really going to, if at all you want to factorize this? Do people know what we do there? Or people may look at this as something hard because you have been doing this. So let me cancel it. You can realize that you're having 2, you're having 2, you're having 2. Like you're having all these ones that can be divided by 2. So when you pull out a 2 like this, what will you have here? You'll have x squared. Here you will have 2x. Here you will have 4. Not so? Then here you will have a 0. Because someone may be like, how does that really apply? So when you pull out a 2, this one will be over 2. Even this one will be over 2. Do you understand? So you will come out with something like this, equal to 0. And that will be valid. But what if it is just an expression without equal signs? After all, it is equal signs that really make the equation to be called the equation. Okay, so you pull it out. So you have x squared. So you have 2x. So you have 4. So my question is, are we going to just end it there? That's what I want people to tell me. If at all it is an expression, and you people know that if at all it is equations, they are the ones we solve. So you can proceed and solve from there. But then if it is an expression, you know, it is expressions that we factorize, and we are not supposed to put equal to 0 if at all the question has not yet really commanded us to equate to 0. So we need to be very careful. So I don't know if people have really created that difference, that if at all something is already it is already equated to 0, that one is easy. You can just divide throughout and come out with whatever you want. But if it is still an expression, my dear, it's a bit different. If it is an expression, it's a bit different. That common factor stays. So with the expression, this one stays. But with the equation, because of that, we have agreed that it disappears. I don't know whether people are getting that technique. It is very key in the next number we are going to do. Very key. So expression, that common factor will always stay. But the equation, it cannot, because even when you pull it out, you have equated it to a 0, so the 0 can work on it. But the expression, we have not equated to anything, so the common factor will stay. Are we together? That is very important to note. So the next example we are going to do, it's going to have that. Okay? And it is the next one. Now, you could leave these answers in SAD form, yeah? Or you could press the calculator and have your answers maybe to 3 dps, 4 dps, whatsoever you want, 2 dps. But when you have a SAD like 10, 10 has no, okay, you cannot simplify it further. You understand? And it is not a perfect square. Like, it has no perfect square root. So you can just leave it as root 10. It is highly acceptable. Okay? Now, let's see the next number that we have on board. You see, they are even saying that we can use the method of completing squares to solve the equation. Yes, and we have actually done that. So look at this number. It is very key. You see, they are telling you to express this. By the mere fact they are telling express, it is an expression, not the equation. So don't think these things of dividing we have been doing, things are going to just be like that. So when you see something like this, you just know those are completing squares. And here they didn't want you to solve, they just wanted you to give them the values of the constants I talked about. Because I told you A, P, and Q are constants, and they wanted their values. X is a variable. So the equation is 2, 8, and 5. So you come and write it. I show you the application of what I've just said. So if it is an expression, you need to be very careful. Most people do that error. They pull out the factor, but again, they want it to disappear, something that cannot happen. Okay? So let me just put here next, because I don't recall what we are supposed to do next. Like, I don't recall whether it is example 2 or 3. So it is 285, this plus 5. You understand? So this is what I'm saying. If it is just an expression without an equal sign, remember this one is supposed to disappear. For you to use completing squares, this one is not supposed to be there. So you pull it out by 4. Someone may be like, why are you pulling it out? Yet 5 is not divisible by 2. You do it by force. Okay? You'd be like, okay, here I will remain with only x squared. Then here I would say 8 divided by 2, so I will remain with 4x. Then here you'll be like 5 divided by 2, so you write it as 5 divided by 2. Okay? What is the goal? That in case this 2 is multiplied inside, we go back to where we have been. So for the expression, the thing remains. Why? So that if we are to multiply again, if it enters inside the bracket, we go back from where we have been. Are we together? Now, this is very important. Very important. Now, this one, we just look at it. We just look at it and then we work on this. That's what we work on, nothing else. Don't look at other things. Now, this is what you're supposed to do, what? To work on. So, if you're to apply the completing squares, guess what? You say equal signs. So this is where I'm going to do the completing squares. Someone may be like, so ticks meaning it's what we work on, and it's the one we are going to really, it's those squares we are going to complete. Guess what? You leave the 2 as it is. And you know we are going to use the curved brackets inside. So you'll be wise and put square brackets here. Okay, now use our formula. What is the formula? Open brackets x plus sum. What is the sum? The sum is 4. Over what? Over 2. Are we together? Close the brackets, then do what? Square. Minus the sum. What is the sum? 4. Over what? Over 2. Then put what? Squared. Plus c. What is c in our case? This. That's what you do. Don't waste your time. Don't waste your time. That's what you're going to be doing. The C, you just come and pick it from here. Just come and pick it from here. Okay? So in actual sense, you should be this person. You are aware that, oh, this sum, no, it is B over A. You see? And you should be that person who is aware that this one is C over A. You understand? But me, I don't want to mention that. I just want to be clear to you that every time the A shouldn't be there as you're applying everything. So that's why at that point, I want to go back to the formula that I gave you, this one, and tell you that this one, let's treat it as the C over A. Are we together? Then let's be aware that this sum is our B over A. And I think people have appreciated that. Yeah? So that C over A is very important. The B over A is very important. After all, we are handling everything when the coefficient of x squared is just a 1. Okay? So when you do that thing, the rest of the things are just substitutions. So go to your calculator. 4 over 2 is 2. 2 squared is 4. So go to your calculator, put in negative 4 plus 5 over 2. Get the answer. Okay? So you just look at this, just look at it. Leave it. Don't bother it. So this one will have become x plus 2. And this is squared. Are we together? Then minus. I don't know whether it's minus or plus, but I know it is minus, but I want you to first put it in the calculator. 4 over 2 is 2. 2 squared is 4. Minus 4 plus 5 over 2. What do you get? I'm waiting for those people who are on. You tell me the answer to that. I'm waiting. Yes, we are not leaving the class. You should get this clearly. Then we are supposed to get the values and see. Negative 3 over 2. Okay, let me trust you all. So it is minus 3 over 2. Okay? Then now the 2 can come and enter. You understand? So as the 2 is entering, you're supposed to now come and be like, this was the question. You get, this was x. This is 2, okay? Then this is x plus 2. This is squared, and then this is minus 3. Do you see that? Very cheap work. Completing squares. And you're done. So they said, so you come and compare with what? With what the question gave. So you can be like, compare with A. This is squared plus Q. You understand? You see, they put plus Q, but they were aware plus Q was becoming negative 3. So that's what I told you. That these unknowns, just know they always hide the negatives within them. So for you, just always do the math. So you can see the A is a 2. And then the P is a 2 also. A. Wow. Then the Q, we have agreed it's a negative 3. Yeah? You see? Very cheap work. Very cheap work. You people just look at that. Do you see how different it is? That if x is already having the coefficient as 1, it is kind of easy. But if it's not, pull it out. Please and please, pull it out. You can do all those things of dividing, but don't forget to pull it out because it must stay. Look at it until you finally reach a step where it can now enter the square bracket. Then compare, get the values they want. That's all they wanted. That question didn't actually ask for a lot of things. Okay? Now, there are things I told you of the discriminant, and I'm going to tell you about the discriminant. Don't worry. Okay? Now, I want to show you this. I want you to look at this question. Are you seeing this one? You tell me how it's going to look like. Let me just do it from here in a very funny way. So you all know the 3 should disappear. So the 3 should be out as a must. So what you put inside are these other things. Here what remains is x squared. So 15 divided by 3 is 5. So this will be 5 what? 5x. 20 divided by 3 is 20 over 3. So this should be something you can do. Then you can now come and handle this. Are we together? But then there is a certain funny hence part. They are saying hence show that the equation has no real roots. Okay? It has no real roots. So they need to know why are we saying that. I'll tell you later about real roots, but let's first do this one. Chap chap. You all know the sum there is now 5. The sum is 5, isn't it? So when the sum is 5, we shall be like this 3. Let's assume the 3 is there. Plus the sum, which is 5. So I'll say over 2. Are we together? So this will be squared. Then we shall have, again, the sum over 2 squared. Then the other one will come, the 20 over 3. Are we together? Now, I want you to see something. You tell me the value of this thing. Remember, 5 squared is 25. 2 squared is 4. So it is negative 25 over 4 plus 20 over 3. I want you to tell me what you get. It is negative 25 over 4 plus 20 over 3. Yeah? I want to show you something. Why those people are saying that. I think we can even use this space here. Be like, this is 3. Then here, people just tell me the result of this. Negative 25 over 4. What do you get? 5 over 12. That's nice. Let me hope you people are being serious. 5 over 12. Okay, so 3, when it multiplies that, it will be somewhere there like that. I want to show you what they mean. Then here, when 3 multiplies 5 over 12, I think we shall get 5 over 4. If I'm not mistaken. Isn't it what we shall get? Do you people realize that as we are solving, remember they're saying equal to 0. Do you people see that when we equate this to 0, this one will become a negative? So it will go there as a negative. But remember, you're supposed to get square root. But you put in the calculator square root of -1. What do they bring you? What do they bring you when you put in square root of -1? Just -1. You just tell me what you get when you press the calculator. Tell me. What do you get when you press the calculator? Root of a negative. What do you get? Put in any, or -2, -10, whatsoever. Math error. You get? So that's what they mean. And you know, math error means something that tends to infinity, something that really can't be defined. So these roots are not real. They can't be defined simply because of that. So do you see? It is also cheap. So when you reach such a step, that's where you stop. Do you see? They also reached this step, but they said, since the root of a negative is not real, the equation cannot have real roots. Do you people, can you do that question on your own and then also have this conclusion and tell them that since a negative has no square root, so the equation cannot have real roots? Can you do that? Please represent your friends who will listen to this well. People are already tired, yet me who has been talking for long is not tired. Then for you say that you're tired. I've told you that we are still pushing. I've not talked about the minimum and maximum, which is the most important part of the class. So can you do that on your own? Use our formula, put in very well, reach the hence part, equate to 0, reach that part of square root of a negative, then conclude that a negative can never have a what? A square root. Hence what? You see? I need around 10 people to tell me that they can. You cannot be here such a big number and then you cannot raise 10 people to tell me that, yeah, we can really do it and have that conclusion. Can you? I'm getting there are only 3 people. Then others, 3 people, those are 5. More 5 people to confirm that you can use our formula, do everything, reach that step, equate to 0, have that thing. Okay, more 2 people. Okay, I think people are on. I thought people are sleeping. That is nice. So, I've been telling you about minimum and maximum. Now, you people, I need you to also do something. Remember, they are telling you to find the minimum value of this. Now, the question is not telling you to use completing squares. The question is not telling you the format to use. And there are so many methods to do actually that. But I'm going to give you the formula of the completing square. It's very cheap. Yeah. And they are saying, how can you really do that? Okay. How can you really get the minimum and maximum? So the completing square. So we are officially done with this according to the syllabus book. Okay? So even this we are done. So all these ones we are done. Of course, you know this one belongs to simultaneous, which shall be the next class. But I think that one will be premium, so it may not be on YouTube. Now, we are now looking at the application. You see, they say apply that method we have been using to complete squares. They now want us to apply it. You see, they want us to apply it and determine the maximum and minimum, which is very cheap. So for now, we are going to do maximum values. Okay, we are going to do values. Then in scenarios, that's why we shall find things like profits, maximum cost, things like that. But basics are needed. These ones, you know where to find them. Then I'm going to give you a hint on what they call the discriminant. It is going to be the last thing. So now you realize we have, this one just needs 1 minute. We actually already talked about it in the bulldozer. So we are just here for 5 minutes to handle minimum, maximum. So you lock in for the last minutes. We really do it. I don't want 3 a.m. to find us here. But at least it's one class and worth it. All quadratics covered in one class. Okay? Now, what is my question? So I've given you the last preamble, the last plan. Before I give you my question, I want us to also handle this one. Let's also solve this. Hence, let's solve it. Hence, if we are to solve, you come and equate this to 0. If we are to solve, okay, they didn't here they wanted values, But what if they said values, then also solve? After there, guess what? Do people see this? You see here you can jump so many steps, 3 over 2, then a root. Do people see that? Do people see that step? Do you see the 3 going the other side? Do you see these 2 dividing that 3? Do you see the x over 2 remaining this side as a squared? Do you see that squared becoming a square root the other side? Now I want to sharpen your minds and then you wake up. Do you get the connection between those 2 steps? Doctor, is it the same as minima and maxima? Yeah. But those ones are better used in the other part of curve sketching. Do people connect those 2 very well? You're quiet, and that is very bad. Do you connect those 2? Do you connect those 2? -3 goes the other side as a positive. The 2 comes for it as divided. The square this side now goes the other side as square root. Do you see all that? And I think that's why they even didn't tell you to really solve, because they didn't want you to have a weird answer. But you all know the square root is either what? Positive or negative, okay? So you come and say either the x is -2 with the positive square root of 3 over 2. Yes, you can have your answer like that. Or is still -2, but with the negative square root of what? 3 over 2. Very correct. Yeah? Are we together, people? Very cheap work. Okay? Now we are going to go to the mega question, the one that is to do with minimum and maximum. Okay, next. When they say minimum and maximum, let's first see the question. Do you see how the question is? They are saying find minimum and maximum value. So when you read the syllabus book, they are like apply. You saw that, eh? They are like apply completing squares to find the minimum and maximum. So you should have that in mind, that completing squares can be used to find minimum and maximum. The question is how. But since they can be used, first appreciate that. Now I want you people to first complete squares for this. And then you write for me the answer in the chat. Or if someone is done, you can just write it for us. I know that people are getting me. You've said that or we have said that completing squares can be used to find minimum and maximum. So when they give you a certain equation and that's what they want, first work on this equation, apply completing squares on it, get something. Now we are supposed to start the thinking from where you people are going to stop. Show me that you have been attending class. Yeah, it is 13 plus 16x plus 3x squared. Okay, so they are saying find the minimum value of that thing, and they also want the value of x for which it occurs. But I've told you application. I've told you that this is application of completing squares. So first apply completing squares on this, then we see what we can do next. I can advise you before you can do anything, first arrange it in order. So that you begin with 3x. You understand? This one stays there. Eh? 3x squared first, 13 goes the other side. Then after, make sure that 3 is not there. First do it on paper, do it neatly. So I'm going to turn off the screen. I don't know whether you people have copied that. Those people who are on, I want you to be sober. So I'm going to stop sharing my screen. I first also do it. Then I expose it. You check if you really have the same steps as me. Okay? So it is 13 plus 6x plus 3x squared. But I've given you some sort of hint. Go until you get the final thing of completing squares that looks like the format we all know. Are we together? Someone to tell me in the chat to stop sharing the screen so that I get to know that you're ready and you're already working on it. Should I stop share? Should I stop share? Okay, someone has told me to stop. So you do it and be fast. I've also started on it. So if by any mistake you don't have work that looks like mine, that means you're not my student. So you need to see at least about, let me see, 10 correct answers, at least. I know that here these people have really respected the time. Yeah, I really always want to teach for these long hours so that I see those students that are really going to pass A level. A level is a level that really needs you to be a person who can endure harsh conditions. Yes, it may take your mental health, but it's worth it. It's worth it. We shall rectify the mental health after passing. Okay, this is 13 right by 13 minus 1. You people, me, I'm done. Yeah, I'm done. I don't know if I also have people who are done. Maybe you can tell me in the chat that I'm done. Yeah, I want to first see 10 people. Those who can upload, you know how we upload, yeah? As you send a message, there is that car box which has a plus in the top right corner of the small car box. Yeah, you take the picture, then you come this side, you select photos, you choose, and then you send it in the chat. Yeah, if you can write it and you have that good handwriting on phone, you can type it. Or the best thing is to wait for me to expose my answer, then you be like, yeah, we have the same answer. Yeah, that means you have actually done it. I can say you have actually, I don't know, anything. Okay. So I'm waiting for you people to tell me that you're ready. For me, I'm ready, I'm done. Okay, at least a good number has told me to share the screen to compare. So I've shared. So you people look at whether, this is what I want you to concentrate on. Don't concentrate on whether we have the same output. Concentrate on whether our work is really looking similar. Yeah, that's one thing I'm really interested in. So if the work is looking similar, don't first edit it, then you write and be like, yeah, it's the same. First really compare, look at it well. You tell me, do you really have the same steps as me? Yeah. What are people saying in the chat? Is it the same? Have you at least reached that point? Should I introduce the part of minimum and maximum? The easiest. Why I'm not happy is that I'm not seeing the number reaching 10. It's about 6 people. Where are the 4 people? And use this time to breathe in and out. Don't just relax. Because I want to give you you understand well that thing of minimum and maximum. And don't send a message twice if you're one person. Send once only. So are we all there? Okay. This I've gotten enough responses. The only difference is that you have 10 over 3, but I have 16 over 3, so I don't know why. It's your calculator, so you press it well. But I think we are there. Now, about this thing of minimum and maximum, this is what I want people to learn. This is what I want you to learn. So you note. Okay. So you do this and be like, logical local way of understanding minimum. Understanding minimum and maximum. Logical local way. So the very first thing you need to appreciate, they have the same condition. You see in this Uganda, there is a statement that usually they make. It means that don't over concentrate on, okay, don't overthink life, okay? Now let me tell you, this minimum and maximum, there is a book of geometry just called minimum and maximum. This is one of the most beautiful concepts in math. But at your level in Uganda, all you need to know, how is it really applying? How do I use it to calculate numbers? And for now, that's what I'll concentrate on. But as we progress, you saw that topic of maximum and minimum value, but it is in differentiation. You go and watch, you will enjoy. When you watch curve sketching, you really get more about the minimum and maximum turning points. Someone called them the maxima and minima, something that it was very good. But that's just pro, nothing much. Are we together? Now they have the same condition, and what is that? Remember, here we are dealing with completing squares. Now I want to give you a simple scenario. Now, because people may not get this well, okay? Um, um, if cheat code. Cheat code. Okay? You will not get this from anywhere. So I want you to listen to my cheat code very well. Okay? But time is going to come when I tell you about the minimum and maximum, things like that. Just don't you worry. So I'm going to give you a certain equation, okay? And then I ask you a few things. Are we together? Remember, remember this, eh? And this is squared, so don't forget that. So I want to first extract out something like this one only, okay? And then I tell you something small. I'd be like, okay, oh, I can first extract the whole of it, and then I tell you something small. Let me just use that. This one is a constant, eh? Constant, we mean doesn't change. This is the logical local way. Constant does not change. Okay? It is the same as this one. The A is a constant and doesn't change, isn't it? Same as this P. Constant, and also the P may not change. But you people tell me, hey, this X is a variable, so it changes. The X alone is a variable, so it changes. But P is a constant, so it doesn't change. So what of X plus P? Does it change or it doesn't change? You tell me. X is a variable, so it changes. P is a constant, so it doesn't what? Change. What of X plus P? The sum of the two. Does it change or it doesn't change? Hey, someone is saying it doesn't. Are you being for real? It changes because it is only the P, the constant, that is not changing, but this is changing. Do you understand? That means this one will also change. Yeah, look at it. Look at this like the nucleus. The nucleus is having protons which carry a positive charge and neutrons which carry no charge. That's why they tell you the whole nucleus is positively what? Charged. So it changes. So that is very key. So if at all we are looking at when we can maximize and when we can minimize, we are supposed to only concentrate on this thing that is changing. Are we together? So I'm going to come and ask you a certain question. So I'm going to say you have something like y equaling to x minus, maybe let me say x minus 2 or x plus 2 whatsoever, don't care, like that. Let me ask you, if at all you put there different values, I want you to be very clear. So this y is like your function. Remember, we are looking at minimum and maximum value of a function. You all know, if you don't put here y, you can put there f of x, just like in that question we are dealing with, f of x. Or you can just have there y. It is the same thing. I taught that in differentiation, that if you don't have there y, you can have there f of x. And you all know, on the x-axis, you put here x, you put here y, which is very clear that y depends on x, so y is a function of x. Those are normal things. Is it okay? Now, if at all we start and we put different values, you can put there is 0. I want you to be very, I don't know, you know what I can say. I want you to, let me use that very thing, so that people can get me well. Okay. Now, I want to pose a certain question. when you have something like this, I've tried to write the whole of it. That's the expression we normally get. If at all they tell you, we want that function to be maximum, we want that function to be minimum, any of the words they have used, I want to pose a simple question, but I don't know if people will get me well. If at all I tell you that I want the whole of this, like the whole of this, I want it to be minimum. Let me begin with minimum, but remember the condition is the same. But remember, guess what? This one cannot change. Even this one will not change. The problem is here. This one is going to change. Now, I want to ask you something. If at all you're looking for the minimum, but remember this one is squared, what is that minimum value you can ever square to give you something minimum? I don't know whether you're getting the question. Let me use the expansion of minimum, but for at the back of your mind, you should know that minimum and maximum, they share the same condition. So I'm looking for the condition. I'm asking you something simple in math. What is that value? What is that value which when squared gives you the minimum value or a very small value that no other value can do? I know that you're getting me. Which value in math do we square? Someone is like 1. Are you sure it is 1? 0. That is a very good trial. People are saying 0. And when I square 0, I'll get 0. Not so? But remember, there are values like -20, which are less than 0. But when you square this one, you get 400. Do you understand? But remember, I've told you that we want to try our level best. We want this function to give us the most minimum value it can ever give. Okay, we want the minimum function of this value. But there are things we don't have control over. Like what? We don't have control over this A. It is a constant, it can't change. We have no control over this. We don't have control over this, it cannot change. But the X plus P changes. So it's the only one we can make good use of by minimizing it. So the whole function will be minimized. But you cannot say you're going to minimize a constant. That one is already a Q a constant. Maybe it is a 3, it cannot change. Maybe this one is already a 5, it is a constant, it cannot change. But since here X is with P, this is a variable, so you still have a chance of playing with the variable, because for it is the variable, it can vary, it can change. You can play with it and then minimize that part. So by chance you minimize that part, the whole function will end up getting minimized. I don't know whether people connect those dots. I don't just want to give you the condition, but I want you to have some simple explanation so that you show that you really came from an academy that gave you a special skill of how you connect concepts in science and math. Are we together, people? And you people are saying 0. You understand? And 0 squared still is 0. So do people agree with me that for the whole thing to really be minimum, for me to minimize this whole thing, the whole of this should be a 0? Do people agree that for you to minimize the whole function, this should be a 0? Because you're saying that only what is inside here should be a 0, but 0 squared is still 0. That means the whole thing is a 0. And that is only when you can minimize it. Because when you make a problem and go into the negatives, we have seen negatives do more harm than good. If at all you're having 0 here, okay, here you have 5 and here you have -5. Let us square all of them. This one gives you 25, but this one gives you 0. Even if you just go one step away, -0.001, the moment you square it, it's going to give you something bigger than 0. So you will not have minimized the equation. So if by chance we minimize the part we can control, we shall have ended up minimizing the whole function and then we shall obtain the answer. I don't know whether people have gotten that story. It's what we are going to be using. Okay, so for you to get the minimum, or the condition is the same, the whole thing here should be a 0. That means, remember, this 0 is also going to affect this. Are you aware? Are you aware the 0 is also going to affect the A, and still you end up with a 0? Do you see that? And if you see that, do you agree with me that this one is always the minimum stroke maximum value? Who agrees with me? I want someone who agrees with me. If I told you, people have told me that what should be inside here for us to do that most minimization, it should be a 0. But 0 squared is still 0, so the whole thing is a 0. The moment it multiplies this A, it will still give you a 0. So we'll have remained with only this. So do you see that that will always be the value that we shall always be looking for? I don't know whether people are getting me. I don't know whether people are getting me. Do you get that? People are writing I. What do you mean? What does I mean? Do you really get that? And when you tell me that you get it, that means you're also confirming that even people in the future will get this, because for you, you're tired. For them, they will be sober. So if you really get that, let's now go back to the question. This is where we ended. What did the question say? The question said, find the minimum value. So it is the minimum value you get first before you even get the value of x for which that value occurs. So guess what? We stopped somewhere here. Okay? By the way, this was not even the best answer. The best answer, we had to multiply, like, it had to enter throughout. I don't know whether people saw that. Okay. So when it enters, it is 1363. So let's continue with that question. I show you how you can get whether maximum, whether minimum, it is same condition. So continuation. We had 13. You can just write it the way it was in the question. This was 6x. This was the x squared. So here, I'm like, I've forgotten what we had here. What was it? Is it 2? Is squared, then plus 10? Is it what people have? You people confirm to me. Is it what you have? I don't want to leave anyone behind. Someone is telling me this is 1. Hope that is right. So are we all there? That's where we ended. I was not there. But do you know how that is coming about? Let's go back, okay, briefly. Look at this. Do you see that this 3 will come here? Then it will just be there. But the moment it sees this 3, it will cancel it, and we shall only remain with the 10. Do you see that? So we shall have 3 into x plus 1, then square, then plus 10. Are we together? But remember, they want minimum value of the function. Minimum value. Now, whoever is serious, you say the minimum value. You say it, if at all you've been following. So when you reach here, you have actually reached. These other things are for pros, because a pro will just come and state it. You just state it without saying anything. You say that value in the chat. Thank you so much. 10. That is it. You see, people are saying 10, yeah? But at least you have some reasoning, yeah? You see, some people say that I always want to teach for long periods, but that's not what I want. I just always want to make sure the point goes home. I would just tell you, people, for those things, always just look at this value, you comment, but that's not how things are supposed to be done. Okay? So you people know the reason as to why. That you know that if at all I want this whole function to be minimized, I don't have control over this. I don't have control over this. But since this x is a variable and it keeps on changing, I can take advantage of it. But the only way I can minimize this, I should look for that one value in math, which when squared gives me the smallest value possible. You all know the smallest value is the smallest negative, not so? But then the problem with negatives, when you square them, they become very weird. So that's the only problem with negatives. So we find out that it is the 0 to help us. The 0 is the smallest number, which when squared gives you the smallest number possible. There is no other value. They shouldn't even lie to you. Because whether negative or positive, when squared, they give you positive values that are greater than 0. Okay? And I've said, since we have agreed that what is inside should be, okay, 0 squared is 0. Okay? So that means that 0 we are getting will also end up killing this 3. So when it kills the 3, we shall always remain with only this value as the outcome. So whether they have asked maximum, whether they have asked minimum, that should always be the value. Are we together? Then that's not where the question ends. The question really proceeds, and they tell you, and state the value of x for which this occurs. So for you to set the value or the x value over which this occurs, we have already said you don't have control over this, but you have control over this. And we said something about that. What did we say? We said that the whole of that is 0. So you be a serious student and say, for minimum value, vmin, it means minimum value. Even if they interpret it as minimum volume, for you don't mind. That's not really a concern in math. Okay? So for us to get the minimum value, the x plus 1 all over squared should be 0. And you see how we are getting the negative 1 as the answer? You don't want us to have so many steps. That is obvious. So that is the x value. There is when they are going to ask you for the x value first, please first do that, then get the minimum value later. The order they have given you in the question is what you should follow. But it is always very, very easy. Do people get me there? Do you get me for the x value? Yeah? So the condition that I said it is the same. That is it. That is it. The same condition that I was talking about. People first tell me, is the x value okay? Is the x value okay? That part we are equating to 0. Don't make a mistake and forget to equate what is squared to 0. That is very key, very key. Because it is only 0 that we square and get 0. There is nothing else. You tell me any other value we square and get 0. It is not there. Okay? So whatever we are equating to 0, make sure it is squared, then conclude with the x value. Are we together? So even when they ask for maximum value, you just remove minimum and put maximum. It is the same condition. It is the same condition. You're just changing words from the word minimum to the word maximum. Okay? Yeah. So that is it. That is it. Okay? So then note, every time you're having this x plus p and this is squared, whether it is minimum, whether it is maximum, have it in mind, it will always be that q, whether it is negative or positive. I told you these are unknown, so they engulf everything. That is it. So when they ask you for the x value over which the maximum or minimum occurs, that's the language they use. For you don't mind them, for you know what to do. You know that I will get all this and equate it to 0. But you know the story. One thing I like about this concept is that even if you've forgotten that story I've given you, at least you recall that and be like, one thing I know Dr. told us, whatever you see here is the minimum or the maximum. And he told us the whole thing should be equated to 0. This one, we should not include this k because we don't have control over a, but we have control over x plus p. And whatever we are equating to 0, we should make sure the k squared is there. To respect the fact that 0 squared still remains a 0, then we conclude with our answer being negative p. You see that? So these are the minimums and maximum values. Then this is the x value over which those values occur. I don't know whether people get me. Now, you first tell me in the chat. I need 10 people to tell me point gotten, point gotten. I don't know whether people are taking a screenshot for that. but at least we have tried our level best. Okay? And I told you to be very serious. Now, I'm going to go to now these other numbers. I pick anything that we have summarized, and then you tell me what the now like this question. Let me see. Okay, this is where we had stopped. Let me just use this one. Yeah, let me just use this one. So this one was the one for completing squares. I told you you're supposed to be taking notes on your own. Okay, on your own, so that you have all this. Every time you write the math on your own, it really makes sense. You tell me, what is the maximum value in the chart? Maximum value, it's what I want. So you've actually done this, you've reached that step, and someone really comes out, they say, that's the minimum value or maximum. Let's begin with maximum. Which is maximum? People are already failing. People, it cannot be 10, yeah? It cannot be 10. I told you those unknowns, it is there as plus q, but it can be a negative. So when it's a negative, people are like, a negative cannot be maximum. You avoid that mentality. Just know they are the same conditions. So the minimum and maximum value, they are the same. So if at all a question, if at all they ask minimum and for you had negative 10, and then the teacher comes and says, change the word minimum to maximum, the value doesn't change. Whether minimum or maximum, you just pick it as it is. Okay? So the maximum value negative 10, the minimum value negative 10. Which one is the value of x where that minimum or maximum occurs? You tell me, what is that value of x where the minimum or maximum occurs? You tell me. You tell me in the chat, what is that x value? Yeah, people are passing it, negative 3. So you just carry the x plus 3 squared, you equate to 0, and then you get everything. Okay? Now, in case you're online and there are some parts you didn't take for the screenshot, you're supposed to visit the recorded class, and then you just skip, yeah? You just skip and reach that point you want, and then you take a screenshot and maybe you copy. But it's better you always pause and do what? And copy that work. Are we together? So those things are not actually so hard. Let us also look at these notes of ours. Now, this number that we were doing, this is where they stopped. Are you seeing? This is where they stopped. That was the completing of squares. Tell me in the chat, minimum or maximum value, whatever they ask for, minimum or maximum value. As of now, I'm telling you minimum or maximum because the question will say it. But when you reach curve sketching, I will tell you, it's not a must. They cannot even change the question. There is when we have maximum, there is when we have minimum, and I will teach you that. Yeah, it depends on what is there. It depends on this, whether we have here negative, whether we have there positive. But you learn that, don't worry. Okay? It's not something hard. Even in revision, we shall see the more complex things. People have passed it 5 over 4. Now tell me the x value over which or when or whatever the 5 over 4 happens or occurs. What is the x value when the 5 over 4 is happening? You tell me the x value when the 5 over 4 is happening. That's what I want. That's what I want. You tell me. Negative 5 over 2. Thank you so much. So that is it. Things are not hard at all, yeah? So even when they give you a negative, guess what? Even when they give you a negative, things just become cheaper. Yeah? Even when they give you something that is having a negative, maybe paper-wise, they can give you two numbers like this. And this is maybe 5 minus, this is 3x squared, and then this is plus 4x. Do you see that? They're hiding that negative. But you deep down, you should be aware that when you rearrange, this will be negative 3x plus 4x. Do you see that? Then plus 5. Then some of them are too open. They just do that. Okay? maybe plus 2x, and then minus 5. But remember, these are not equations. Yeah, so you're supposed to be very careful. Now, when you're handling this, I think this one I will use this space down. So when you're handling this, maybe -3, you first bring it out so that it leaves our things. But I told you need to be very careful. So this one will be x squared. Now this one will be, you tell me what should I put there next. You complete for me this. You just tell me what I should put here in the chat. I see whether people really know these things well. What should I put there as the balance? Because the rearranging, I just believe everyone can rearrange. I told you a sign before a number is a sign of that number. So the -3 was actually part of this. So I brought it first. I brought this. Then even this +5. There is a positive there. So the positive belongs to the 5, though it's invisible. So what should I put there after? You see people failing. What should I put there? I've pulled out the -3 for reasons you all know. That before you complete squares, the x squared should have the coefficient of 1. So this one, it likes it or not, it should leave, it should be outside by force. But now the problem is usually with what we are supposed to put here. Students usually fail that so much. So I want to see those two values. You see people are not passing, but someone has really put them right. You see? Even others, please first try. People are giving me positives. But remember, when you put there a positive, okay, let's say you're putting there 4/3. Do you see that when this one multiplies this, you're going to get -4? This one was +4. Do you see that? So you need to be very careful that when you put out a negative, first study whatever you're bringing inside the bracket and ask yourself whether it will be taking you back to the same thing that was there. So this is best as 4/3. That is wiser, okay? Then even this one is -5 over what? 5/3. Then people can struggle with this, I believe, because now the sum here is very clear, -4/3. So you find ways of struggling. Even this one, first put out the -1, okay? Or you can even just have it as a negative, and even if you don't show the 1, then you'll be like, this is x squared. Are we together? This is negative, because when you open brackets, you're supposed to go back. Now this one has been originally negative. Because negative is outside, then it becomes what? Positive. These are very sensitive things, but they are coming in at last. So let me hope people are getting the point. So people tell me, have you also gotten what to do in case the negative comes in? You said that negative will not even cause any change, whether we are getting maximum or minimum value. Do you see that it will not even bother us? It will not disturb us, because we don't even apply it as we are getting the minimum or maximum. For us, we just pick our Q. You get? And as we are getting the x value over which the value occurs, we just equate the squared part to a 0 without involving this, because this is a constant, so there is no way we can play with it. It doesn't change. We just play with that thing for a reason you all know. And whatever you're equating to a 0, you just need to make sure there are brackets here and they are squared. Never forget it, so that your math is just clean. Okay? That is very key. Now, I think we have exhausted completing squares and how. So you just tell me in the chat. Do you really want to confirm to me and really say that, doctor, as far as this is concerned, minimum and maximum, we are actually there. This maximum, minimum. Should we put ticks there? When they say maximum profits, minimum costs, will you be in position to do those things? Very cheap things. Very cheap things. Very cheap things. Okay, now I want to give you a certain hint that we shall really rectify when we reach curve sketching. I told you this lesson is supposed to be full package. Okay, I've told you about the equations that will have the positive a, and I've told you about those that will have negative a. Okay. I taught students how to plot scatter diagrams and how to plot other things. But I want you to go to Pinterest right now, okay? Pinterest. You see, you people, you don't want to use this app, but I always warn you. But it is a very good app. Mathematics, physics, okay, science and everything. But I think today let me use mine, Pinterest. I show you something, yeah? Are you seeing my Pinterest? You first tell me, are you in position to see my Pinterest? Can you see my Pinterest? That is the app, yeah? I don't know, here I was looking for the structure of the human heart. Yeah, I wanted to, I think I was studying some valvular disorders, and I wanted to get the best animation for mitral regurgitation and mitral stenosis, yeah, as part of some of the valvular disorders. So I wanted to get clear illustrations to show my international students of medicine. You get? I think, yeah, it's either mitral prolapse, regurgitation, or mitral stenosis, but I can't recall. But I usually use it. So let me also use it for my local students in Uganda. So I want you to look, you ask, you just put in quadratic curve. Very good app. How can I fail? If at all Pinterest was there during our years, I think I could get, 30 points. So there is that where we have A as positive, then there is when we have A as negative. After all, you people don't want to use Pinterest. Now for me, after all, it's me is going to do your name. So plus C. Let me pray they really bring this. Wow. Wow. So you see, they have at least provided something. Whatever I just pressed. This is what I want. I want you to look at this image. You look at the blue curve. Do you see the blue curve? Do you see where it is pointing? Do you see that the blue, you tell me the name of the blue curve. The name of the blue curve. How does it look like? The name of the blue curve. What have they put? Because people may not be seeing this. Tell me in the chat. How is the blue curve labeled and how is the orange curve labeled? So you write for me the name of the blue curve, comma, name of the orange curve. Do that for me, please. I confirm that you people are really here. I confirm that you people are really here. Someone is like local ouch. Local simply means we are in the same area. Yeah. If you also get a teacher and that teacher is in America, that is your international teacher. And if I'm in the same country with you, so I'm your local teacher. So look at local as the English meaning, not the slang. People are saying that. You see someone is saying a greater than 1. That's not how it's labeled. You people, the blue curve I'm talking about, it's labeled as y is equal to x squared. And the orange curve, I mean, it's labeled as y equal to negative x squared. Do you see, okay, that curve? Just tell me that, yeah, we see it. Maybe I should increase the size. Do you see it? The blue one, which is y equal to x squared, and the orange one, which is negative x squared. So we are going to also answer this. We are going to separate your responses with the comma. You tell me where the blue curve is pointing, where it is facing, and you also tell me where the orange one is facing. Blue then orange, where they are facing, down or up, east or west, left or right, so that I get to know that, yeah, people are really seeing these things. Someone is saying blue upwards. Don't look at the arrow. You people, we are talking about facing. Physics students, you know what I mean by face. If I do something like this, of A and B, which one is the face? This is the face. You understand? Yeah, so you be organized. People are looking at arrows. People are looking at arrows. Okay, anyway, that is okay. Let me not over that. The good thing you've looked at them. And after all, that is not so important, whatever they are facing. Okay? Okay. But let's do this. You've realized ig y equal to x squared, where a is a positive, yeah? And here a is a negative, yeah? Just like negative x squared of y. Like this, negative x squared of the function y. Like that. This is what I want you to learn. There are so many curves just because the one of Pinterest has really picked that. Okay? Even here, let me have it. So you're going to learn it from me. Now, you have realized, you just look at it, the one of blue. Do you see how it's facing? That's how they face. All of them. All of them. There is face like this. Then look at the orange one. This is how it's facing. So those with negatives, that's how they face. All of them. There is face like this. Now, what they call those minimum and maximum what? They are these points, these ones. So I want you to tell me, this first one that I've just circled, this one, it's what they call a turning point, where the thing is turning. Turning point. Turning point. You tell me that first turning point, according to you, is it minimum or maximum? Then you're also going to tell me about this. You tell me this. Where can I put it? This one. You also tell me it is also a turning point. Then you tell me, is it minimum or maximum? There are 2 points, different points, and you've looked at how they look if at all you're to plot. That's how they look. One is like, I don't know what I should say, but one is like this, another one is like this. One is facing up, another one down, period. One has a maximum turning point, another one a minimum turning point. Blue is positive, second is maximum. You people, you tell me the first one, the turning point. It is at that point where it turns, it is called a turning point. So for this first one, where we are having this one as positive, see this one is our concern, this. Okay, then here also our concern is on this negative, here our concern is on this positive. And we have looked at Pinterest and it is showing us that's how the curves will really look. It will fall, then rise. But the other ones, it will rise, then fall. Okay? So the first turning point, is it minimum or maximum? Someone is saying the first is maximum. I think people are tired. It is minimum. Don't you see that it is down, the other one is up? That is just English. Don't overthink. This one is down, the other one is up. Yeah? So this one is what? Is minimum. Okay? Then this one is maximum. It is up. So I want you to leave this class when you at least have that hint, that for those equations that look like that, guess what? Minimum turning point. For the other ones where x squared may have a negative before it, guess what? Maximum turning what? Point. So there are things that I really want you to look at. Meanwhile, something so small. Let me see. I want you to look at this question. You see, I told you that questions don't just fall, yeah? They don't just fall. There are reasons as to why they are set. When you look at this one, it was positive. So you can get it like this, positive minimum. You understand, that when this one is positive, the turning point will be minimum. When negative before x, the turning point will be maximum, okay? That's why it was here positive before x and they asked for minimum value. Are we together? We go to the next question. What are they asking? They are saying by completing squares, here, thank God they have even mentioned it. They are asking for the greatest value. When they ask for the greatest value, they are asking for at maximum. But maximum happens when there is a negative before x squared. Do you see in our question that our x squared has a negative before? So it has a maximum turning point. So we expect a maximum value, but the technique doesn't change. People, the technique doesn't change. Get that from me. Get that from me. You look at what these people have done. Are you seeing this? So for us, this is the answer we shall have. According to how we organize our work. For us, we shall maintain something like this. Are we together? So when they ask us for the greatest value, we shall just come and pick this 10 and it is here. It is the greatest. When they ask for the maximum value, okay, when they ask for the value of x for which this maximum value occurs, we don't want to mind about this negative one. It is a constant and we have no control over it. We just concentrate on this thing with the square and equate it to 0. And then we shall get our x as -3. Do you see, people, that these things are cheap? I don't know. You tell me in the chat. Around 5 people tell me that it is cheap. That one we shall handle. Shall you handle both minimum and maximum, and shall you have that knowledge that here these people here asked greatest because of this, here these people asked minimum because of this, and this value I don't have control over it. When they ask for greatest, this is what I pull out. When they ask for the x value for which it occurs, I know what to equate to 0, and I shouldn't forget the squared. That simple mathematical jazz. Okay, now let me hide this. I don't know if people have copied. But you tell me, this is the equation. Okay, you tell me. Should they ask for the least value or minimum value? Sorry, minimum or maximum? You tell me. Should they ask for minimum or maximum? Minimum or maximum? But you people, let me tell you, today you've learned a lot of things. You're supposed to practice, jokes aside, especially this last part. What I like about it, it's just having concepts direct. So you're supposed to get them. Are we together? You see people telling me maximum. You people, why are you too bad? After all the energy I've used, you can even see here. I told you now you can get it in this way. Positive, minimum. Negative, maximum. If this is hard for you, I'll give you a technique. Another technique that you can follow. You see, you can always plot this curve. If at all you have issues, you plot this curve. You people, if at all you believe or you have a feeling that doctor, for me that one it has refused, I cannot really manage. I really need the way of, okay, I really need the best way I can really recall that. Even if I just recall that positive minimum, I can be in position to be like negative maximum. Let me also help you. I will not leave you because I've seen people who are flopping. So you assume you're having this, y is x squared. So you come and be like, I'm going to plot it de novo. And you know how we plot it. We always give values of x, then, okay, you understand it? And be like, let me just forge these ones. And then I have something like that, okay? But remember, for you to get y, you square x. So this will be 4, this will be 1, this will be 0, this will be 1, this will be 4. Am I right? Then you'll be like, let me plot. I see how it will come out. Okay, you have all the points. So I'll come and be like, I don't have any negative y value, isn't it? That means my values may be all positive. So I'll come and do this. Yes. And I be like, okay, I have my -2 here, I have my -1 here, I have my 1 here, I have my 2 here. Because this is 0, then my greatest value of y is actually a 4. So I can put here 2, I can put here 3, I can put here 4, something like that. Are we together? Then guess what? Let us start plotting. -2, 4, -2, 4 is here. Do you see that? -1, 1 is here. For people now to plot 0, 0 is here. 1, 1 is here. Are we together? Then 2, 4 is here. Then you join. Be like, oh, let me join. Yeah. Then you label it and say, this is my line. The one you saw on Pinterest. So don't think it was something so hard that I couldn't do. I just wanted you to appreciate the beauty of Pinterest. So when you do something like this, you'll be like, oh, the ones where the coefficient of x squared is a positive, they have a minimum. Good. So when you see any equation, these examiners, even if they try to forge it around and it is maybe like this, for you concentrate on x squared and be like, the coefficient is positive, this way it is a positive, so I expect a minimum value. Good. Then the reverse is true for the negative coefficient. Let me hope now it's okay. You've also not just crammed that. In case you feel like you forget, you be like, okay, what do I want? I want x squared positive. If I get the positive, I can get the knowledge of negative. Draw your table. Guess x values, put those of y, make a simple sketch, get to know the turning point. What is its nature? You understand? Is it a minimum? Is it a maximum? Something like that. So you also assure me that you can now know. You people, I don't know, but I've given you the content you really need for the topic. Okay? Now, guess what? Guess what? Guess what? Do you see this? When you see a negative like that, what do you expect? Minimum or maximum value? You tell me in the chat. We are having a negative before x. So what do you expect when you see that? What do you expect? Thank you so much. You expect maximum. But guess what? What is the question having least value? Isn't that a contradiction? Isn't that a contradiction? Hey, isn't that a contradiction? But let me also teach you. You're going to learn. Hey, you people, if at all you're having something like 1 over, maybe 1 over 4. 1 over 4, we all know it is 0.5. Are we together? But guess what? I can reduce that 4 to a 2. I can increase that 4 to a 10. Are we together? 1 over 2, everyone knows that half is 0.5, isn't it? And 1 over 10, we all know it is 0.1. You people, you tell me, of 0.5 and 0.1, which one is greater? You tell me in the chat. You see? Let me also teach you this. You see, now these last minutes are shaping you to really become very good math students. 0.5, thank you. So you people are saying that 0.5 is really, so this one is what? Greater. Not so, but this one is least. That's what you're saying. Remember, this one was a 4. But remember, I reduced this one and it became 2. So 2 was least or minimum. But you guys are saying it's giving me something what? Maximum. Even this 10, it was 4, I made it 10. So it's like I maximized it. But after maximizing it, it's like I ended up what? Minimizing the outcome. I don't know whether people are really getting me. Do you get what I'm trying to teach you? That when the denominator is a maximum, the overall result is a minimum. And when the denominator is a minimum, the overall result is a maximum. Do you get that technique as well? Do you see that? That when you make a mistake and maximize the denominator, you're going to have a minimum overall result. When you minimize the denominator, you have a maximum overall result. Do you understand that? You people, you speak. Do you see that? So when you see such a question, don't say, Dr. Paul gave us wrong things. No. Yes, down we have a maximum. But see, because of 1 out of, it recreates those situations of us coming up with the least value finally. Is that okay? So you're going to do it normally, nothing. Let me tell you, there is totally nothing that is really going to really affect us. Nothing is going to change. Like, for example, look here. Look here. They maintained 1 out of throughout. Okay. This one, they just rearranged it as I told you, and the negative was put out. So they really applied completing squares, and they came up with something like this. So I believe whoever is here can come up with something like this, isn't it? Now let us be realistic. Let us be realistic. You're coming up with something like that. But remember, this is what I want you to get from me. Let us open these brackets down, this denominator. It's going to be negative. This one will be x plus 1. This will be what? Squared. This will be positive 3. Isn't it? If at all you know what I'm saying. Now, this is what we have. But remember, this one is 1 out of. Understand? That 1 out of is a constant. When you're only dealing with this. So all the answers of this you're going to obtain. You just need to put, I don't know, I just beg you people get me. All the answers of the denominator you're going to be getting, you just put 1 over the answer you're getting down. Are you getting me? That 1 out of is just there to, it's just there for formality, kweraga. It's there for actually nothing. So for you, just deal with this. You be like, what do these people want? They want the least value. Then you be like, I know it is this. Whether minimum or maximum, for you, you know it is this. But because of this 1 out of, you fix it there and say 1 over 3. I told you that here we are in Uganda. There are things I will just tell you and you're supposed to get them the way they are. So is that okay? When they ask you now for the x value for which it occurs, you'll be like, oh, I'm supposed to equate the whole of this to 0 and I'll get negative 1. So what is 1 over negative 1? It stays negative 1. It is here. Even the 1 over 3 is here. You people, is that hard? Is that hard? Can you really wake up and say that Dr. Paul taught us those things, but he left out those of 1 out of? Do you see that those ones of 1 out of are also very cheap? Are they hard? You tell me, is 1 over hard or it is cheap? And you people are quiet. That is bad. I'm explaining and I need feedback from you immediately. You're representing so many people who will listen to this later. Cheap. It is good to say cheap here, but you start calculating on your own. Now look at this. It is plus 3x squared. So the coefficient is positive. We expect minimum. Are we together? But guess what? The question is asking for greatest because of 1 out of. That when it is out 1 out of a minimum denominator, the overall result is maximum. You will understand that more when we reach error analysis. It is even already recorded. There are 2 classes and I completed. And those are one of the things we will enjoy so much from the drive. Let me just maybe show you small. It is topic 16. It is the last topic in senior 5. It is term 3. Where is term 3? It is here. I think I'm tired. What am I pressing? It is term 3 and it is topic 16. It is here, error analysis. Lesson 1 and lesson 2. Those are one of the lessons you will enjoy most from Science Scholars Academy. Because things were explained and nothing you can forget. Nothing you can really fail to derive on your own. So you'll also enjoy from there. I told you math, I completed the syllabus. You people are just making me repeat these simple things. You see? Now, for you don't mind about the 1 out of, you just handle the numerator only. You can even first tell the examiner, if at all you know this person who is good at saying 1 out of, then you do your math from here. You can first tell them considering denominator only. So you work on the denominator normally like others, then you bring the 1 out of later on when you finally have it. But if you can be writing 1 out of, 1 out of, 1 out of, and you're doing your business here down, it is very okay. It is very okay. If you want to first have a consideration of the denominator, summarize it up to this point, because I believe everyone here can reach this point. And trust me, this number, we did it. You just don't want to believe me. You people, if you recall well, do you realize this is the number you all tried, but these people have just changed it and added the 1 out of? You look at that denominator. Isn't it the number we tried? Isn't it the number we tried? They have just put a 1 out of. And you realize they have also calculated it up to when they have reached to this thing we obtained. The only difference is the one out of. So when they ask, do you remember that previously our greatest value, okay, the value we had was 10. So this time around, because of the one out of, it will also be 1 over 10. Remember that our value was a negative 1, but 1 over negative 1 doesn't change anything, so it remains negative 1. You people, you can see now they are going to quadratic formula, which we completed. So it's like the topic is done from A to Z. Are those numbers of 1 out of also very okay? Can you do them? Can you write those steps well like I do? Have you been following? And you feel like the lesson here, it has really been a success? You've benefited and you hope to be a better math student? Those are things I want to see in the chat. Not lamentations, but promises, academic promises that are really worth it. Because when I look at the syllabus, let me tell you, most of the things have been said. Most of the things, actually everything. I've told you, I've even hinted about the representation of information graphically. Though there is a better way, I really want to bring it out. Okay? Now here they are telling about the nature of roots using what we call the discriminant. Some of you don't even know the discriminant, to make matters worse. But I'm also going to teach you that at the last thing. It is 15 minutes to 4 a.m. At least you'll be those kinds of students who will tell people stories that, do you know that we have ever had a math class that stopped at 4 a.m. and we started at 8? Those are how many? 8 hours of a class. Yes. You should have stories to tell. And if you're here and you've been here from the beginning up to the end, then for you, you're just blessed. Just pray to God that you keep up with that spirit. Now, you tell me in the chat, should I hint about the discriminant so that we fully hint, so that we fully handle this? Or you want the discriminant as research work? Do you also want it now? I'm seeing so many messages. Are people giving up before the tutor? Is that really fair? For me, I can speak. I told you as a child, I used to go for talking competitions for a district. Okay? Hint about it. Go on. Yes, you're the people I want. So let's go. Discriminant. Okay. Now, I want you to recall this. Let me try to test my math. I see if I'm still so good. I used to forge these things. Negative b plus or minus. So you people, you tell me in the chat. Because I may be doing something that people don't really want. Do you prefer quadratic? Do you prefer the topic quadratics to have 3 classes and more, just like you handle them at school? Let me tell you, these are 10 lessons. You like it or not? These are 10 lessons in school. So you want me to have maybe 5 to 10 lessons, or you want me to have 1 class? We have 1 class microscopy down, 1 class quadratics down, 1 class, because that's the system I want to begin very soon. I say transport biology, 12 hours non-stop transport down, so that you also watch it in bits. Be like, okay, today let me watch 3 hours. Or you want those bits like transport? I have like 15 classes. Yeah, you want 1 class so that if by chance you attend, you're also done. Okay. But we shall pass, inshallah. Okay. Now, I've even missed it. Tahajjud. Tahajjud was 3 a.m. But the good thing, I'm helping God's people. Yeah. I wish I could combine it with subuh. But we can maybe proceed. Now, are you seeing this cat thing? Eh? This one. But there is a way blue resembles purple. And I don't know. Around midnight, I was very tired. But I don't know why I'm getting so much energy. Okay. B squared, this is what they call the discriminant. So people are hearing discriminant, you think it's going to be something very, no, that is the discriminant, nothing much. So they just want you to verify the nature of roots using what they call the discriminant. Are we together? Now, the very first one. I want you to listen. I have this. I'm going to use all sorts of equations. I have 3x squared. Are we together? Then let me be like, this is minus 5x. Okay. Then this is plus 2 equal to 0. That is one equation. But do you see where the discriminant is? Okay. Let me write another one. So this other one, let me just have something so simple. Minus 4x. Are we together? Plus 4. Something like that. Then I equate it to what? To 0. Together. Then let me have the last one. And the last one, I think let me juggle this around so that people don't over fall into my trap. This is 1 plus 4x squared minus 4x equal to 0. Okay. Then they can also have some other format. Let me give it to you like this, then maybe we can rewrite it together after. These people are wise, they can give you something like say 5 is equal to, okay, then they be like, okay, let me first write it here. Five x minus 5 equal to 0. Yeah, it is 5 squared plus 5x minus this equal to 0. Do you see that? Let me say this is 10. Yeah. So they can juggle it around, yeah, and tell you 10 is 5x plus x squared, yeah? Like that, just playing with your mind. Then you're supposed to rearrange after. Even this one, they can play with you just like that. Now, I want us to use bulldozer in each of the cases. So here, you come and say this is x, not so. Then you'll be like, this is what? Negative. And you'll be like that, not so, into this. Now here, there is a certain method I want to use, and I want to be very fast. B squared. Our b here is negative 5, not so? So b squared here will be 25 minus 4sc. 4 times a, 3, 12. Times c, this 24. So here I will have 24. Not so? Then this one will be, that will be over 2, isn't it? Then I also want us to come here. You all know this is the a. Negative 4 is the b. This one is the c. Okay. So when I get x, I'll be like negative b. Actually, let me be very fast. Anyway, let me do it. B squared. What is my b? My b is negative 4. When I square it, I get 16. Are we together? 4sc. 4 times 4. Like my a is here. 4sc times 4. My c is a 1. It is 16. Are we together? Out of 2. Oh, someone is talking about this. 2 into 3, that is very good, thank you. Then here we shall have 2 into 4. Okay, so people are following. That is nice. Then this side, we shall have x. My b here is a 5, so I just have negative 5 plus or minus. My b to be 25, not so. Minus 4sc. Do you see this? Now I'm going to make this a positive, yeah? Are we together? So you correct that, so this one will be negative, I think. Yeah? Like that. So 4sc, how will it be? 4 times a, which is 1, it is here. Then my b, sorry, my c is this 10, yeah? So it will be 40, not so? Out of 2a, which is 2 into 1. I want you to listen carefully. Hope I've not left anyone behind. So when you look at this one here, what do you realize? B squared is greater than 4sc, if you can see, because 25 is really greater than 24. Do you see that? That is nice. So what are we really getting? Remember, that is the discriminant, eh? So here we are having 5 plus 25 minus 24 is 1, eh? And the square root of 1 is 1, positive or negative. So here we shall be having the value as 3 all. Yes, we shall have the 5, but this time around the minus square root over 2. And this side this time around I'll be getting a 2 like that. Are we together? That is what we found. Then in this quadratic equation, guess what? I got 16 minus what? 16. What does this really imply? This implies that b squared was equal to 4ac. Are we together? 16 minus 16 is a 0, isn't it? You see that? So it is a 0. So what will I have? I will have, this will be a 4 plus a 0 over 8. Also, so I'll be getting my x as 0.5 if the math is right. Then even this side, if I say 4 minus 0 over 8, I will end up with the same what? Value 0.5. Are we together? Okay, we go to the next one. When you look at this 25 minus 40, what do you realize? Realize that this time round, the b squared is less, the 25 is less than the 40. Are we together? And guess what? And guess what? We are having this negative 5 plus or minus, and this is negative 16. Are we together? Over 2, something like that. Now, there is a topic called complex numbers. Anyway, let me not just go there. I'm going to just tell you the real thing. Before I go any further, are we together up to that point? You first tell me. I just want to make sure that I've not left anyone behind in whatever substitutions I've been making. Are we together up to that point? Do you get all that? The quadratic formula, where the discriminant is, the substitutions we have been making, the conclusions about the discriminant have been making, up to where the point we are. The first equation, what's wrong with it? People are telling me first equation. What is wrong with the first equation? Oh, you mean 6c. Okay. Okay. Mean this, eh? So this is 1. And then this is 2 over 3. Is that what people meant? But there are those who have been telling me that, yeah, we are there. I think I'm tired. Divide by 6. Okay, at that point, are we together up to wherever I am? Are we together up to where I am? Quadratic formula, 3 different equations, and the discriminant is behaving in 3 different ways. And there is something that I want to bring out. Yes, doctor. Okay, now this is it. When you look at these roots, they are different. Okay, so when they are different, that's what they call two real roots. That is one. So you've learned something. When you look at these ones, they are the same. So they are the same. They are the ones they call repeated what? Repeated roots. Okay, when you look at this, doesn't exist it. So what does that mean? No real roots. And if at all something doesn't have real roots, it has what they call complex roots. And we shall see that under the topic called complex numbers. And complex numbers, guess what? Complex numbers are one of the last 3 topics in senior 6. Okay? Because your topics of mathematics, they are 27. So you have topic 25, you have topic 26, you have topic 27. So these ones are flowcharts. Are you listening? These ones are DEs. I think these ones are the complex numbers. Yes, topic 25, senior 6 work. But me, I covered all that. So a serious student, immediately after this, you go to the senior 6 work and really cover complex numbers so that you know you have really connected work and you understand. Let me show you. I think there were 3 classes and we got done. It is senior 6. It is topic 25. Unless I just have a very bad memory. It is here. You see, topic 25, complex numbers. 26 DEs, the differential equations. The last topic, flowcharts. Differential equations, 4 lessons I got done. They are waiting for you all. Complex numbers, 3 classes. You see, I can even remember very well. 3 classes, me I got done. So I'm just taking my time to cover Form 5 work of Term 1 because even that of Term 2, Term 3 is there. So your role is just to sit down, you complete work, okay? Now, this is now the thing. For you to get 2 real roots every time, we should make sure that b squared is greater than what for SC? That's when 2 real roots can be obtained. For you to get repeated roots, it is only and only possible where b squared is equal to what for SC, because the square root of 0 will come in. And for complex roots, I'm saying complex numbers, if the roots cannot be real because you cannot have square root of a negative, so those roots are what? Complex. And I will teach that in complex numbers. And it is only and only possible when this is less than for what? For a C, like that. Yeah? There are people who always want to show that they know a lot of math. Do you know what they do? They be like, the right thing is that b squared minus 4ac, this thing should be greater than 0. But guess what? They have just carried this the other side. Even this one, they can really add cosmetics. May I call them cosmetics because you're wasting time. Like b squared minus 4ac is less than 0. Of course, this is supposed to be a 0 because you've left nothing there. You see that? So someone may be like, what did they mean in the syllabus book? Because the syllabus book is like, verify the nature of roots of quadratic equations using the discriminant. We have used the discriminant and we have described the nature, whether they are 2 repeated roots, whether they are 2 real roots, or whether they are the complex ones. So you just confirm to me that that is okay. Then I end the class. I've actually ended. Yes. The only thing that we are remaining with right now is you taking pictures for the assignment. But we actually done. So have you gotten the discriminant? Can you get on board and when you're given a piece of chalk, you can write for them the quadratic formula, give them those equations from your head. How do you get them from your head? You juggle with the discriminant and make sure your equation brings out what you finally want to. Don't cram mine. Sit down, get your own. Get the equation where b squared is the same as 4ac. You can generate it. Yes. You cannot get a number you can square and it is similar to a number you get when you multiply 4 by any other 2 values. That is very cheap. Can't you get where greater is? Can't you get where less is? Things like that. Very cheap. So can you handle the discriminant as the tutor, the way I've really handled it? We don't have access to that. Of course, that is premium work. So getting access to it, it's you pay for it. But we may see it on YouTube and it's not really accessible. That is so bad. Okay? But I don't know how long has really been this class. You first tell me. I think it's about 6 hours. Yeah? Goodbye, doctor. I saw you were already tired. You are very unfocused. Okay, now I think that is it. I don't think anything has been really forgotten. You people have said that things are now kawa. So, you take these screenshots. You do these numbers. This is assignment. Take a screenshot. I'm not going to give you time to take screenshots for the workbook because I want you to be taking your own notes. You look at what I've written, you reproduce it on your own, getting it from the head, not just copying it. So when you're doing these things, you see here they finally talked about the discriminant, and it is this one, and they are telling you it can be represented by letter D, discriminant. And you know what it means. You guys are now so good at it. Okay? Now, you see, these questions are telling you to find the discriminant, but I told you the discriminant is b squared minus 4ac. So like this question, you'd be like, this one is the value of A. This one is the value of B. And this one is the value of C. So when they ask for the discriminant, b squared, that is negative 5 squared, 25, minus SC, 3 times 2, that is 6, times 4, 25, minus 25. So the discriminant is 1. Do you see it? And they are like, since the discriminant is greater than 0, so that, do you see that these things are cheap? They are like, find the discriminant, and after getting it, state whether the equation will have 2 real roots, no real roots, or a repeated root. Can't you really do that? Do you see this summary that we are having? If you have a very keen eyesight, this one is the discriminant. So for 2 real roots, the discriminant is greater than 0. So those people are just wiseacring. Then here, still this one is the discriminant, and it is less than 0. Then here, the discriminant, if you look critically, the discriminant shall be a 0, because when I take this side, the other side will be a 0. So you see that when discriminant is a 0, repeated roots. Discriminant greater than 0, 2 real roots. Discriminant less than 0, complex roots, or no real roots. Are we together? You see, they're just playing with your mind. Nothing much. So when you also see this, now when you go to this, what will you get? We got a 0. And when the discriminant is the same as a 0, we have said equal roots. You can just say it has a repeated root or equal roots. When you go to the next one, you get negative 11. And then how do you conclude? It'd be like, since the discriminant is less than 0, then that equation has no real roots, or it has complex roots. Discriminant represented by D. What is the formula? That thing that is under the square root in the bulldozer, it is the discriminant. When it is greater than 0, you have realized 2 real roots. When it is equal to 0, repeated root or 2 equal roots. When it is less than 0, no real roots or complex roots. Very cheap work. You see that this was actually worth it to be ended with? You see? Now all these other things, they really come in revision. I may not have exhausted all questions and examples, but the work I've given is enough for you to, like this one. They're saying find the values of the constant k given this. And they are saying it has a repeated root. So for you, you're supposed to just understand that for a repeated root, the discriminant is what? Is 0. But you'd be like, the discriminant, you'd be like, this is the value of A, you see? This is the value of B negative 8k. You see this? And this is the value of C3K. Then you'll be like, oh, discriminant is 0. What is discriminant? B squared. B squared is negative 8K squared. You understand? Minus 4SC. What is A? 5K plus 1. Not so. What is C? 3K. But it has a repeated root. This is the discriminant substitution and it is equal to 0. Can't you get the value of K? You people, is there anyone here who can fail to get that value of K? You see that even if such numbers have not been done, but at least you know what a discriminant is. Even when I give you the notes, you can go back and really just chop everything and pass. I'm right? Okay. As I scroll, you tell me if that number has been understood. Just 2 people to represent the rest. Okay? I mean, these things are all okay. Very cheap. Okay? Oh, now these ones are in inequalities, eh? Yeah? This one is in inequalities. Provided you see any question dealing with range of values, eh? This one we shall cover in inequalities. Yeah? This one is now another topic. So this is not supposed to be covered today. Inequalities, eh? So you take note of that because they have the investigation table, critical table. If I start now, people will just run away. Yeah? Oh, even these things. Do you see? The moment you see between, just know those are inequalities. You all know that. When they do something like this, do you know that they mean that x values are between negative this and this? So those are inequalities. So we shall cover that when inequalities begin. And we also look at the investigation table. We see how things work. So inequalities, that's a topic on its own. Now we are going to go for the exercise. Sorry. So you're going to take a screenshot for the exercise. Then I say bye-bye. I don't know. Are people seeing the screen? Or it is off? So we are going to take the screenshot. So to do with the investigation table, that is inequalities. Unless people say that, doctor, we are sober. Let's just log off and come back for inequalities we cover. Or you can say, let's just mix. You label the class as quadratics and inequalities. Now, these things you're seeing, they are things, they look like scenarios, but they're also very cheap. You just apply what you've understood. And trust me, everything has been said. Now, anyway, anything that is remaining, if there is anything that is remaining in the topic, it is scenarios. But you, as you're doing the exercise, you pick what you can do. Hope people are taking screenshots. Okay. So you can see here they are saying this guy is quadratic equations, these ones that have power 4. Now these are the ones that you're going to go and research about, but these ones are there in polynomials. Those who watch the introduction of polynomials, you know what I mean. You'll find these things there. Polynomials are better. Okay, so when you see such things, polynomials, so I just tell you, go to polynomials and watch. The classes are there. I think polynomials, it is also term 1 of senior 5. Let me confirm. Senior 5, term 1. I think it is topic 2. Yeah, equations and inequalities, polynomials, 2 classes, lesson 1 and 2. You go and cover those. Yeah, you will enjoy. And there is also assignment for that. And I think we are using also the same book. So that's where you find. So do you see this sketching that I've been telling you? This sketching of quadratic functions or curves. We shall see that under differentiation, application of differentiation 1, curve sketching. That's where we shall find that. So that shouldn't be a concern. And then our next stop is that, simultaneous, linear, non-linear, and everything. So we shall enjoy the next time we are back. These things of sum and product, these ones we handled. all these things. We even took the screenshot for this. Yeah. Other equation, these things I told you for proofs, I told you they are not supposed to waste our time. Yeah, they are not, but they're also very cheap. These radical equations, these ones are covered under SADs. Okay, so in SAD, that's where we shall find these radical ones. Okay, let me see what else. Yeah, they also have exercise. There are those they call the systematic. Then the next chapter shall be polynomials that I've sent you to. But slowly, as we revise, the things will really get clearer. Okay, you first go with that content. You've really moved with enough content. Okay, so our next stop so research about proofs. But let me tell you, proofs are just obvious. They're just obvious. That one you should just trust me. Yeah, that one just trust me. Because even the way they set them, it is always very clear. And that one is just algebra. Let me tell you one thing as to why I really don't want to do proofs is that it is a wastage of time. Yeah, for example, let me show you this question in my book. Okay, this is the last thing. You don't be like, doctor, you're not ending. Why? They said, they gave you this equation, this bx plus c equal to 0. Are we together? Then they told you that the roots were actually alpha and beta as usual. That's what they said. Then they said, show that alpha this. Then they added on this plus 1. They said, show that one is c minus 1. This is squared plus b squared. Now, do you see such questions? They don't really have a principle. It is supposed to be you, the student, with that maternal math that can enable you to do such things. That's why you never see me waste a lot of time on proofs, because they never end. Let me tell you, I can talk to AI and I generate 1,000 proofs because I just sit down. I can even generate my own. Okay, so I don't usually waste a lot of time on that, but they are very cheap. You get, because now the things I've been teaching you. It's like now that question where they have been telling you, this is the equation, these are the roots, find a new equation whose roots are these, and as you're getting the product, you multiply them. You understand? So these things are very cheap. What do I mean? You're supposed to be like, what is the sum? The sum is b, not so? Because it is negative b. Then you be like, what is the product? The product, you be like, it is c. Are we together? Then you be like, these people are telling me to show that this is this. I just want to show you how bogus these things are and very cheap. So when you multiply alpha squared to multiply the other bracket, it will be alpha squared, beta squared. Then it will be plus alpha squared. Then 1 times the other bracket, we shall get beta that plus 1. Are we together? Then what are you going to get? This one will be alpha beta, like that squared, isn't it? This one, we all know that it becomes something like alpha plus beta squared minus 2 alpha beta. But it's having that plus 1, so you add it. You get? Then you come and substitute. That's how the proofs look like. So for me, I taught you the principle. So other things are supposed to be application of your own knowledge. So don't find such questions and be like, but doctor didn't talk about that in that class. Why didn't he really do that? I did. Okay. So this one you can see it is alpha beta, it is c squared, not so? Plus alpha plus beta, where is it? B squared. Minus 2 alpha beta, what is it? It is c. Then plus 1. Are you seeing where you are? Now you ask yourself, how am I really going to relate this to this? You get the point? Then you be like, in the question, I'm saying b squared. Even here, I'm saying b squared. Then you be like, Well, that means the whole of this balance is this. That's why I want to do this in revision. But this one's supposed to be concept overview classes. Do you see that it becomes very cheap? Do you see that it becomes very cheap? Hey, so you'd be like, oh, this one is c squared minus 2c plus 1, like that. And then the other side, I'm having plus b squared. And this is a constant. Okay? And let me tell you, everyone knows that this one is this. You don't even have to do anything. You just switch. Because I told you there is a shortcut to multiplying this thing. What did I say? First square the c, right? C squared. Square the -1, make it +1. Then multiply this 2 times this c times this -1, then get minus 2c, which is here. That means if at all you can move from here to here, that means you can also move from here back to here in one step. And then you've reached what those people want. So you people, you tell me, that number I've put as an example for you to make research about the proofs. I've realized how obvious they are. Do you see that they don't really have a technique? They can change. They can remove B and put Q. They can remove C and put R. You understand? They can change those things they are multiplying to some other things that have power 3, that have power 4. So you just need to be that person who can play with the alpha and beta, especially the other things I talked about, where the square root comes in, where those other things really come in. And then you get the point? So you promise me that the research questions shall also be obvious. People are thanking me, they want to go away. For me, I'm still here. So will you be in position to do that? Will you be in position to do those proofs? Do you see that they are obvious? You just make sure the left really becomes the right. Very cheap. I see people struggling with trigonometry proofs. I be like, now this one. Very irrelevant work for now. First understand basics. Those ones you just even handle them in the last minutes of senior 6. Be like, oh, these proofs were as easy as this. But trust me, when you've captured the concept, they really become so easy in the end. Are we together? Yeah. So, I think I've said it all. Yes, some refuse. That's why I tell you that I'm not supposed to waste a lot of time on them. And you also don't need them. But when you over practice, time will reach and they are just okay. Okay? So, our next stop shall be linear and simultaneous. Linear and simultaneous equations. And then maybe also inequalities. Inequalities, these ones I'm quite sure. These ones I'm quite sure that they will strictly be premium. Yeah, premium is not very expensive, but for the simultaneous equations, these ones we shall study, don't worry. I'm not sure, either premium or free. It will depend on what the board of governors of Science Scholars Academy will decide. Okay, so I think you should allow me to officially sign out as Paul Tutor. Yeah, one of the tutors of science and math at Science Scholars Academy. Okay, abbreviated as SSA. Visit our channel, subscribe, visit our Google profile, reach out. The contact is 0753279592. Academic changing contact. Okay, so that is it. Do I have any people with any concerns, anything you're asking? Or we are good to go? Okay. Let me allow people take some screenshots for today. So those who don't need the screenshots, you can go off in peace. Thank you for attending. Thank you for thanking me for the classes. Music break, I never do that. I never do that. Music break, go to TikTok. This is not a disco. This is a serious academic academy. Okay, take that. I don't think I've left out anything. But please make sure you do assignments. And let me tell you, you're supposed to learn math by doing math. And you're also supposed to share these screenshots to your friends in the groups that have not attended the class. Hope I'm communicating. Take that. So I'm also going to give you more numbers because you learn math by doing math, as I've said. So you stay on, you're going to take screenshots of more numbers. You try out, I told you to form discussion groups, things like that, things that really make you active academically. Concentrate for the 2 years and then, yeah. If at all you're on and you really want me to say something, yeah, you really want me to talk about something, you can tell me. You can tell me, I tell you something about it. You may be going through something. You may be having a challenge. I'm the answer. Hope people are taking screenshots and I'm not just wasting my precious time. Discriminant, especially discriminant. Completing squares, alpha, beta, that's a lot of work. Then the quadratic curves. Actually, the lesson has actually been worth it. It has actually been worth the time. People seeing the screen. Let's see if we can also get some good numbers from here. Equations are so many, eh? So I need to also give you too many so that you can practice. What is this? Surds and indices. Oh, these are very good numbers. These are logarithms. Simultaneous equations involving these are surds. Let me see. Now I think like this number, very cheap. They are telling you from the equation roots are these because you know this formula. I gave it. So you add them, you understand, and multiply them. Then you do what? Substitute. Even these ones. Add them, put here the sum. Multiply them, put here the product. Very cheap, eh? Yeah, you just enjoy. This book is serious. This one has serious work. Don't come here if you're biased. You'll be shocked. Let's look for the exercise. These numbers are good, eh? Very key. These ones are very key, very high yield. You first take the answers are even there, so you can struggle. About proofs, I've already hinted about that. Okay, so you can take that. You see, there is even power 7, but I told you how to deal with LCM. But these ones are miscellaneous. You do with a friend. You take that up to number 7. Yeah, in your free time. But they are serious. Miscellaneous. Disclaimer, you can ignore. First take number 8 alone. See, this is mathematics for an A-level student. Actually, it is for a serious A-level student. It has only had numbers. For those who always think that they have actually made it in math, numbers are here. Let's take that number 9 to number 10. Show you where you see ranges, those are inequalities. Now this one you can first try. I've told you that alpha and beta, they are the roots of this equation. There is even kx. So they are saying, show that the equation whose roots are this is this. There are things I've been teaching, even the answers are here. You struggle. Okay? Yeah, they're saying obtain the quadratic equation for these roots. Answer is here. Try. Struggle. And this is a unable number actually. So where there are unknowns, whether the originals, you can just try everything. It really works out. Yep. You know what to do. So even when there are unknowns, the answer will have unknowns. Let me tell you, math has so many numbers. But always just try your level best and tell God, if I get the concept, even if I don't understand anything else. So you struggle. You take those. If alpha and beta roots of that, express that in time. Now you see this one, you see? You play with alpha and beta. Get things from here. Come and handle this, then come up with this. The things I told you. Just play with your mind. Given that this one has these roots. Express P and Q in terms of alpha and beta. That is alpha plus beta, alpha, beta. Then they want the equation whose roots are these. Then the answer is here. But this one is for purely unknowns. So the answer will be the same. Yeah? You just don't need to worry about that. Someone will be like, how am I really going to do that? For us, we have been doing things that have knowns only. So when they involve unknowns, just know it is the easiest. You understand? I did for you something to do with the unknown. That is what you do. The final answer will have those P's and Q's like you can see. Like the one we did and it remained with the B's and C's. But in case you find a challenge, you know the people to consult. Okay? But these ones are miscellaneous. First do the other ones in the book. These ones you may hate math. These ones you just need to do to confirm that the topic I know. And even fear this book. Also take that. But I told you when you see something like inequality, that will be another topic. Okay? But don't ask me for this book. Very hard book. I just want you to experience that math is really hard. That's why it's my first time to even bring it here. Because equations, people think they are easy. Now you go and look into that book. You will see what they call hard work. You see that you have actually been joking. I think these are polynomials. You see, miscellaneous. Those ones I've told you, when you go to polynomials, you will enjoy. This is a very good book, eh? Though it needs to come here when you have really perfected the math. By the time you come, you're just perfecting everything. I think I'll also be using it to give you some hard work at the end. You can see it's having some good work. But this series, these ones we also covered. So you create time, you go and watch and enjoy, okay? I can see there are people who are checking on us, thinking we have actually stopped. My dear, we are still here. So series, I think it is term 3, term 3 work, senior 5. It is topic 13. You see it is here. AP and GP was taught. So AP, you go there and study. GP, you go there and study. And that is it. So people, I think I should finally sign out. I don't see any concern in the chat about anything that people may want me to talk about. How to manage academic stress. You complete the syllabus in senior 5. So as of now, you just take on the stress, complete the syllabus in senior 5, have a full year of senior 6 to cover all that work. You won't really be surprised. What's the appropriate time of rest for an A-level student? Minimum 5 hours, minimum 4.5 hours, maximum 6 hours. You shouldn't go beyond 6 hours. If you go beyond 6 hours, it is healthy, but putting you in danger academically. If you sleep for less than 4.5 hours or even less than 5 hours, that is really very bad for your own mental health because you even need it after senior 6. Secret for passing in the new curriculum, completing the syllabus in senior 5, matters complex stuff, especially the proof part. Okay, but the rest of the things are really okay. And all I know, the new curriculum setting is not supposed to have a lot of those proofs, more of application. And proofs are, yes, proofs are application, but they are not so important as other things. Let me hope we are together. So BCM versus PCB, I told you this, the reason behind all those rumors you've been hearing. But biology and chemistry cannot be really ignored for health sciences. They are very key. Yeah, so that is it. Any other concern? Any other concern? Any other concern? Thank you, doctor, for your time. Welcome, Achen. So if there is any other concern, I'm giving you a few seconds to say the concern, I address them. Not really, I guess. Okay. Maybe other concerns, people can bring them through WhatsApp. People maybe don't really have problems, but maybe to talk about other subjects, physics, anytime now we are introducing statics and we are pushing heat, we shall be introducing heat quantities. Yeah, that is of course calorimetry. We are done with thermometry. Then biology, I've told you we are going to cover microscopy, just be on set. Then chemicals of life, we are also going to push it. Then chemistry, a lot of work was covered already. We just have a few things like radioactivity, things like mole concept, of which you have there a collection that is enough for you to go into other topics. Then also maybe structure and bonding, but those shall be covered in the holiday. Maybe those who will be listening to this months after, years after, all those classes shall be there, either on YouTube, if premium, everything shall be communicated anyway. Okay, I think I'm also tired. Yeah, that's what I can say. I'm extremely grateful. You have a school you teach. No, I don't teach any school. If I'm not at SSA, I'm at the hospital, Mulago Hospital. Yeah, I don't teach any school. I don't teach any school. I'm a medical doctor, passionate about educating the young generation. So if I'm not here, I'm at Mulago Referral National Referral Hospital. Out of finishing this syllabus in Singapore without perfection, you will fail. You're supposed to perfect. While not memorizing, that is failure. It's not enough for moral concept. It is enough. I'm telling you facts. There is no topic you need in the future that we did. The practical chemistry doesn't need any of what I talked about, and it is enough. Mole concept, the remaining part is in equilibria 1, which is also senior 5 term 3. So you have all that work. So when I say it's enough, I know what I'm talking about. Okay. I think we shall really meet next time, inshallah. So people, bye-bye. Any other concern before I go? Bye. We shall meet in the channel, in the premium groups and other groups for interaction. Bye-bye.